Hello there, you beautiful people, and welcome to the Python Bible. Now this is just a quick video to let you know what you can expect from the course and how it's going to be structured. So what makes this course awesome? Well, one great benefit you get from this course is that it's project based. Instead of listening to me ramble on forever, you're going to be actually applying your newfound skills to cool projects that you can show your friends. You'll build a total of 10 fun projects in this course, and there'll also be quizzes and coding challenges scattered about to make sure you're getting frequent feedback on how you're progressing. We're going to start off by getting you all set up with Python, whether you're using Windows, Mac or Linux, so you can follow along with all the programming goodness. You'll also be introduced to idle, the main interface we'll be using to program in Python throughout the rest of the course. Once you're all set up and running, we're going to move on to variables. Now variables are like little boxes in your programs that you use to store data. You find them everywhere in programming and they are absolutely key to doing, well, anything. So that makes them a pretty good place to start. We'll then move on to learn how to use numbers in Python. Numbers are absolutely everywhere in programming, and if you learn this section well, you may never need to do maths ever again. In this section, we'll also meet our very first project. We'll be using numbers to create a health potion for an imaginary video game. Pretty sweet, right? After that, we're going to move away from the world of ones and zeros and learn how to manage text in our Python programs in order to create customized and meaningful experiences for our users. We'll be using this knowledge to ask our users a bunch of questions and then write a piece of text all about them. We'll also learn about how to slice and dice text and apply this to an email slicer project. By the way, no emails were harmed in the making of this course. By this point, we should have the basics of programming down, but if I know you, you're going to want to take your abilities to the next level. This is where logic comes in. Logic allows your programs to do multiple actions depending on the situation that they're facing. If anyone asks, just wink and tell them you're learning AI. Now after that, we will make our programs more sophisticated and learn about how to use Python's awesome data structures to help us deal with large amounts of data. We'll start off by making Travis, the ridiculous security system. Travis will have a bunch of known users, and if he detects an intruder, he will tell them to stop, and then ask them if they'd like to come in. We'll also be making a cinema simulator that has a bunch of films with their age ratings and number of tickets still available. When someone comes to buy a ticket, the program will check that they're old enough and that there are enough tickets left. And if they are, then they'll let them buy the film. Now we're talking, right? Then we're going to learn all about loops. Let's face it, some things are just repetitive, but that doesn't mean you have to do them. In this section, you'll learn how to use loops to make computers do stuff over and over and over again, but by only typing it once. For the projects in this section, we're going to use loops to simulate an annoying conversation with a 3-year-old child, and also to make a translator that will convert any sentence into Pig Latin, a funny language meant to confuse and amuse. After that, we're going to learn about creating functions in Python. Functions are ridiculously useful, and we're going to use them to create a game of tic-tac-toe, or 3 in a row, or XO, or whatever you want to call it. You've definitely played it. Then finally, we're going to learn about object-oriented programming, or OOP, in Python. You'll learn all about classes and objects, and use this information to create a set of coins and even your own bank. Now if that all sounds like fun, then I won't keep you waiting any longer. Let's get you all set up and running with Python. Hello there, you beautiful people, and welcome to this video where we're going to get you set up and running with Python on your wonderful Windows machine. Now if you aren't running Windows, but are running Mac or Linux instead, then feel free to skip this video and head over to the installation video that's appropriate for you. But if you are running Windows, in this video I'm going to walk you through the installation step by step, and by the end of this lecture you'll have Python 3 fully installed and ready to go on your machine. So let's do this. Right, so first of all, fire up your favourite browser, mine's going to be Google Chrome, and head over to www.python.org/downloads. And when you hit enter, you should see a page like this that pops up. Now you can see here that we have two options available to us. The Python website gives us the option to install Python 2 or Python 3. Now for this course, because we're all modern and updated, we're going to be using Python 3. So go ahead and click on that button to start the download. Now at the time of this recording, version 3.5.2 is the modern version of Python 3, but if you have a more updated version, don't worry, everything will work just fine, so go ahead and download whichever version is appropriate for Python 3. Just wait for that download to finish, and then launch the installer like you normally would for any other program by double-clicking on it. When you launch the installer, you'll see a window like this pop up. Now the first thing I want you to do before you do anything else is to click this checkbox that says Add Python 3.5 to Path. Boom. Alright, once that's checked, I want you to click this Customize Installation button. We're going to go hardcore, you guys. Now, you'll see that we have some default options already checked for us in here. Don't worry about these for now. Just go ahead and click on the next button at the bottom. Now, once you're on a screen that looks like this, I want you to make sure you check the button that says Install Python for all users. The reason that we're doing this is because it makes the install location for Python much easier to deal with later. Once you've checked that, you can see that the install path that's shown in this box changes to be much nicer. Once that's all done, click the install button. You'll have to say yes when the pop-up arrives to ask for your permission, and once you do, the install will begin. Just wait for the installation process to complete. It should take around 30 seconds or so, and it should be all set up to use Python on your Windows machine. Congratulations, that was easy, right? Now, just as a quick check, I want you to open up something called the command prompt. Go to the Start menu and type CMD and run the program that comes up. Next, when you're in there, type Python, all in lowercase, and press Enter on your keyboard. Some text like this should pop up, which means Python is installed. Congratulations! Go ahead and close the command prompt window. So by this point, if all has gone well, you should now have Python successfully installed and set up on your Windows machine. Well done! In the next lecture, we're going to jump right in and discover an incredibly important tool that comes with Python called idle. Many congratulations once again, and I'll see you in the next video. Hello there, you beautiful people, and welcome to this video where you'll get up and running with Python on your lovely Linux machine. Now, if you aren't running Linux, but are running Mac or Windows instead, then feel free to skip this video and head over to the installation video that's appropriate for you. But if you are running Linux, then I'm going to walk you through the installation process step by step, and by the end of this video, you'll have Python 3 fully installed and ready to go on your machine. Let's go! Now, on most modern distributions of Linux, such as Ubuntu, Mint, and Fedora, then Python is pretty much already installed on the computer by default. Such are the perks of an open source operating system, right? Now, just to check, open up a terminal window and type the following command. Python 3 -- version. If that returns text saying Python 3.5.2 or newer, then that's it. You're already done. Feel free to skip this video and just move on. You can type Python 3 to get Python to work in the command line here on out. But if it gives you some older value that's a bit earlier than 3.5.2, then just type sudo apt-get upgrade if you're on Ubuntu, or dnf upgrade if you're on a Debian-based distribution, and that should take care of the whole process. But if you get an error saying that Python 3 isn't installed or something like that, then we're going to need to install it. But it's pretty straightforward. Just stay in your terminal window and type in, if you're on Ubuntu for example, sudo apt-get install Python 3. But if you're on a Debian-based system, such as Fedora, then type sudo dnf install Python 3. And that should pretty much take care of it. And there you have it. If you can type Python 3 on your command prompt and not get an error, you're pretty much good to go. In the next lecture, we're going to jump right in and discover an incredibly important tool that comes with Python called idle. Many congratulations once again, and I'll see you in the next video. Hello there, you beautiful people, and welcome to this video where you're going to learn about an incredibly important tool that comes pre-packaged with Python called idle. In this lecture, I'm going to introduce you to what idle is, and I'll be showing you a few useful things that you can do with it. Be sure to follow along and try things out for maximum learning. But by the end of this lecture, you'll know what idle is, how to open it, and how it can help you when programming Python. So what's idle? Well, idle is basically the program that we're going to be using to write Python code. But more precisely, idle is Python's very own interactive developer environment, or IDE. And what's an IDE? Well, that's just a fancy word for a useful text editor that makes it easier to program in a certain programming language. So idle's Python's built-in IDE. And what we're going to use idle for is to run Python programs and write files known as Python scripts. Now don't worry if you don't know what they are, we're going to see plenty of them as we go through this lecture. But for now, let's just learn how to open idle. Alright, so if you're on Windows, just go to the Start menu and type idle in the search bar. There'll be a similar way to do this on Mac and Linux, so if you're on either of those, don't worry about it, it's pretty straightforward. Just click on the icon that pops up to open idle. If you see a window like this, then congratulations! You've successfully opened idle for the very first time. So let's have a quick look around. The most obvious thing that we see on here is this big box with some official looking text at the top. Now this box is what's known as the Python shell. Strange term, shell, but it's likely familiar to people who use Mac and Linux regularly, but it might be unfamiliar to those of you who are using Windows. But for now, just understand that whatever you type here will be interpreted by Python as a command. Along the top, you'll see the sexy idle toolbar. Okay, and there's two main options I want to show you at this point. I'm not going to deep dive into everything. First of all, we have the File tab. Now in here, you'll notice you can create new files, you can open files, save files, amongst other things. These files that idle is talking about are what are known as Python scripts. We'll be creating one of those in this video, but let's continue to explore idle's toolbar for now. So the second thing that I want to show you is under Python's Help tab. You'll notice that under this tab, there is this option here that says Python Docs. Now this documentation is incredibly useful and is also available at https://docs.python.org/3. You can just Google Python documentation, it'll come straight up. Oh, by the way, the reason my text is absolutely massive is because I've made it this big so it's easier for you guys to see on the video. If you want to have it this size or something similar, then what you have to do is just go up to Options, Configure Idle. This thing will pop up, and I just picked the Lucida Sans, probably saying that all kinds of wrong, but the Lucida Sans type and size 22, and that's why it's so big. So if your text is much smaller, that's because you got the defaults and nothing's broken, don't worry. But that's enough faffing around for now. Let's actually do some programming, shall we? Right, now let's look back at the Python shell, this big thing here with these three arrows. In this shell, we can run what are called Python commands. For example, if I type 1 + 1, you know we're going to start complicated, in this shell and press enter, Python gives me back the number 2. Pretty cool, right? I want you to give that a go. Just pause this video and give it out a try for yourself. Type in the shell 1 + 1 and press enter. Don't worry, I'll wait. Okay, so hopefully you gave that a go and you got similar results. If you did, then congrats, that was your very first line of Python code. Give yourself a pat on the back. They won't always be that easy. So what you just did was an example of a Python command. You have the command of add together 1 and 1, and Python shell interpreted your command and gave you back the answer 2, or returned the answer 2. So that's pretty cool, right? But the issue here is, what if we wanted to do this command over and over again, or we wanted our code to be reusable? It's kind of a pain to do that at the moment, right? I mean, like, if I wanted to use this, I'd have to go up here, copy it, and then maybe paste it on here and press enter again. I know it's only 1 + 1, but you get the idea. Well, to make our code reusable, we use Python scripts. Python scripts are files that we can store commands in. And scripts are just like scripts in real life, right, that actors use. You read them from top to bottom, and you can read them over and over again. They can also be copied, pasted, and moved around, and even shared with your friends. In fact, it's possible with scripts for someone on the other side of the world to get a copy of your code and be able to run it and get exactly the same result. Talk about high tech. So let's go ahead and create a Python script. To do this, we go up to Python's sexy toolbar, and we press File up here. And then you can see this thing that says New File. There's a keyboard shortcut of Control+N for those of you who would like extra speed, but I'm just going to do it this way. And what you'll see is you get this window pop up. It's different to the shell, but anyway, this is the editor that you use to write your scripts in. At the minute, you can see it doesn't have a name, so the first thing I'm going to do is I'm going to save it by going File and Save, or Control+S for a keyboard shortcut. So you press save. Now I'm going to make a new directory or a new folder on my desktop. I'm going to call it Python Bible, which is where I'm going to store all our stuff. So Python Bible. And in there, I'm just going to save this file as meeting idle. Right, so meeting_idle. Now, so this is something very important, okay? Whenever you save a Python script, you must make sure that the file has the .py file extension. Otherwise, the Python just won't know how to run it. Okay, forgetting the .py file extension is a common mistake that beginners make. I mean, it's so easy to forget, right? And it causes all sorts of pillaging, destruction, and ruin. So don't let that happen to you. Whenever you create a new script, just make sure it has that py file extension. You have been warned. Okay, so I'm just gonna put that right there. So now we have a beautiful, pure, angelic little script. And what you can see on the script toolbar panel, you can see this button here that says Run. If we click on that, you'll see a drop down, and down here it says Run Module with a keyboard shortcut of F5. What we can do is we can click that, and it's going to run that script. You can see the way that it started here, but nothing happened. Well, that's great. There was nothing in the script, so we didn't expect anything to happen, really. But now the next bit is totally badass. Okay, watch this. If I just pop over back into the script, okay, now what we can do is we can type 1 + 1, exclamation mark, 1 + 1 in here, and save that. Okay, now when I run it, well, nothing happens again. Well, this is another common mistake that can happen when using Python 3. In Python 3, when using scripts, we need to do something to actually print the answer on the screen. And for this, we use the print function. Okay, so in here, instead of just typing 1 + 1, I can type print, open brackets, open parentheses here, and put 1 + 1 inside. And when I run that, save and run it, ta-da! We can see the number 2 pop up on the screen. That's sick, right? But the cool thing about this, the thing that's really cool, is the fact that I can go over here and I can run this as many times as I like, okay? And there's not copying and pasting, there's none of that, okay? It will just run the same thing over and over. But the good thing is as well, you don't just do one-line commands, okay? You can add more than one line. So on here, let's say if I did print, I don't know, 105 + 10, okay? And I save that. Now, when I run it, you can see the way that it first did the command we had before, and then it gave us 115. What that means is, it ran the first line to get 2, and then it ran the second line to get 115. So what you can see is happening is, it's going from the top, and it's going all the way down. Okay? So you can make scripts as long as you want, and they will run from top to bottom, and they will run the same every single time. It's pretty neat, right? Now, if you've been following along, typing along, then congratulations! You've officially written your very first Python program. This could very well be a great moment to share on social media, get a few likes, get a few retweets. But either way, this is amazing. It was only a few moments ago that you'd actually installed Python, and now you're already set up and have ran your first Python program. Well done. Let's just have a quick recap to see how far you've come. So in this lecture, we introduce you to Idle, Python's built-in interactive developer environment, or IDE. Idle is the tool that we will be using to write Python scripts and Python code for the remainder of the course. We then had a quick tour around Idle, its menus, and we jumped right in and started off typing some Python commands into the Python shell. Just the simple 1 + 1 command, right? Now that was alright, but we noticed it was a bit limiting. It was great for one-off things, but it's a bit of a hassle if you want to repeat things or share your code. So this is where we started using Python scripts. We made a folder and saved a script in it, making sure not to forget the benevolent and glorious .py file extension, without whom the whole Python world would descend into utter chaos. For real, no scam. Then we wrote some commands in the file, using the print command, and ran it. And Python shell interpreted all of those commands in the order that they're typed and gave the output that we wanted, which in this case was 2 numbers. Remember, when we wanted stuff from scripts to show on the screen when using Python 3, we needed to use the print function. We'll cover the print function later on in the course, but for now just focus on the way scripts work. And awesome! We now have a reusable script. All in all, this is amazing. We've officially written our first Python program, and we're well on our way to becoming great Python programmers. Actually, in the next video, I want to share with you a best kept secret of top programmers, which is going to blow your mind. If you learn this secret, you will save countless hours of time and headache, and programming will be a whole lot more fun. I honestly can't wait to share it with you, so I'll stop here and I'll see you in the next video. Hello there, you beautiful people, and congratulations on getting Python set up in the last section. I'm really excited about getting started with all the amazing Python goodness that's in store for you in this course, and I hope you are as well. Now, in the last section, we managed to print some numbers to the screen by running our very first Python script. While that was cool, I'm wondering, how can we save the answers that Python's shell gave us back? You know, in case we wanted to use them for later. Well, for that, we're going to need variables. In this section, we'll be talking about the fundamental concept of variables in Python. But before I get into all that, let's just take a step back and get an overview of what we can look forward to in this section of the course. For those of you who feel like you have a very good grasp of variables from using other programming languages, feel free to skip this section if you like. However, if you're new to programming, or just fancy a bit of a reminder of what variables are, then you're going to have an absolutely great time with this section. First off, I'm going to explain to you what a variable is in the simplest terms possible. After that, we're going to jump right in and create our very first variable and see what we've learned working in action. Then we're going to have a discussion about variable types, which is going to broaden your horizons about what's possible in Python and also give you a taster for what's to come in the rest of the course. And just to make sure you've really got everything, we'll close the section with a review lecture and then jump into a quiz and your first coding challenge, just to really cement in that learning. And once we've learned all about variables in this section, we're going to move on to the section afterwards, which is all about numbers, and we're going to combine our knowledge of variables and numbers to create a health potion for an imaginary video game. So in summary, in this section, we're going to introduce variables and variable types and give you plenty of practice to get this extremely important and fundamental concept down, and follow up by testing your understanding with some quizzes and friendly coding challenges. So without further ado, I'll see you in the next lecture to welcome you to the world of variables. Hello there, you beautiful people, and welcome to the world of variables. Variables are an incredibly useful concept in programming, and they help us store information in our code and generally just make programming a whole lot simpler and a lot more fun. So making sure you understand what variables are is going to open up a whole world of possibilities to you. So let's get cracking, shall we? In this lecture, I'm going to use an easy-to-remember analogy to explain to you what variables are in everyday terms, and I'm also going to explain to you why variables are so useful in our Python programs. After you've gotten the fundamental understanding down of what variables are, we're going to jump right in and create a few variables of our own to see how they work in real-life practice. By the end of this lecture, you should have a good grasp of what variables are and also how to create them in Python. You'll also understand how to find a variable's type, and you'll also learn how variables in Python are different from variables in other programming languages such as C or Java, for example. All very useful stuff, so let's get into it. So what are variables? Well, I want you to think of variables as little boxes. And just like regular normal boxes, variables can store stuff. In our computer programs, the boxes store certain values, also known as data. This data can be anything from numbers and words to videos and images, but the cool thing about variables is that they all have a uniquely identifiable name, and we use this name to see what's in the box, i.e. to get the data. So now that we're thinking of variables in terms of little boxes, let's go ahead and actually create our first variable. Now in Python, just like in every other programming language pretty much, a variable has two things. It has a name, and it has a certain value. So if you think of a variable in terms of a box, the name is the name or the text you write on the outside of the box, and the value is what you put inside it. Okay, now the first thing we need to give is our variable a name. So for this instance, let's just call it number, and all we have to do is just type in the name there. Now to put a value inside that box, we need to assign the variable a certain value. Okay, so the way that we assign a value is to use the assignment operator. Makes sense, right? Now it sounds really fancy, but the assignment operator in Python is simply just an equals sign. And now let's say we wanted to assign the variable called number the value of 1. What we would do is we'd type the number 1. Now what you can see here, let's break it down. We're saying let's create a box with the name number and put inside that box the number 1. Or assign that box the value of 1. Pretty straightforward, right? Now what makes this useful is that when I hit enter, you can see that we've gone to another line, as you can see by these 3 chevrons, these 3 arrows here. What has happened is, whenever I type number into the shell or into our program and press enter, we get back the number 1. By typing the variable name, we have looked inside the box and taken the value inside the box out. This allows us to store the value for later in a very convenient and easy to remember way, and that's what makes variables so powerful. Now there's something very important that you need to keep in mind when working with variables in Python, and that's that the variable names are case sensitive. So for example, like here when we type number in all lowercase, that worked. Okay, we got our value 1 back because we defined it all lowercase up here. But if I tried to type number all uppercase and press enter, we see that we get what's called a name error, saying number not defined. And what that means is Python basically couldn't find a variable with the name number in uppercase because we never defined it with that name in that case. So when you use variables in the future, just make sure you spell them exactly the way that you define them, because this trips everyone up once in a while, okay? And another thing to bear in mind is that in Python, variables are dynamically typed, or Python is a dynamically typed language. Now, what the hell does that mean? So let me just break it down. Each variable can have a certain type, and you can find that by using what's called the type function. So if I type type and number, it'll tell me it is an int or an integer, which is just a fancy word for a number, okay? Because it holds the word, it holds a number variable type. Now, when I say the Python is dynamically typed, that means the type of our variables can change. Now, this is different to other programming languages like Java and C, which are statically typed. In those languages, you have to say what type of data this variable is going to take when you define it. In Python, you don't have to do that. Basically, you can change the type of data that goes inside the box. So to give you an example of this dynamically typed nature, let's take our variable called number and assign it the value of hello, for example. I know that's quite confusing, but let's do it anyway. Now you can see that we didn't get an error. Okay, hello is a type of, well, it's text, isn't it? It's what's called a string data type. If we look at the type now, it will tell us that the class is str or string, which is basically just text. Now the fact that we could do this and basically overwrite our variable with a completely different data type is what I mean by dynamically typed languages. Statically typed languages don't allow you to do this. The reason this can be confusing is if I looked at someone else's code and they used a variable called x, for example. I don't know whether x is a string or it's a number or it's an image or whatever else it is, because it's a pretty bad name. But if they called it image or something, then that would make it a lot easier for me to know what went in that place in the code. So by making sure that your variables have good names, you're going to basically get the best of both worlds. You're going to be able to take advantage of Python's dynamically typed nature, and you're going to avoid the drawbacks of having confusing, ambiguous code. We covered quite a lot in this lesson, so let's take a quick recap to make sure that we've got everything. First of all, we introduced you to what variables are and said they were basically like little boxes in our programs that store information. Each variable has a name and is assigned a certain value using the assignment operator. Python's assignment operator is the equals sign. Remember, what's on the left of the equals sign is the variable name, and what's on the right hand side is the variable's value. That's what's stored in the box. We then went on to mention that the information that a variable can store has a certain type, such as a number or text. Because Python is a dynamically typed language, this means that the type of data that a variable holds can change dynamically. This is different to other programming languages like Java or C, which are statically typed, and that means the variable type is defined upfront and cannot be changed. It's static. We also created our very first variable and retrieved its value, which was pretty cool. We also use the type function to find the variable type that our data is. And Python told us that number was a number. Perfect. So now that you've got the concept of variables down, we're going to go ahead and apply it in a real-life example in the next lecture. I can't wait to show you, so I'll see you in the next video. Hello there, you beautiful people, and welcome to this lecture where you're going to supercharge your understanding of variables to a whole new level. After getting an introduction to variables in the last lecture, we're now going to go ahead and use them in a real example. Make sure to follow along for maximum learning. In this lecture, we're going to make our previous code a lot more organized by using variables. In this way, you get to see a before and after example to really understand why variables are so useful and why using them is much better than what we've been doing before. Let's go! Okay, so the first thing you're going to want to do is boot up idle, and once you've done that, head over to the File tab and click Open. Now, if you've made a file directory like mine, It's going to be on the desktop, so I'm going to browse there, desktop Python Bible, and here we are, meetingidle.py. So if I double click on that, well, hey, there we are. That's the code that we made a few lectures ago. So let me just maximize that. So let's run it again to get an idea of what this script does. As we can see, the script prints out the number 2 and the number 115. This is all good, but what if we wanted to keep those numbers for later? Well, for this, we're going to need variables. Remember, variables are like boxes, so we can put the value inside the box and keep it for later. Let's say we wanted to call our first number the imaginary name of first number. The way we do that is we'd get rid of this whole print function here, and we'd type first number with an underscore, then equals 1 plus 1. So what's going on here? Well, in the middle, we have our assignment operator, the equals sign. On the left-hand side, we have our variable name, which is first number, and on the right, we have 1 plus 1. 1 plus 1 is what is called a Python expression. Python is going to evaluate the expression, basically find out what it is, and then store the result in the box called first number. What this means in plain English is that Python will do the calculation on the right and get the answer 2. Then it will store the answer 2 inside the box called first number, or inside the variable called first number. We can then use the variable name to refer to this value at any point in the future. So what we can do is instead of print 1 plus 1, we can just use print first number. Here, Python will look inside the box called first number and find the number 2. And it will then print the number 2 to the screen. So you can see we get exactly the same answer as when we just printed the answer directly, but by using variables this time. We can do this for the second value, and let's call that the equally imaginative name of second number. So what we do, we get rid of our print function and type second number equals 105 plus 10, making sure to get rid of that trailing bracket there. So Python is going to evaluate the expression on the right-hand side and get the result of 115. The value of 115 will be stored in the box called second number. And now when we use the print function, but put second number inside it, Python is going to see what's inside second number, it's going to see the number 115, and print that out to the screen. We see exactly what we saw last time, it works just as expected, and both numbers are printed on the screen just like before. If you got exactly the same as me by following along, then well done, you're basically becoming a boss at using variables. I just want to make a note here about naming variables. Sometimes variables have long names, and they contain multiple words like ours do. There are multiple common ways to name variables in programming. For example, there's camel case, which looks like this, or there's another type of camel case, which is like this. However, the most common way to name variables in Python that have multiple words in them is just to add an underscore in between each word, like we've done here. There mustn't be a space in your variable name, so we can use the underscore instead. It's common for a variable to be all lowercase in Python, so we'll use that style going forward in the course. Having a common style for naming variables isn't required, but it makes your code a whole lot easier to use, and a lot easier to read as well, and it stops you making as many errors. Oh, one other thing I should mention is that variable names can't start with a number. For example, I can't create a variable like this, but I can type this, because this starts with the letter A instead of the number 1. This is just something to bear in mind as you name your variables. Just make sure they always start with a letter. Now, with that out of the way, what makes using variables any better than just typing out the value? I mean, our program works just the same as before, right? Why bother making variables? Well, imagine if we wanted to do some calculations and add the answers together. We might make a variable called total and set that equal to the first number plus the second number. Now, when we print total, what we're going to see is 117 come up, because 117 is 2 plus 115. So what happened here? Well, let's break it down step by step, although it may very well be apparent by now. Python sees that it needs to evaluate the expression on the right-hand side of the assignment operator here and put the answer inside the box called total. The first thing Python sees is the variable called first number. Python looks inside that box and sees the number 2 inside. Next, Python sees that it needs to add whatever's in the box called second number. Python looks inside the box called second number and sees the number 115. So now Python knows it needs to add together 2 and 115. It does so and comes up with the answer 117. 117 is then stored in the box called total. And finally, when we use the print function, Python looks inside total, sees 117, and prints that to the screen. So that's what's going on pretty much in the entire program. So as you can see, by creating variables to store important information, we can make our information much more reusable and easily findable because we can give it very convenient names. Also, look at how much easier it is to change our code. If we wanted to add 5 to the first number, we can do that. And when we run our script, we see that not only the first number changes, but so does total. By using variables in this way, we can actually, by just changing 1 or 2 lines of code, create massive changes all the way through the rest of our program. Now, everyone loves a shortcut. So there we have it. We've learnt all about variables and used them in a practical example to add together a couple of numbers. Nice and easy, right? We also went over some naming techniques which you can use to name your variables in Python to keep them nice and readable. Just make sure to start with a letter, keep them all lowercase, and if there's a space, replace the space with an underscore. We also discussed in laborious detail, but very useful now that we've got the basics down, about how Python evaluates expressions and then stores the result in a variable. Finally, you saw how variables can make our code much more organized, much easier to find the data we want, and also a lot easier to change and edit later with powerful effect. Told you variables were pretty great, right? Now, because variables are such an important topic and pretty much everything else is built upon them, up next we have a quiz to check your understanding, and then you have a coding challenge to check that you've really grasped the concepts and let you try them out for yourself. Now don't worry, it's nothing too scary, but by giving you repeated opportunities to review and practice the concepts that are taught in the course, you're going to get an excellent understanding of them and learn them much deeper so you'll be doing it in your sleep. Now this is all part of the magic of the project-based learning that you get with the course. So I wish you the best of luck with the quiz and challenge, and I'll see you for a quick recap in the section review. Congratulations on completing the quiz and the coding challenge. I hope everything went well and you're now super confident that you fully absorbed everything there is to know about Python variables. So let's have a quick review of this section of the course to make sure that you've gotten absolutely everything before we move on. Firstly and most importantly, you learned that variables are used to store useful pieces of information in your computer programs. Variables are like boxes, and each variable has a name and also has a value stored inside of it. We give variables values and names using the assignment operator, which in Python is just an equals sign. You also learned that variables have a certain type, and because Python is a dynamically typed language, this variable type can change dynamically. This is different to languages like C and Java, which are statically typed languages and don't let you do this. You can check a variable's type by using the type function, which makes complete sense, right? You also learned that how the name of your variables can impact the readability of your code, and I suggested to you that you stick with Python's convention and keep everything lowercase, and if you need a space, use an underscore instead. Oh, and bear in mind that the names need to start with a letter, they can't start with a number or a symbol. After that, you applied your knowledge of variables and updated the script we made earlier on in the section to make it more organized and a lot easier to change. And after that, you had a quiz to check your knowledge and you got your first taste of a coding challenge which you passed with flying colours. I mean, wow! What a lot you've covered in just this section alone. Well done! If you've followed all of that, then you're truly a master of Python variables. We're now finished with the variables section of the course and we'll be moving on to using numbers in Python. Computers use numbers for absolutely everything, from game design to computer vision to online maps. Numbers are absolutely everywhere in programming, and as usual, Python makes working with numbers super easy and a load of fun. So in the next section, we're going to take what we've already learned in this section about variables and combine it with some new knowledge about numbers in order to make our very first project. In that project, we're going to get all magical and make a health potion for a video game character, so you'll definitely want to check that out. And with that, I will once again give you my warmest congratulations for completing this section of the course, and I'll see you in the next video. Hello there, you beautiful people, and welcome to this section on numbers. Now this is a really important section of the course, because in here we're going to learn the inner workings of so many things in computing. Things like computer vision, web pages, and even Google Maps all use numbers to get stuff done. Now, this lecture is just an overview of the coming section, and it should serve as a briefing for what is about to come. But by the end of the lecture, you should know what we're doing next and be super excited to jump right in and start using numbers in Python. We're going to start off, as always, with the basics. The first lecture will cover how to do basic arithmetic in Python. That is addition, subtraction, multiplication, and division. And once you've learned all these, it's quite possible that you'll never need to do maths in your head ever again. And once we've got the basic arithmetic down, we're going to start doing more complicated processes and learn about how we can control the way that the computer will work the answer out. This is very useful and is going to give us a lot of confidence when doing rather complicated things later on. After that, I'm going to introduce you to a new data type called the float. And yes, floats are as cool as they sound. Then we're going to jump in and create our first project. We're going to tie together what we've learned about variables in the last section, along with what we're going to learn about numbers in this section, in order to make a health potion for a video game character. Our project will be able to deal with different game difficulty levels and will really give you a good demonstration of how numbers are used to make things work in computer programs. This project will also introduce us to the Python random module, which we will use to make a random number generator. By doing this, we will learn how to use Python libraries, and this means we can leverage work done by other people to make our code even more awesome. After that, for those of you who are interested, we're going to cover other mathematical topics such as rounding, powers, square roots, some basic trigonometry, and go into more advanced topics using the Python math module. This will be particularly interesting to those of you who have come from scientific or mathematical backgrounds and want to see what Python truly has to offer. Finally, we'll have a section review, and then there's going to be plenty of coding challenges for you to have a go at to check that you fully understand the concepts covered in this section. So hopefully you have a good idea of where we're going to be going in this section, and if you're anything like me, I bet you can't wait to get started. Let's get right into using numbers in Python. Hello there, you beautiful people, and welcome to the first lecture in the numbers section of the Python Bible. Now, of course, no numbers section worth anything would be complete if it didn't tell you how to add, subtract, multiply, and divide, now would it? In this lecture, we're going to do a quick run-through of all the basic mathematical operations, and also a very useful one called the modulo function, which might be new to some of you. We're also going to introduce you to another variable type called the float, and go over a special difference between doing maths in Python 2 and doing maths in Python 3, which can trip a few people up. So by the end of this lecture, you will be able to add, subtract, multiply, divide, and use the modulo function on numbers in Python, and that's going to serve as an excellent and strong foundation moving forward. You'll also have a deeper understanding of what operators are, and you'll also be familiar with a new variable type, which is pretty cool, right? So we have a lot to do, so let's boot up idle and get started. Alright then, so how does arithmetic work in Python? Well, all mathematical operations, like adding, subtracting, etc., all need a mathematical operator. A mathematical operator is just a fancy word for a symbol that lets us do a certain mathematical task, like adding or subtracting or dividing or whatever. So let me show you what I mean. Let's say we wanted to add together 2 and 3. Well, we would type 2, just like in here, just type the number 2, then the addition operator. In Python, the addition operator is just a plus symbol, which, makes sense, right? And then the number 3. When we hit enter, Python is going to know, because of the addition operator, to do an addition between 2 and 3. So all we have to do is type 2 plus 3, Python's going to do the rest and give us back 5. The key point that I'm trying to hammer home here, it's the operator that tells Python what it needs to do. So for example, what about subtraction? I bet you can guess what the subtraction operator is, right? That's right, it's just a minus sign. So let's say if we wanted to subtract 20 from 100. The way that we do that is 100, subtraction operator, 20. And when I press enter, Python's going to do 100 minus 20, and it's going to give us 80 back, which is correct. We can also combine together these operations. So for example, if we type 100 plus 20 minus 80, what that's going to do is it's going to give us 40. Okay, so now that we have addition and subtraction down, we come to multiplication, the bad boy. Right, so the multiplication operator is an asterisk or a star. You can find this by pressing Shift and then 8 on your keyboard. It looks basically like this. Okay, so the way that you do this, let's say if we wanted to find what 2 times 2 is. Well, for that we need the multiplication operator. So 2 multiplication operator 2 times 2. Python's going to give us back 4, which is correct. Now, as a matter of style, it's always good to put a space around the operator. So, like, instead of just typing 2 times 2, it's better to do 2 space times space 2. Just like that. And this just makes it look nice, really, and just a bit less cramped. So that's something you might want to bear in mind. Now we come to division. The division operator in Python is the /. Okay, just like when you're going to a website or something. It can be found next to the question mark on your keyboard. But anyway, if we wanted to find what 2 divided by 4 was, we do 2 division operator 4, and it's going to give us 0.5, or 1/2. With another example, we could do 10 divided by 5. It's going to give us 2.0. Interesting, isn't it, the way that we've got this 0.0 instead of just 2. Now, if you're following along on Python 2, or if you've ever used Python 2 before, you'll find this a bit strange, because one thing that Python 2 used to do was every division would just give back a whole number. Okay, so if I did 1 divided by 2, it wouldn't give me 0.5, it would just give me 0. And that used to make all sorts of problems, okay? Used to mess everything up sometimes if you didn't catch it. But in Python 3, that has been, I guess, fixed. The problem's kind of been removed. So the divisions now always give back a decimal number. But how is it actually giving back a decimal number? Because numbers in Python, and I guess in most programming languages, they're not all created the same. Okay, there's 2 different types of data that represent numbers. The first type we're already familiar with is the integer, or int. So let's say let's take the type function of the number 2. It's going to tell us it's an int. If I take the type function of 0.5, we're going to get this other one here called a float, or a floating point number. A floating point number is just a fancy way of saying a decimal number, basically. So we've got this completely different data type called a float that allows us to get extra levels of precision in our numbers, so we can go to decimal places rather than just dealing with whole numbers. This is kind of more or less automatically done, but it's something to bear in mind. Numbers are not all the same. They're basically 2 different data types, one for whole numbers and one for numbers that have a decimal point. The reason there's this difference is because basically, if you want more levels of precision in your numbers, you need to be able to store more information. So floats actually take up a bit more space in your computer program, a bit more memory than integers do. So a float takes up 16 bytes of memory, whereas an integer in Python only takes up 14 bytes, which is actually rather large as far as integers go. I think Java, it's only 4 bytes. So in Python, a float is 14% larger than an integer in Python, but you get all that extra precision. So it's just something to bear in mind. You've got 2 options available to you. Yeah. So with division out of the way, let's move on to the last topic in this lecture with regards to these operations. Quite quick, right? Called the modulo function. Now, the modulo is weird, but it's very useful, and it basically allows us to find the remainder of a division. Okay? So the modulo operator is the percentage symbol. So, and you can find this in case you're looking for it. It's pretty much just you press Shift and then the number 5 on your keyboard. So, for example, if we did this, 5 modulo operator 3, we get 2. And why is that? Well, the reason is, it's not because 5 minus 3 is 2. No. The reason is because 3, if you divide 5 by 3, 3 will go into 5 once with remainder 2. So let's try another example. If I did 10 modulo 2, we're going to get 0. Why? Because 2 goes into 10 5 times and there's nothing left over. So the modulo returns 0. Basically, 10 is exactly divisible by 2, so there's no remainder. What if we do 7.5 modulo 5? Well, that's going to give us 2.5. It's going to give us 2.5. And the reason for that is because 5 goes into 7.5 once, and 2.5 is what's left over. So you can see the modulo operation, although it's a bit weird, it gives us the remainder of a division, which is sometimes quite useful. So yeah, I mean, we've really covered quite a lot in this lecture. I mean, as far as content there, we've learned how to add, subtract, multiply, and divide, as well as use the modulo function. And you've also learned about a key difference between numbers in Python. They're not all the same. You've got integers and you've got floats. And you've also learned about a difference between Python 3 and Python 2. Python 2, whenever you used to use division, it always used to make it as integers. There was no concept of floats during division unless you directly expressed that you wanted floats. But in Python 3, you don't have to worry about this anymore, and it won't cause any problems when you're doing it. So divide away, I suppose. So what have we got next? Well, in the next lecture, we're going to learn about how we can combine all these operations together to make rather advanced operations. And we're also going to learn how to make sure Python works out the answer in the way that we want it to, rather than it calculating something behind the scenes. Now, this is a very useful skill, and it will stop things going wrong and you not being able to notice it. So it's very useful to know whenever you work with numbers in Python. And as usual, I can't wait to show it to you. So I'll see you in the next video. The great thing about computers is that they will do whatever we tell them to do, and they'll do it very, very quickly. But at the end of the day, computers are just machines, and they can't really think for themselves. Just yet, anyway. So sometimes we think that we've told the computer to do one thing, but in fact we may have told them to do something totally different, and one particular time when this can happen is when we're doing calculations. So in light of that, in this lecture, we're going to go over some common mistakes when doing maths in Python and on computers in general, and we're also going to go over how to prevent them from happening. And by the end of this lecture, you'll know how to order your mathematical operations in Python to prevent things from going wrong. So let's boot up idle and get started. Okay, so here we are in idle, and let's say we want Python to work out the answer to 2 times 5 minus 1. Okay, so 5 minus 1 is 4. So 2 times 4 should give us 8, right? So when I press enter, oh, we get 9. But why does that happen? Now, the reason we got that issue in the previous example, where Python gave us an unexpected result, is because mathematical operations don't always follow what makes sense in our head, but they actually follow what's called the BODMAS ordering system. Now, the BODMAS ordering system is just 6 letters that represent different mathematical operations, and whatever is at the top, basically close to the letter B, gets ordered first or gets more priority, and what is towards the bottom, by that I mean closer to the letter S, gets lower priority. So what's the letter B? Well, the letter B stands for brackets, or you may have heard of them called as parentheses. So whatever you put inside brackets is going to be executed first, because B is at the start of BODMAS. After that, we have order, which refers to squaring numbers, cubing numbers, or raising any number to the power of something else. Okay, so cube roots, square roots, all that stuff. That goes second. Then we have division, which is, where you divide 2 numbers. Then we have multiplication, where you multiply 2 numbers. And no points for guessing, A stands for addition, and S stands for subtraction. So the main takeaway from this is that brackets can be used to force operations to occur in a specific order. So with that in mind, let's have another look at the example we just did now to see if we can get the answer that we wanted. So here we are back in our shell, and let's have another look at our equation or our calculation to see what might have gone wrong. We wanted this calculation to give us the number 8 because we thought 2 times 5 minus 1 should give us 8, because 5 minus 1 is 4, and 2 times 4 is 8, right? But that didn't happen. It gave us 9. And the reason why is because Python follows the BODMAS system. And in BODMAS, multiplication happens before subtraction. So what actually happened is Python did this multiplication first. It did 2 times 5 and got 10. Then it subtracted 1. 10 minus 1 is 9, which is the answer that we got. So we want to get 8. And the way that to do this, we need to force 5 minus 1 to be calculated first. So to do that, we can do 2 times and open up a bracket and put 5 minus 1 inside the bracket. Okay, so now because brackets are at the start of BODMAS, 5 minus 1 is going to be forced to be calculated first to get 4, then 2 times 4 should give us 8. So there we are, we've got the same numbers on the screen, but just by using BODMAS to our advantage, we've actually got a completely different answer. And this is something to bear in mind because, you know, if we'd just gone ahead and wrote this line of code and didn't think about it again, we might think that it's working correctly, but it's actually not. It gave us a different answer to what we wanted. So by using BODMAS and knowing about it, we can actually control the answers that we get and make sure that the maths that we do in our code is free from errors. The concept that mathematical operations have different orders as dictated by the BODMAS system is a really useful thing to keep in mind whenever you work with numbers in computer programming, because it'll stop your code from doing something unexpected and it'll stop really rather hard to spot errors actually cropping up. So when in doubt, use brackets. I mean, they're free after all. In the next lecture, we're going to build our first mini project, and in this project, we're going to imagine a player that has just walked over a special health potion in our game that gives them a random amount of health. We're going to make a random number generator that can be used to randomly generate some health for your player, and then update their health depending on the difficulty system. So it's going to be super awesome. So I'm not going to waste any time here, and I'll see you in the next video. Hello there, you beautiful people, and welcome to our very first project. I hope you're excited. In this project, we're going to be making a health potion for a video game. That's right, we're officially game developers. High five. So the scenario is, we have a character, who I guess kind of looks like this, who has some health. Let's say he has 45 points. We imagine that this character has walked over a health potion, and the health potion magically increases their health by a random amount. I guess in this case, quite a lot. But the game also has 3 difficulty settings: easy, medium, and hard. Now, depending on what difficulty is selected, the amount of health that the person gets from the potion will change, and this will be less on higher difficulties. So in this lecture, we're going to be using variables and numbers to create the functionality required for this health potion to work, and we're also going to use Python's random module to help us build a random number generator. By the end of the lecture, you should have a rock-solid understanding of how numbers are used in computer programs to make things work behind the scenes, and you'll also know how to make a random number generator in Python. This lecture is going to tie together a lot of what we've covered so far and should be a really valuable learning experience, so I hope you're excited. Oh, and make sure to follow along with me for maximum learning. We have a lot to do, so let's boot up idle and get into it. Alright, so the first thing we're going to need to do is create a new script to hold all our code. So I'm going to go up here to the File tab, press New File, and we're going to see this thing here. I'm going to save it on the desktop in my Python Bible folder, and I'm going to call it health.py. Now make sure you remember the .py file extension when you're following along. So let's maximize this, and we're good to go. Right, now that we've done that, the first thing we're going to want to do is give our character some health. Health is a rather complicated topic conceptually, as I'm sure doctors will tell you, so we need to think of a way that we can represent health in a simple enough way that a computer can understand it. I know, we can use a number. Health is going to be a whole number in this game, so we're going to want to use the integer data type, because that's what we use for whole numbers. We'll obviously want to store the player's health somewhere and refer to it and update it later. So for this, we're going to need to create a variable called health, and we'll need to give it a certain value. Let's say the player's health starts at 50. Here's a micro challenge for you to test what you really learned in the last section. I want you to pause this video and create a variable called health and give it the value of 50. Go ahead and pause this video now, create the variable called health, and then unpause the video to see if we did it the same way. So how'd you get on? Did you manage it? The way that I do it is I type health equals 50. Now if you got the same as me, then congratulations! You're well on your way to understanding variables and numbers in practice, which is brilliant. So now what we've done is, we've managed to create a representation of the player's health using a variable called health. The value that health has starts at 50, but this number is going to change as the player gains health from our potion. Now our potion is going to give the player a random amount of health. The amount of health it's going to give them is going to be a random number between 25 and 50. Now, we don't really want to create the code required to generate a random number from scratch, which I understand is quite a complicated task. The good thing is, we don't need to. Python has a built-in module that we can use, called the random module, which can generate random numbers for us. The way that we use Python libraries is to import them. You usually do all of your imports at the top of Python scripts, so let's go up there and import the random module. Let's move this down. All we've got to do is type import, which you can see goes yellow, and then the name of the module. Seeing as we're importing the random module, we're just going to type import random. And say when I save the file, that's going to allow it when it runs for Python to import that file. So perfect. One thing that you should notice is the way that the import word here went yellow. This is idle's helpful way of showing us that import is an important word in Python, or a keyword, and this colour highlighting can be useful when checking for spelling mistakes. So let's say, for example, I forgot the R, and I put import. You can tell that now that it's gone black, which would let me know that potentially I've made a problem, instead of because I was expecting it to be yellow. So let's have a look at the Python random module and what it makes available to us. One way to do this is we can open up the Help tab inside of idle and click on this Python docs link, or you can press the F1 key on your keyboard for a shortcut. Either way, we're going to see a window that looks something like this pop up, and this contains all the Python documentation. This documentation details all the built-in modules and functions that are available with Python and other useful pieces of information, so it's a great resource. Now at the top here, as we're looking for a random module, we're going to click Modules. And here's an alphabetical list of all the modules, which is quite convenient for us to browse. Now as we're looking for the random module, let's click the letter R here and see what comes up. Awesome, the R's not that long, and you can see random is right at the top, so let's click on that. And this has opened up the documentation for the random module. As you can see in here, we have all sorts of useful information, which you can browse through if you wish, but to save us some time, I'm just going to show you the randint function. So when I browse to that, here it is. So random.randint. So this function will give you a random integer, okay? And it gives you the information here on how it works. It's going to return a random integer, what they're going to call n, such that n is between A and B, but it can be equal to both of them. So it's probably a bit easier if I show you what this is in practice. Let me just show you how this works. So let's head over to the shell. Where's the shell? Let's type it in here, don't I? Let's open up the shell. This is different to our script, by the way. This is just the raw Python shell. If I type import random, okay, that's worked. That's fine. We haven't got any error. Now I want the randint function. So for that to work, I have to type the module name, then a full stop or a period, and then the function that I want to use. So random.randint, and let's say I put, I don't know, 10 and 20. Okay, so Python has given me a random number between 10 and 20 that can be equal to both. So if I just run that again, random.randint, let's say 10 and 100. You see, it's given me 45. So basically, this is just going to be, and if I type that again, 56, 54. By the way, this is a useful time to mention. On the shell, if you want to just repeat a command, put your cursor here, hit the enter key, and it will copy and paste it to the next line. But as you can see, it's giving us a random number between 10 and 100. So that's quite useful. Now, if you remember, I said that we wanted the health potion to generate a random health value between 25 and 50. And store that in another variable. So here's another micro challenge for you. I want you to create, on another line here, to create a variable called potion health and set that equal to a random number between 25 and 50 using the random module's randint function. So pause this video now and go ahead and try to use the randint function to create a variable called potion health that is between 25 and 50. How'd you get on? Did you manage it? Well, here's how I would do it. I would type on this line, I'd type potion underscore health because, well, first of all, we can't have a space in our variable names. And this is the convention for how you name your stuff, all lowercase with underscores for spaces. And I'd assign that a value a random value between 25 and 50. So to do that, I need the random.randint function, and to have it between 25 and 50, I give this 25, comma 50. So if you got that, then perfect. But if it was a bit hazy and a bit difficult to understand what happened, just feel free to rewind the last few minutes to make sure that you have a decent understanding of how modules work in Python. Just as a quick overview of how it works, we've imported the random module, and which you can see is the same here. And inside the random module, there are loads of functions, one of which is called randint. So, I mean, we're going to cover functions much later in the course, but I just want you to understand kind of what's going on. So what we're saying is, in the random function, put a period, this function name, randint, which we're going to give 25 and 50, Python's going to get a random number from this, isn't it? It's going to get, I don't know, say 35. Once it's got 35, it's going to stick that value in the box that we've called potion health. So if you understand more or less what I'm talking about, then brilliant. I'm not expecting you to understand the ins and outs of this, but if that kind of makes conceptual sense, then that's brilliant. We've now got a certain amount of health that the potion is going to give our character that we can refer to later on. Phew, I think that's a good time for a break, don't you? So let's have a quick review of what we've done so far in the project. We started this lecture with a brief of this project and what we'll be making. We found out that we're making a health potion that can be used in a game to give a character a random amount of health, depending on the difficulty level. You then went ahead and applied what you've learned about variables and numbers so far to create a variable called health and give the player an initial health value of 50. After that, we decided that we wanted to use a random number generator to help us with making random numbers for our potion to save us coding it all from scratch. So we checked out Python's random module. We had a quick overview of how to look at a module's documentation and also how to import a module into our code using the import keyword. All we had to do was type import and then the module name, which in this case was random. Finally, we used the randint function inside of the random module to generate a random integer between 25 and 50 and stored that value in a variable called potion health. I mean, we covered quite a lot in this lecture, and I'm really proud of how far you've come in such a short space of time. We're really starting to touch on some advanced topics such as module importing and functions, so if all of this makes sense to you so far, then well done, genius. We aren't there yet though. There's still some way to go to finish off our health potion project. In the next video, we're going to find a way of adding together our potion health to our player's overall health, and we're also going to find a way to implement a difficulty system so that a player will get less and less health from our potion when playing on harder and harder difficulties. I'm really excited to finish off our project, so I'll see you in the next video. Hello there, you beautiful people, and in this video, we're going to finish off the health potion project, which is going to be quite an achievement. So in this lecture, we've got quite a few things to do. First of all, we're going to make it possible to add the potion health to the original health of the user, or the character. Then we're going to make the program print out how much health the character has so we can see if our code is working or not. After that, we're going to implement a difficulty system so that the potion gives less health on higher difficulties. By the end of this video, you'll have a functioning model for a health potion that you'll be able to show your friends. Pretty cool, right? Now, not only that, but you'll have tied together everything you have learned so far in the course, and you'll hopefully have a rock-solid understanding of variables and numbers. So let's get into it. Alright, so this is where we got to last time, back in our health.py script. Now, the next thing that we need to do is to take this potion health right here, which is a random number between 25 and 50, and add that somehow to the original health that the player had. So, as a micro challenge to you, I want to see whether you can do this, okay? What I want you to do is to store in the box called health the value of what the health is currently, what the health is now, plus the potion health. Okay, so let's see if you can do that. Pause the video and try on this line, so a couple of lines down, just try and store in the health variable whatever the current health is, plus the potion health. And check back here to see how you did. So how'd you get on? Did you manage it? Well, here's how I'd go about it. I'd type health equals health plus, let me shift my mouse, health equals health plus potion health. Okay, so what's going down here? Well, we've got a box that's called health, and we're using the assignment operator to stick a new value in it. So what are we putting in? Well, we're taking whatever the value of health is now, So Python's going to look inside the health variable and see 50. So we've got 50 plus potion health. So let's say potion health was 30, for example. Python is going to evaluate whatever's on the right-hand side of the assignment operator and see 50 plus 30, and it's going to add those together to get 80 and store that back in the health variable. You can kind of overwrite a value using itself, which is pretty cool, right? Alright, so to check that everything is working correctly, we need to now print the new value of health onto the screen. So let's make this another micro challenge. I want you to figure out how to use Python's print function to print the new value of the character's health onto the screen. So go ahead and pause the video now and use the print function to print the health value onto the screen, and come back when you're done to see how you did. So how'd you get on? Hopefully it went well. Here's how I'd have done it. So we want to print the new updated value of health. So simply, I would have just typed print health. Now there's one thing I want you to notice here. Can you see the way that the word print has gone purple? Well, just like import up here went yellow when idle showed us that it had a special meaning, likewise print has also gone purple to show that it's a built-in function. So when you see words go purple, that means they're a built-in Python function or a reserved word. So that's just idle letting us know that we spelt things right, or that we're doing things correctly. Now up here we kind of put the new value of health inside a box called health, didn't we? Now to print that out, we just have to type the variable name. So Python's going to look inside the box called health, get the value, which let's say it's 70 or something, and when we print it, it's going to show up on the screen. So if I save this file by pressing Control and S, alternatively you can go File and Save if you're old school, and then we can click Run, and what we see is 97 pop up on the screen, which is pretty neat. So what happened was, our health started at 50, potion health became a random number between 25 and 50, which in this case I guess was 47, and we added that to the original health, so 50 plus 47 is 97, and we printed 97 to the screen. So that's pretty neat, right? So what have we got next? Right, the last thing we need to do is we need to make some kind of difficulty system. So what we want to happen, let me just close this here. What we want to happen is for the player to get less and less health at higher difficulties. Now the simplest way that I can think of doing this is to create a variable called difficulty and set that equal to a value between 1 and 3. 1's going to represent easy because it's the lowest difficulty, 2's going to represent medium, and 3 is going to represent hard. Again, the thing that I'm trying to get across is the way that we're using variables to represent concepts in the real world. So you can see how useful numbers are, right? So let's make this step for now. As a micro challenge, at the top here, near where we've defined health, so let's say here, I want you to define a variable called difficulty and set it to easy mode by default. Okay, so just set it to easy mode using the number scheme we mentioned earlier. 1 being easy, 2 being medium, and 3 being hard. So create a variable called difficulty, set it to easy, and then come back to see how you did. So how'd you get on? Well, as we're setting the difficulty to easy mode, I'd do something like this. Difficulty equals 1. Simple as that, right? If you got that, then brilliant. You understood what I was talking about. Now, as if they were on medium mode, we just say difficulty equals 2, or if they're on hard mode, difficulty equals 3. But for now, we're on easy. So now we need some way to allow this difficulty to affect how much health the potion gives our player, which means we need to modify our potion health variable using this difficulty value. So one way that I can think of doing that is simply to just divide the health that's here by the difficulty. Because what's going to happen is, as the difficulty gets bigger, we're going to be dividing by a bigger number, so the potion health will become smaller and smaller, which means on higher difficulties, the player is going to get less and less health from the potion. Makes sense, right? So if I run this now, Python's going to tell me to save it, so I'll save. And we see we get 98.0. So that's pretty good, but now we have this decimal point that's popping up that we didn't have before. Now the reason is It's because, do you remember a few lectures ago, I said that whenever you divide in Python 3, you get a float. And a float is different to an integer. Floats are decimal points, and integers are whole numbers. And we want this as a whole number, this potion health. What we've got at the minute, we've got a float plus an integer, and that's going to give us a float because it can't lose the precision. It can't lose the decimal point values, so it needs to just add it. So what we need to do is we need to convert this value, whatever it is, into an integer. And the way we can do that is with something called casting. So casting is where basically you force a certain piece of data to become another type. So we want to force it to become an integer. So what I can do is I can type int, open the brackets, and now you can see actually that it's gone purple, just like print went purple down here, showing that we've got something right. And we're going to put inside the brackets all of this stuff. And what that means is that it's going to calculate potion health, just like before, and convert it into an integer. So now when I run that, you can see now, oh, they got the maximum health. Brilliant. So what that means is we now only get integers out because we got rid of the float in our calculation. You can convert between pretty much all kinds of compatible data types in Python, but for now, this is how you do integers, convert to integers. You can convert to floats as well using the float keyword like that. And what we can see is that as I increase the difficulty, say I give it to 3, and now it's on hard mode, what we're going to see is that on average, I mean, they did quite well there, 61. On average, they're going to get much lower than if I put the difficulty on 1. So now it's much more likely they'll do higher. So you can see they got 80 there, whereas before they only got in the 60 range. Awesome. We now have a fully functioning health potion with a swanky new difficulty system. Why not share the code you've made with your friends and show them how it works? I bet they'll be very impressed. So let's just go over really quickly what we've done in this lecture. We started off by allowing our script to update our player's health with the random health that Python generated. This basically means we've added health to the player. This concept of overriding variables is very useful, and you should make sure you've got it down as it comes up all the time. After that, we moved on to make our script print out to the screen the new health of the character using Python's print function. This was just so we could check that everything was going as expected. After that, we implemented a difficulty system, again by using numbers to represent the different difficulties. Numbers are amazing for representing real-life concepts, and we use them here to represent difficulty. But we found that by doing it in my chosen way, we got a little bit of an issue where we would get health values with decimal numbers. This meant that we were getting float variable types instead of integer variable types, and we only want to work with whole numbers in this project. So to fix this, we used casting. Casting is simply where we convert one data type into another. In this case, we converted a float into an integer by using Python's int function, but you can convert from an integer into a float using Python's float function if you wish. Whew, I mean, that really is quite a lot we covered in this video, so I hope you're really proud of yourself for finishing the project, and I hope it serves as a badge of honor that you fully absorbed the variables section and the numbers section of the Python Bible. Now in the next lecture, we're going to be talking about some extra things that Python can do with numbers, such as trigonometry, rounding numbers, powers, square roots, and other useful things which may be interesting to you by using the math module. However, this lecture is optional, so take it if you feel like it, but if you're not particularly interested, then feel free to skip it and head over to the section review for a quick recap of what we've learned in this section. Either way, I'll be there, so I'll see you in the next video. Hello there, you beautiful people, and first of all, I commend your dedication for stepping up to take this optional lecture on useful Python maths functions. This kind of dedication to always find out more makes it very clear to me that you're going to do great in this course and in your future work as a Python programmer. Nice one. Now in this lecture, I'm going to share with you some things which you might use quite often if you do rather maths intensive or engineering related work with Python. These include things like rounding numbers, trigonometric functions, exponentials, logs, squaring numbers, cubing numbers, etc. Now for this kind of stuff, you'll need to use Python's math module. Feel free to check out the documentation for Python's math module for yourself in the Python docs like I showed you earlier. But in this lecture, I'm just going to cherry pick a few examples to give you a feel of what's possible, but there are many more things for you to explore and play with to see what you personally might find useful. By the end of this lecture, you'll have more of an idea of what Python has to offer maths-wise, and I'll also point you in the direction of a few more advanced libraries or modules for you to look at. We obviously have a lot to do, so I'm going to be going quite fast to fit it all in. Don't worry if I go too fast, just listen to the bits that are relevant to you and rewind them, otherwise just ignore me. Alright, let's go. So a common thing you might want to do in Python is to round numbers to the nearest integer. Now this is done using Python's built-in round function. So for example, if we have the number 2.1, by typing round 2.1, Python is going to round this number down and give us back the number 2. Just like that. Likewise, if we have the number 1.5, by typing round 1.5, Python is going to round this up to the next whole number, which is also the number 2. Something to notice here is the way that round has gone purple. This shows that it's a Python built-in function. It's just one of the basic standard functions that Python already comes with. But Python's basic math support is not all that powerful. So to use some more powerful abilities, we can import Python's math module, which is full of all sorts of functions and stuff in there. So here's a micro challenge for you. Using what we covered in the last few lectures, try to import the Python math module. So go ahead and pause the video now, head over to your shell and import Python's math module in the same way that we imported the random module, and come back here to see how you did. So how did you get on? Did you manage it? Well, if you did something like this, you opened up your shell and you typed import math, and you pressed enter and got no errors, then fantastic, that was exactly it. Because we know the module is called math, all we had to do was type import and then math. Okay, because whatever the module name is, you put here. So brilliant. Now sometimes you only want Python to round up or round down to the nearest integer, regardless of the value you're rounding. So for example, if I just do the regular round of 1.5, because it ends in 0.5, it's going to round up, isn't it? But what if we wanted to force it down to 1? Well, for that, we could use some of the built-in, well, not built-in, but use some of the math module functions. So for example, if I just do round of 1.5, we're going to get 2. But if I do math.floor of 1.5, you can see it rounds it down to 1, because that's using the floor function inside the math module, and that will give us 1. Likewise, if I do, I don't know, math.ceil of 2.1, that's going to round up to 3. Ceil is short for ceiling, like the ceiling in a room. So instead of rounding down to 2, which it would normally do, like up here, it's rounded up to the next integer, which was 3. Along with having functions inside of it, Python's math module also has a few useful values already built in, such as pi and e, the exponential. So for example, if we type math.pi and press enter, we see that we get pi to quite a few decimal places. And likewise, if we do math.e, we're going to get the exponential to quite a few decimal places, which is useful because you don't have to type these up, and it saves you just a bit of work. Now, Python's math module also has standard trigonometric functions such as sine, cos, and tan, as well as inverse trigonometric functions such as arcsine, arccos, and arctan already built in and ready to go. But do bear in mind that these functions take numbers in radians and not degrees by default. So for example, we know that the sine of pi by 2 is 1, right? So if we type math.sine of math.pi divided by 2, we get 1 as expected, but notice the answer that comes out is a float. Likewise, if we type math.sine of pi, which is just math.pi, then we're going to get 0, or almost 0. As you can see, we get 1 times 10 to the minus 16, which is a very, very small number, but it isn't exactly 0. The reason it's not exactly 0 is because when we entered math.pi up here, that is only an approximation to pi. So to get this to be actually exactly 0, what we might want to do is do math.floor of math.sine of math.pi. So basically we take that number and put it in there, and that's going to round it down to 0 as expected. So likewise, we can use cosine, for example. We know that cosine of 0 is 1. So if we do math.cos of 0, we're going to get 1. And to show an example of taking the inverse of the sine function, we can do math.asine of 0, and we can see that we get 0 back. Likewise, if we do math.acos of 0, we get 1.5707, which is pi by 2, as expected. If you check on the cosine graph, that's what you need. We can also use the math library to find the hypotenuse of a right-angled triangle using the Pythagorean theorem. Now, as we know, the hypotenuse of a right-angled triangle, where A and B are the small sides, and then C is the hypotenuse, the long side, you can use the square root of A squared plus B squared. But for a right-angled triangle with short sides of lengths 3 and 4, the hypotenuse is 5. So we can check this by doing math.hypot 3 and 4, and we're going to get back 5, because 3 squared is 9, 4 squared is 16, add those together you get 25, square root of 25 is 5. This function is also useful for finding resultant vectors in vector algebra as well. We can also square numbers and cube numbers in Python very easily using the math.pow function. So for example, if we want to get 2 to the power of 3, or 2 cubed, we can type math.pow of 2 to the power of 3, and that's going to give us back 8. We could alternatively, as a shortcut, we could do 2 times 3, and that's also going to give us 8, but as an integer instead of a float. So this is available without using or without importing the math module, and is a shortcut that's just generally built into Python. But you can see there's a difference in the variable type that comes out. So let's take another example. Let's say we wanted to find 9 squared. We could do math.pow of 9 to the power of 2. We're going to get 81.0, or we could do 9 star 2. We get 81 as an integer. You can also find the exponential of a number using the math.exp function. So for example, if we wanted e to the power of 2, we could just type math.exp 2, and that's going to give us 7.39. which if you type it in the calculator, you get the same thing. The same goes for natural logs. As we know, the natural log of an exponential always equal 1. So we can see this result when we type math.log of math.e as a constant. We're going to see 1 come out. So that works fine. But if you want the base 10 log or base 2 versions of log, you can use the log10 function, or sorry, the math.log10 function, or the math.log2 function, respectively. For example, if we do math.log10 of 1,000, what we're going to see is 3, because 10 to the power of 3 is 1,000. Likewise, if we do math.log2 of 8, we're going to get 3, because 2 to the power of 3 is 8. So there we have it. That was a really quick run through of some of the things that are available in the Python math library. Of course, you aren't expected to memorize any of this, and I'm not even expecting you to need to use most of it. Just use this lecture as a starting reference in the future if you ever need to do more mathematical things in Python. You've got it there for life. So one thing you should be able to take away from this lecture, however, is that Python is very capable of doing mathematical processes, and there is plenty of functions available for that kind of thing. If you want more in-depth stuff, you might want to check out the NumPy and SciPy libraries for more advanced functionality that is best suited for data analysis. But well done, you've survived the gauntlet and made it to the end of the numbers section of the course. In the next video, we're going to have a quick review of this section to make sure you've got all the concepts down, and then we'll move on to a quiz and coding challenge and stuff like that. So without further ado, I'll see you in the next video. Hello there, you beautiful people, and congratulations! You made it to the end of the numbers section of the Python Bible. We've covered so much in this section, so let's just take a step back to see just how far we've come. By the end of this lecture, you'll be feeling pretty fantastic about yourself for all the stuff you've covered, and you'll be pretty confident that you've fully digested all the information. And if not, you'll know what parts of this section you might need to brush up on. So let's get into it. We started by having a look at how to do basic algebra in Python. In that lecture, we introduced the concept of mathematical operators, which we said were just special symbols that let Python know which mathematical operation to do. We learned how to add, subtract, multiply and divide numbers, as well as learning about the modulo function, which just finds the remainder of a division. You also learned about a key difference with division between Python 2 and Python 3. In Python 2, division always used to give you back an integer or a whole number, which used to cause all kinds of problems. But now in Python 3, that's been fixed, and divisions always give back floats. We then introduced what a float actually was, and we learned that floats are just a data type for storing decimal numbers, which are very useful and they come up all the time. You also learned how to control the order of the computations and how Python works out an answer using the BODMAS system, which is how mathematical operations work. And it's going to stop you getting loads of errors. And after that, we jump right into our first project. Our project was to use everything we know so far about variables and numbers to make a health potion functionality for a video game. In this project, we learned how numbers are used in programs to represent real-life concepts such as health and difficulty. We also learned how to import external Python modules into our code for added functionality using the import keyword. We used Python's random module to help us make a random number generator. We also learned how to cast variables from different types, particularly from a float into an integer. Then, for those of you who are interested, we had an optional lecture which did a deep dive into the Python math module, showing you things from how to round numbers all the way to doing trigonometry and logarithms. The main takeaway from this lecture was that Python is very capable programming language for all the mathsy stuff, but be sure to check out the NumPy, SciPy and Pandas libraries if you're looking to do more complicated stuff like scientific data analysis. Also, don't worry if you didn't grasp everything in that lecture, it's there for reference for life, you've got it forever, so just come back to it when you need it. I mean, wow, just give yourself a big pat on the back for how far you've come. I'm honestly so proud of you, and you should be too. We've covered a heck of a lot of ground in this section, so to make sure you've got the key points down, we have some quizzes and coding challenges coming up to check your learning. After that, you'll have fully completed the numbers section of the course, and you can officially call yourself a Python maths wizard, if such a thing exists. But numbers aren't everything. The next section of the course will cover how to deal with text in Python, and for one of our projects we'll create a program that can take any user input and use that to write sentences about anyone in the world, or anyone imaginary. It's going to be a really amazing section of the course, as text is so fundamental to many user experiences that you're going to be creating with your programs. So good luck with the quizzes and code challenges that are coming up, and I'll see you in the next section to learn all about text in Python. Hello there, you beautiful people, and welcome to this section on Python strings. In the last section, we covered numbers, and we learned so much about how computer programs use numbers to represent useful concepts. However, numbers aren't everything. Sometimes you want to collect information from the user, such as a username, or a password, or an email address, and all of these are text data. Strings are the fundamental data type for dealing with text in all of programming, and by learning about how to use strings in Python, we're going to take your programming skills to a whole new level. But as usual, let's take a step back and get an overview of what to expect in this section. And by the end of this lecture, you'll have a good understanding of where you're going next, and you'll have a good idea of all the cool stuff that's waiting for you in this section on strings. So let's get into it. So we're going to start off by jumping straight in and creating the famous Hello World program in Python. In that lecture, you're going to learn how to create strings and also how to make the computer print out Hello World to the screen. This is going to serve as a good foundational introduction to strings and show you how easy they are to work with in Python. You'll then be given a quick coding challenge to see whether you can make strings on your own, and I bet you'll smash it. After that, we're going to make a mini project where we will use variables, numbers and strings to create a mini program that talks all about my favourite person, you. The project's going to start off quite easy. The computer will ask you for your name and will then say hello to you. This lecture will give you the basics of sticking strings and pieces of text together, which is also known as string concatenation, and you'll also learn about user input and how to get information from a user in your programs. We're then going to step it up a gear and get the computer to ask for your age. If you're 15 years old and your name is Sarah, for example, the computer would say, "Hello Sarah, you're 15 years old." We very rarely deal with just text or numbers in programming, so this lecture is going to teach us how to deal with potentially incompatible data types, such as strings and numbers, which you can't normally just stick together. After that, you're going to learn a cool way to create complicated pieces of text and use variables to fill in the blanks for customization purposes. This is called string formatting and is used everywhere in programming, and it makes creating personalized messages in Python programs super easy. This is great for emails. We will then take a deep dive into loads of cool tools that are available when we work with strings in Python, such as finding the length of a piece of text, or whether a certain word is in a piece of text, or whether a word is capitalized or not, and loads of cool and useful things like that. Strings are such a fundamental part of programming, so having all of these easy-to-use tools already built into Python is really helpful, and knowing about them will definitely save you a lot of time when you make your cool projects. We're then going to apply these tools to another project called the Email Slicer. This project will ask a user for their email address and use Python to slice up the email address and tell the user what their username is and also what their host domain is. Now we're talking, right? Proper programming. So overall, by the end of the section, you'll have 2 more awesome projects on your resume, and you'll be comfortable with handling text in Python by knowing how to create strings, perform operations on them, and even format paragraphs with special customized content. Now this all sounds like a lot of fun, so let's jump into the next section. Hello there, you beautiful people. Now every great programming tutorial series always has an iconic lecture where the student creates the famous Hello World program. As the Python Bible is naturally the best course out there for learning Python, right? We're going to build one of our own. So by the end of this lecture, you're going to know 3 main ways to create strings, and this is going to give you plenty of flexibility when working with text in your projects. You're also going to learn what a broken string is and how to fix one, which is going to stop you making silly errors and save you a bunch of time, especially when dealing with speech. And finally, you're also going to learn how to print text to the screen, which is a great tool for creating any user interface for your scripts and updating your user about what's going on. These are the fundamentals for any work you're going to do with text in Python in the future, so I hope you're as excited as I am to get started. Let's boot up idle and get into it. Alright, so the first thing that I'm going to do is I'm going to scoot up here and create another Python script, save that in the desktop Python Bible, and I'm going to call it hello_world.py. So now that that's there, we've saved that script, we're all good to go. So how do we create strings in Python? Now strings are very easy to create, and all we need to do is open up a double quote or a set of speech marks and then type some text inside and close the string with another set of double quotes. So for example, if I created a string that's, that said hello, that's how we do it. Pretty easy, right? We just have some double quotes, some text inside, close the double quotes, and that's it. Now, as you can see, idle has turned our string green to help us identify strings at a glance and also detect if something isn't quite right. Now, just like numbers, we can store strings inside variables. So let's create a box or a variable called name, and I'm going to assign that the value of Ziad, which is my name. And basically, this is just going to take the string called Ziad and store it in a box called name. Now, we're expecting this box to hold data with the type of string, right? We're expecting it to hold string data or text data. And we can confirm that by printing out the type. So let's print the type of name. And when I run this, we can see that Python tells us that it comes out with str or string. Okay, so that's simple enough. Let me try and give you a bit more of a complicated example. What if we wanted to save a string called message and set that equal to something like John said to me, I will see you later. Oh. Now can you see why Python's text highlighting is so useful? We can see here that we've got a string and then something broke here, right? The string hasn't continued because you can see the color change. We seem to have a string here, then something messed up, and then kind of another string at the end. So what's happened here? Well, this is what we call a broken string, and we can see this because the string isn't green anymore, right? Now, the reason for this is because we closed off the string by using the second set of double quotes, even though grammatically that's correct, isn't it? Like if you need to put speech within speech marks. So the way that we can fix this is instead of opening the string with double quotes, we can open them with single quotes, which is basically just the apostrophe on your keyboard. So if I put an apostrophe there, and I put an apostrophe there, That's all fine now. Now, can you see how useful this is? We can basically open strings with either double quotes or single quotes, depending on the punctuation that we're expecting to be in the text. So now we've just got a string that says, John said to me, quote, I will see you later. So that's really, really useful, right? And also, congratulations. You've not only just learned 2 ways to create strings, you've also just fixed your first broken string. You must be a genius, right? Okay, so what if we have a really long piece of text, like a paragraph from a book or text in an email? Well, right here on my clipboard, I have the opening paragraph from William Shakespeare's famous play Romeo and Juliet. If I create a variable called Romeo, and I set that equal to this text, we're going to see that, oh, and I tried to open up some double quotes, for example, and try and put it all in there, we're going to see it doesn't work, right? The string kind of just breaks after the first line. So how can we fit all of this into just one variable? Well, the way that you can do this in Python is to use triple quotes. So I could put 3 sets of double quotes like that, and that will work fine. Alternatively, I could put 3 sets of single quotes, and that will also work fine. And you can notice the way that it doesn't really matter what, because you can see there's a single quote in here, there's another single quote here, another single quote here. It doesn't really matter. I can put a double quote in there. It doesn't really matter what punctuation is inside, because this is going to take care of all of that. But do note that it will preserve the line spacing. So now that it's enclosed in there, if I want to print out all of this text, all I have to do is just print Romeo. Now, when I save and run that, you can see that it's going to print out the entire text. So to refer to all of that data, now you can imagine this being hundreds and hundreds of lines long, right? This could be anything you wanted. I can refer to all of that data just by using the variable name Romeo, which is really cool, and I'm sure you can see why variables were so useful to get a grip of earlier on. Awesome. We now know way more than enough to create our Hello World program. So let's go back into the script, down here, over here, and delete all of this first. Okay, just start a clean slate again. There we are. So what we need to do to make the Hello World program, the first thing we're going to do is create a variable called hello that's going to hold the text Hello World. And of course, you knew it was coming. Here's a micro challenge for you. What I want you to do is go ahead and create a variable called hello. Then I want you to set the text equal to Hello World with an exclamation mark at the end. You can use either double quotes or single quotes to accomplish this. It's entirely up to you. So pause this video now and have a go at creating the string, then come back to see how you did. How'd you get on? Did you manage it? Well, if you did something like this, hello equals hello world, with an exclamation mark, then fantastic. Well done. You really are a fast learner if you got that, because now you know pretty much how to create strings. So all we need to do now is create the famous Hello World program, is print this text to the screen. Sounds easy enough, right? Well, here's another micro challenge for you. Go ahead and print the hello variable to the screen and save and run your script to watch the computer say hello. Then unpause the video to see how you got on. Welcome back. Did you manage to make your computer say hello? Here's how I'd have done it. Very simple. Just print hello. And when I save and run that, that's going to print the content of the hello variable to the screen, and the computer is going to say hello world. So congratulations, you've just created the world famous Hello World program in the Python programming language. Well done. So you've learned quite a lot in this lecture. First of all, you learned how to create strings in Python. Python makes creating strings super easy, and in fact gives us 3 ways to do it. You can use single quotes, double quotes, or triple quotes, depending on your needs. You also learned how to detect whether a string was broken using idle's convenient syntax highlighting, and also learned how to fix our strings if they do get broken. You then created the legendary Hello World program in Python by using your knowledge of variables to print text to the screen, and you can now class yourself as an official Python programmer. Epic. I'm happy to say you're now well on your way to mastering strings. Well done. Up next, we have a couple of coding challenges to test that you know how to print text to the screen and that you know how to fix broken strings. After that, we're going to create the Hello You project, where we'll be building a program that tells us all about you. We will learn about things such as getting user input, which is always useful, and you're also going to learn string formatting, which is great for automating text creation. These are things which you really don't want to miss, trust me. So I bet you're super excited to smash through those coding challenges and get to the next lecture. So I'll get out of your way, and I'll see you in the next video. Hello there, you beautiful people, and welcome to the second project of the Python Bible course. In this project, we're going to be creating a computer program that will ask you a few questions about yourself and use the information that you provide it to write a sentence all about you. Pretty cool, right? We've got a lot to go through in this project, so in this lecture, I'm just going to give you an overview of all the cool stuff that's in store for you and let you know all the awesome things you're going to be able to do after we finish it. So here we go. First of all, you're going to learn how to get your computer programs to ask users questions and gather information from a user. Remember, your programs are all about helping a user to complete a certain task, and being able to tailor your programs to each individual user is a very useful skill indeed in today's world. This skill is useful for all sorts of things, from creating personalized emails to creating user accounts. After that, you'll build on your previous knowledge and learn how to combine together various different data types in order to make meaningful pieces of text by using skills such as string concatenation, data casting, and string formatting. One of Python's biggest strengths is how easy it makes it to combine and convert between various data types in order to make meaningful outputs. By learning this, you will have more flexibility in your programs, and more flexibility means more options, and more options means better programs. By the end of this project, we'll have a program that asks you some questions and learns about you. The program will then do some behind-the-scenes processing, and in the blink of an eye, give back a meaningful sentence that says something about you. This is a really cool project that will be worth sharing with your friends, and I can't wait to get started. So let's jump into the next video, where we will start by teaching your computer to ask questions. Hello there, you beautiful people. So we're now officially kicking off the second project of this course, the Hello You program. In this lecture, we're going to start off, as usual, by creating our script, and then we're going to learn how to use Python comments to structure our code and help us plan what we want to do, which is a great practice for big projects like this one. After that, we're going to get our program to be able to ask questions, and then when it gets answers to those questions, to store the answers in variables with appropriate names. So by the end of this video, you're going to know how to get user input in Python and how to store that input in variables, which is an incredibly valuable skill, and it's used for so many things, like I said before. As an added bonus, you're also going to learn how to look up functions for yourself, which will improve your independence as a programmer, and you're going to learn how to write out a plan for your code using Python comments, which is going to make programming much easier for you and everyone else you work with on big projects in the future. So let's get cracking, shall we? Alright, so the first thing we're going to want to do is to create our new script. So I'm going to go at the top here, File, New File, and when I'm here, I'm going to save this on the desktop in the Python Bible folder as hello_u.py. Brilliant. So now let me maximize that and we should be all good to go. So the first thing we're going to really want to do in this project is to write an outline for our code. Writing an outline helps you stay on track with what you're doing and basically serves as a checklist for your code, because when you're programming, there's so much stuff going on, it's really easy to get lost. So the way that we're going to write this checklist is using Python comments. Comments are things you can write in your code that don't get interpreted by the Python shell. They're basically just notes for yourself and other programmers who see your code, but Python won't touch them at all. So let's see an example. The first thing we want to do in this project is to ask the user their name. So to create a comment, we use the hash symbol. And you can immediately see that the text has gone red. This is Python telling us that it's a comment. Anything we write after this on this line will just be ignored by Python. So if I type hash and then write ask user for name, that would be a Python comment. Now if I just run this, you can see that nothing happens, right? And nothing happened because Python just ignored the comment. So comments are simply ignored by the code, but they're visible to people. So the thing that we want to do after that is ask the user for their age. So let's just type another comment, ask user for their age. Brilliant. After that, we're going to ask them where they live. Ask user for city. By the way, when I say user, I mean you, right? So we're going to ask them where they live or what their city is. and we're going to ask you what you enjoy doing. So ask user what they enjoy. All right, so that's that. And once we've got all this information, we're going to create the output text. This is going to be the sentence that's going to put all this stuff together. So create output text, and then we're going to print the output to the screen. Print output to screen. So hopefully you got a bit of an idea of how this is basically going to work. We're going to get some user input. We're going to do some processing on all that input and then output it to the screen. Fabulous. So this plan is going to allow us to write code in between here so we know exactly what to do next so we don't get distracted. Right, so if we follow our checklist, the first thing we need to do is ask the user for their name. So in order to do this, let's learn about the Python input function. Now, as a programmer, you're going to need to know how to look up functions for yourself, because I can't possibly teach you everything in this course. There's just way too much. So in the interest of helping you gain independence, I'm going to show you how to look up the input function in the Python docs. So to do that, let's go up here to the help bar here and click on Python docs. And you'll see a window like this pop up with a bunch of folders on the side. If you don't see this, then it may be possibly that you accidentally clicked hide up here, and to get it back, you'll see a button here that says show. Just click on that and it'll pop back up. Anyway, there's a bunch of folders in here, but the one that we're interested in for the minute is the Python standard library. If you click on that, you will see the Python standard library pop up on the right. Now, the good thing about the Python standard library is that everything in here is available to use straight out of the box. Before, when we used the random module or the math module, you had to write an import statement and then the module name, and then you had to do, to access the functions inside of it. You don't have to do that with the Python standard library. Everything here is built in and ready to go. So seeing as the input function is a function, we're going to look here at bullet point number 2 for built-in functions. Let's click on that. And we're going to see a table here of 68 items pop up. They're all in alphabetical order, and feel free to go and have a look at these if you wish. But seeing as we want the input function, I'm just going to click on input to link us to that. Now, Python always shows you how to use the function. It tells us that you type input, open a pair of brackets or parentheses, and then inside here, you type a prompt. Now, you can see here that there's some square angle brackets around prompt. What that means is that prompt is optional. You don't actually have to put one. But if you do put one, like in the example here, they wrote S equals input of some kind of arrow. The arrow popped up, and then the user typed in Monty Python's Flying Circus and pressed enter. When they pressed enter, Monty Python's Flying Circus was saved in S, as you can see here. So then when the shell was given S again, it gave out Monty Python's Flying Circus as a string. So this is important to note. Whatever the user responds to an input statement in Python 3, it's going to be saved as a string. So now that we've got that under our belt, let's head back over to the shell and ask the user for their name. Now, the way that we do this is we would type input, and then we need a prompt. So let's say we want a question such as, the very basic, what is your name? Okay, now I could just leave the string like that, but I'm actually going to put a colon and a space. And the reason for that is just to give the user a bit of space after the question to type in their stuff to make it look a bit nicer. But if I do that now, it'll work. What will happen is it'll run input, and I can say Ziad is my name. But so that's fine, and you can see why I added the space here. So we've got a nice space for me to start. But the issue is we're not saving that data anywhere. We want to save the data in a variable called name. Now all we have to do to make that work is just type name equals input. What is your name? Now whatever the user enters here is going to be stored in name, and we can prove that by printing out name onto the screen. So if I type in what is your name, let's say I entered John, it's going to print out John now, which is excellent. We've managed to take user input and save it somewhere in our program. So as a micro challenge, I want you to go ahead and do the same for age. I want you to create a variable called age and set that using the input statement to whatever the user answers for a question such as, what is your age? So pause the video now and go ahead and create a variable called age and to get the user's age. So how'd you get on? Did you manage it? Well, here's how I'd have done it. I'd have just gone in here and typed age equals input of how old are you. And now when I run that, what I'm going to do is I'm going to take this print statement and I'm going to put that there, and I'm also going to print the age. So what's going to happen is if I enter my name Ziad and let's say I am 23, then it's going to say Ziad 23. So what's happened there, we've got two different inputs and they are all saved in individual variables. Now something I want to just prove to you. Let me print the type of age and let me print the type of name. Now what you're going to see is that if I put my name, Ziad, and 23, you can see that they're both strings. I typed in 23, which you might think would be saved as an integer, but it's not. The input function always turns it to a string, which is something to keep in mind because it can trip you up later on. So as an extra micro challenge for you now that we've got all that working, let me just delete my print statements. I want you to create a variable called city, which is going to ask the user what city they live in. And I also want you to create a variable called love to ask the user what they love doing. So go ahead and pause the video now, create those variables using the input function, and come back to see how you did. How'd you get on? Hopefully it went all right. Here's exactly the way that I'd have done it. So I'd type in here city equals input, what city do you live in? Like that. So we've got that, and I'm just going to copy and paste this just to save myself some time. Love equals input, what do you love doing? And that's that. So the user is going to get 4 questions to come up to them, and they are going to respond to them with specific answers. And these are going to be saved in certain variables that we can use in our code. Now, what we've got to do next, which we're going to do in another video, is to combine these answers together to create a sentence. So I'm going to leave that for the next video because this one's getting quite long. So I'll see you in the next video to finish off the Hello You project. Welcome back, you beautiful people, and in this lecture we're going to finish off the Hello You project, and you're going to have a cool new program that you can show your friends, and I'll bet you'll have a lot of fun with it. So in this lecture we're going to start off by seeing how we can combine pieces of text together using string concatenation. We're then going to learn how we can convert numbers into strings so they can be added into the text as well. And after that, we're going to look at how we can use Python's format function to do all of this conversion work for us and make it really easy to make elegant and highly complicated strings. And of course, we're going to finish off the Hello You project. So by the end of this lecture, you'll have all the skills you need to create text of any complexity in Python. Quite a lofty goal, so let's get into it. As you can see, I've gone ahead and taken a step back from our Python script and booted up the Python shell just so I can demonstrate to you a few of these concepts nice and easily without messing up our code. So the first thing I want to show you is how you can stick pieces of text together in Python. So let's say we have a string, a variable called a, which I'm going to set as the string part1. And actually I'm going to put that all lowercase. And if I press enter, there we are, we've saved a. Let's say I have another string called b, and I'm going to call this part2. Now, how can I stick these pieces together? Well, the way that we do this is we use the addition operator, which if you remember in Python is just the plus symbol. That's right, the addition operator in Python isn't just for numbers, it's actually to add together two pieces of compatible data, which is why it's better to think of them as operators rather than just plus symbols. So anyway, if I type a plus b, then what you're going to see is part1, part2 get stuck together. Now, a fancy word for sticking strings together is called string concatenation. In this example, we have concatenated variable a and variable b. As a side note, it's even possible to multiply strings. You can't multiply a string with another string, but you can multiply strings with numbers. Let me show you what I mean. If I type a times 3, then you're going to see it says part1, part1, part1. Now this is really useful if you don't want to repeat yourself, because here we've got the contents of A printed 3 times. One particularly useful use for this is when you're creating menu systems and you just want like a nice underline. So you might type an equals sign and times that by 20, and you can see you get a row. So let's say if I did equals times 20, then I did like print title, then equals times 20, you can see that you can imagine having a header with some text inside, and you can have nice equal rows without having to type equals loads of times, right? So it's very useful if you want to save time repeating yourself. Now here's the interesting thing. If I just go ahead and close idle and then I open up it again, so idle in here, okay, and I define A as part, and I define B as the number 1. Now watch what happens if I try to do A plus B. We get an error, right? And Python tells us it's a type error, and it says we can't convert int into strings implicitly. Basically, what this means is it couldn't stick together a string and a number. And it also, Python didn't convert the number into a string on its own. So this is because numbers and strings are incompatible data types. You can't really add them together. To make this work, we need to turn the number into a string. And the way that we can do this is using the str function, which you can see has gone purple, so you know we've got it right. So if I did A plus str of B, that's going to convert this 1. It's going to convert 1 into like 1. Okay, you can see the difference there. This is what it's doing. It's taking 1 and converting it into a string which contains 1. And then it's adding that to part. And what we'll see is it comes up part 1. So that's something to bear in mind. Numbers and strings are not implicitly, or they're not automatically compatible. You have to use the str function to make them compatible. Now, this string concatenation business is all cool, but it's a bit long-winded, right? I mean, imagine if we had parts A, B, C, D, E, and F. I mean, that's a lot of plus symbols, and it's not very flexible. There must be a better way, right? Well, there is, and it's called the Python format function. So how does the format function work? Well, the way that it works is that you create a string that works kind of like a template. So let me just show you. So let's say I put a placeholder there and a placeholder there. So these pairs of squiggly brackets are placeholders for some data, and we can choose what data goes in that place. So, and the way that we do that is we write the string, then type .format and choose what we want to go in each place. So if I put A and B, we'll see what comes up, part 1. So A went in the first placeholder and B went in the second placeholder, and it combined it all as a string. Now the very interesting thing about this is we didn't have to do this strb here. We just had to put B, which was initially a number. So the very interesting thing about this is format will format whatever data you put in here into a string, okay, and put it in the places that you like. But what if I wanted, say for example, B to go here and A to go here? Well, the most obvious thing I could do is I could change B and A, but that's a bit that's kind of a bit of a hassle as this gets longer. You know, if you've got C, D, E, and F. But what you might want to do is you put A and B, and then inside here you actually put numbers. So you put 1 and 0. The numbers start from 0 and they count up, and they refer to the things here. So A would be 0, B would be 1, C would be 2, D would be 3, and so on. So now when I run this, we see it says 1-part, because 1 is B and B went in there, and 0 is A and A went in there. So you've got some flexibility about how you can control the result. So now that we know all about string formatting and string concatenation and converting between different data types, let's go ahead and finish off our project. I'm going to go down here and open up our hello.u.py file. Now in here, we just need to create some kind of text. So let's create a string called string, and this is going to contain the base text, where basically the template for our message. And what it's going to do, we're going to have equals, and then we're going to create our string, and it's going to be in the form your name is blank, and you are blank years old. You live in blank, and you love blank. Now, the output string is going to be that string formatted with the first blank as their name, the second blank as their age, the third blank as their city, and the fourth blank as their love. So what's going to happen is it's going to take string, which is all of this, and it's going to format, name's going to go in there, age is going to go in there, city is going to go in there, and love is going to go in there. So finally, the last thing we need to do is just to print out the output string to the screen. Just like that. So if I save and run this, it's going to ask me my name. Let's say my name is Ziad, which it is. How old are you? 23. What city do you live in? Nottingham. And what do you love doing? Teaching Python. So when I do that, it's going to say your name is Ziad and you are 23 years old. You live in Nottingham and you love teaching Python, which is fantastic, right? I mean, that's pretty much exactly it. Honestly, you don't need to meet me in real life. That's all you need to know. So, wow, I mean, we've pretty much finished the project. We've now got a program which will ask a user for pieces of information. We can store that information in certain variables. We have now been able to stick in those values at any point in our text and format the text how we would like, and produce that and print it to the screen for the users in a customized message. So spot on. That's pretty much the end of that, to be fair. That's the end of that project. We've got quite a few things coming up next. We're going to one amazing thing about strings is that you can slice and dice them and take certain pieces and move it around. So we're going to be learning how to slice text and come on to build an email slicer project, which is going to be super cool. So make sure you check that out. But first of all, before we get onto that, we've got a couple of coding challenges to test what you've learned. And when you finish them, I'll see you in the next video for some super string methods. But be sure to share this project with your friends, and I'm sure you can have some fun filling in the blanks, right? So I'll see you in the next video, and take care. That's all then. Hello there, you beautiful people. Now, strings are present in pretty much every single programming project, and because strings are everywhere, Python has provided us with plenty of inbuilt functions that make doing many common everyday tasks with strings simple and easy to do. So in this lecture, we're going to go over some of these useful functions that allow you to do things like find a word in a certain paragraph, or count the amount of times a certain piece of text appears, or remove certain pieces of text from a string. So by the end of this lecture, you'll have greatly increased the knowledge of the Python string toolkit, and you'll also be able to leverage the power of Python's inbuilt functions for working with strings. And what this means is you'll be able to spend more time building and creating your projects, and you'll spend less time getting bogged down in the details, and that means more programming fun. So let's jump right in. Okay, so the first thing I want to talk to you about is how these special string functions work. Well, they're known as string methods. And by the way, a method is basically just a function, but it's specific to a certain data type. So string methods are just functions that are specific to strings. And the way that we use a string method is something like this. You have some string, you type a period, then you type the method name and a set of parentheses. So let's break this down. The first thing we need to have is a string, right? So step number one is to type some kind of string here. This could be, I don't know, it could be like hello. Okay, so you type your string there. Then you put a period or a full stop, and then the method name or the function name. So, for example, one of the string methods would be count. And then you put some parentheses, and in here you might put some other pieces of data. So in here I might put e. So for example, this would say on this string, hello, count the amount of times that e appears. And when we do that, we get back 1. So let me show you another example. Let's say we have a variable called text, and inside here we're going to have the text happy birthday. Okay, now what I can do is I can do text.count. Let's say we wanted to see the amount of times the letter A appears in text. I could type that and it would tell me 2 because A appears here and it appears here, which is 2 times. So you don't need to have the literal string here. You can actually have a variable which contains that string, which is super useful. And by the way, when you use the count function, it doesn't just have to be one letter. So for example, I could do text.count, let's say day. Okay, and if I do that, it's going to say once, because day appears once in happy birthday. So I hope that's super clear. Alright, so you've just learned how to count the amount of times a piece of text appears in a certain string. The next thing I want to show you is how you can quickly convert a string into uppercase, lowercase, title case, and capitalize it, which is useful for all sorts of data validation, making sure your text is in the right format. So let's say we have a string called x. If I go up here, x equals happy birthday. But notice that this time the first letter of each word are capital letters. Okay, so if I use the x.lower method, the lower method, what we're going to see is what that text would look like in lowercase. Okay, and likewise, you may have guessed it if you were thinking that far ahead, x.upper is going to give you that text in uppercase. Now, one thing I need to point out is that this lower and upper method are not actually modifying the original string. So if I type x again, we can see that it's exactly what we typed at the beginning, even though I just used the upper method here. You can see that it's still got lowercase letters in it. And the reason for that is because strings are an immutable data type, which means that they cannot be changed. Immutable means unchangeable, mutable means changeable. So that while they cannot be changed, they can be overwritten. So x is lowercase to begin with. As you can see, it's got some lowercase in it and a few capital letters. But if I type x equals x.upper and I run that, and then I show you what x is, you can now see that x has been changed to be the fully uppercase value. So when we were just running the method on its own, it was just telling us what it would be like if it was uppercase or all lowercase. But when we assigned x the value of itself in uppercase, that's what changed it. You can't change them unless you overwrite them, because strings are immutable. So let's go ahead and convert x back into lowercase to make our happy birthday message a lot less aggressive. So if I just typed x.lower, we're going to see it in lowercase, but x won't have changed. But if I type x equals x.lower, we can now see that x is all lowercase. So another method that I want to introduce you to is the capitalize method. So what this does is it takes any string and turns just the first letter into uppercase. Now, capitalize is spelt with American spelling. So instead of the S, you put a Z, like this. So x dot capitalize with a Z. And that is going to show us basically it's going to take just the first letter, which is H, and turn it into an uppercase version of itself. But again, X hasn't actually changed because we didn't overwrite it. So I'm going to go ahead and make a bit more space by just typing enter a few times. Okay, so what if we wanted to capitalize the start of every word? Well, for that, we'd need to use the title method. So if I type x.title, you're going to see now that H has been capitalized because it's the start of the first word, and B has been capitalized because it's the start of the second word. But again, remember, because we didn't overwrite it, X hasn't changed until I write X equals X.title, and now X will have been changed. Now, sometimes when you're working with logic, which we're going to come on to in a later section of the course, you might want to know whether a piece of text is lowercase or is uppercase or is title case, etc. So the way that we can do that is with the, for example, if you wanted to check if X is lowercase, it's not, but look, what you type is x.is lower. And when it runs out, it's going to tell us false, basically because X isn't lowercase, right? So what if I did x.is upper? If that's out of the way, x.is upper will also tell us false because it's not uppercase. But if I do x.is title and run that, it's going to tell us true because X is indeed title case because the first letter of each word is capitalized. We can also find if text contains just letters. So for example, x.is alpha is going to tell us whether everything in X is letters. So if I do that, it's going to say false. And the reason it's going to say false, if I show you X again, is because X actually contains a space, and a space isn't a letter. So this just shows you sometimes how you can be expecting one answer, but a computer gives you the other thing because it's just so picky about what it works with, right? So if a space is in the text, x.isAlpha is going to give false. But if I had another piece of text like ABCD and I did is alpha on that, that's going to tell me true because there's no spaces and it's all letters. You can also check whether a piece of text contains just numbers using the isDigit method. So if I do x.isDigit and run that, it's going to tell us false because obviously X isn't all numbers. But if I had 1, 2, 3, for example, and I did isDigit on that, that's going to tell us true because this contains all numbers. You can also check whether a piece of text contains only alphanumeric characters, and by that I mean the text only contains letters A through Z and numbers 0 through 9. So if I had another piece of text called Y and I set that equal to happy birthday 123, and I did Y dot is alnum, so for is alphanumeric, then that will tell us true. But if I add any other kind of punctuation, so if, say for example, if I did Y equals happy birthday exclamation mark 123, and I did Y dot is alnum, so I've only added the exclamation mark, and that's going to now tell me false because the exclamation mark isn't a letter or a number. So as this video is getting a bit long, I'm going to cut it short here, and we'll continue with a few more methods in the next video. But just as a quick review of what we did, we learned that the way that you use string methods is you have some kind of string, you type a full stop or a period, the method name, and a pair of parentheses, and sometimes you might put something inside of there. Okay, and the methods that you learned were the dot lower, the dot upper, you learned also the dot title, the dot capitalize, which allows you to put your text in all different types of forms. Capitalize turns just the first letter capital. Title turns the first letter every word capital. This turns everything capital, and this turns everything lower. You also learned ways to check whether things were lowercase or not and uppercase. So you got dot is lower, you got dot is upper, you've got dot is title, like that. And you also had a few other things to check whether strings contain certain stuff. So you had dot count to count the amount of times a letter appeared. So dot count A would count the amount of times A appeared. You also had dot is alpha to check whether things only contained letters. You had dot is digit to check that things only contained digits. And finally you had, actually let me keep that there, and finally you had dot is alnum, which checked whether your string only contained alphanumeric characters, which are letters and numbers. So use this lecture as a reference in the future, or at least just to know what exists. I'm not expecting you to memorize this stuff. We're going to get plenty of practice using it. But there's a few more things that I want to show you when you work with strings before we jump into the project. So we'll go over those in the next lecture. It should be quite a short one because we're nearly there. And then we'll start applying this in practice. Hello there, you beautiful people. Let's pick up where we left off in the last video. I've cleaned out the shell by opening a new one, basically. So let's get going. You can also search for pieces of text inside another. So, for example, if I did, say if I had X is happy birthday, and I did X dot index of birthday, right? This is going to give us back 6. And the reason for this is because every single piece of a string, every single letter has its own address, basically. It has its own index. And these indexes are just numbers, but they start counting from 0. So 0 would be H, 1 would be A, 2 would be P, 3 would be P, 4 would be Y, 5 would be this space, and 6 would be the start of our string birthday. But what if that string doesn't exist? Let's say if I did x.index of blah, 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 something like that. So if I did that, we're going to get what's called a value error, saying that the substring is not found. So either index gives you the index of where that string starts, or it gives you an error. Now, there is another way to finding certain small strings inside your big strings, and that is called the find method. So I could do x.find of birthday, and that's going to give us 6, just like index did. But the difference is, if I do x.find of some random text, instead of giving us an error, it's going to give us -1. So find is used if you don't want your program to crash in that instance, because -1 is still valid, right? It's not an error. But index is used if you want something to just hard stop if something goes wrong. So you've got a bit of flexibility there in how you want to use these methods. Do bear in mind, however, that these methods are case sensitive. So while x.index of birthday in lowercase is going to be fine, if I do x.index of birthday like that with a capital B, that's going to give us an error, say a value error saying the substring is not found. Likewise for x.find, if I do birthday lowercase, that's going to work, but x.find of the capital birthday is also going to give us the -1, which it got for just this random string up here. So make sure that when you use these methods that you match the case. And this is why, sometimes you use those dot lower and those dot upper methods, because sometimes you want to convert the string into a certain format before you try to find it, or you want to, make sure that everything works together fine. So that's just something to bear in mind there. So another thing that you can do is to strip certain pieces of text from the side, from either side of our string. So let's say we have a variable called y, and that is 0000000, happy birthday 0000000, like that. So we've got zeros on either side. We can strip off these zeros using the strip function. So y.strip 0 is going to give us happy birthday. So it removed all the zeros from either side of the string. But you can just strip one side as well. So y.lstrip 0 is going to just strip y from just strip zeros from the left hand side of y, like that. y.rstrip is just going to strip zeros from the right hand side of y. But if you just do general strip, that's going to do both sides. But do bear in mind that, again, because strings are immutable, this isn't actually changing the original y. Okay, this is just showing you what it would be like if you overwrote y with that thing, right? So strings are immutable, so you can't just change them that easily unless you overwrite them. Now, by default with the strip method, if you don't put anything in the parentheses, so say if I just did y.strip like that, it'll still work, okay, but nothing particularly happens. What it does if you don't put anything in the parentheses is that the strip method is going to strip away any spaces from both sides of the text. So why is this useful? Well, let's say I have an input, right, and I want to take someone's name. Name equals input of what is your name. Okay, and then I see this come up and I type Z and I accidentally hit a space, right, and I press enter. If I print that name, we're going to see that there is indeed, see, look, I can't drag any further, but there is indeed a space in that variable. And I could show you the length of it. Actually, the length of the name, you can find the length of a string using the len method. Length of name, it's going to tell me 4 because we've got 3 letters and a space. But if I wanted to prevent that error from happening, what I could do is when I define this input here, name equals input, whatever it is, dot strip. Okay, so what this is going to do is it's going to take this input function is going to give us whatever we put in. Then it's going to then we're going to use the strip method to strip off whatever this string is and then save that in name. So if I do that, it's going to ask me what my name is. I'm going to say Z, and I'm going to press many spaces like that. Now, if I print the name, it's just going to say that, but you can see, that there's actually no spaces at the end, and I can check the length of the name, and it's going to tell me there's 3. So even though I typed all of that, all of these spaces here, because I used the strip method on whatever was inputted and then saved it in the name, we've managed to strip off all the extra spaces, which can in fact cause a lot of errors and a lot of problems in your code if you don't take care of those up front. So it's a bit of a housekeeping kind of method, which is very useful. So with that, I think I'll bring to an end this discussion of all string methods, and as promised, I'm sure you've greatly expanded your repertoire of string methods and things you can do with strings by looking at this discussion. So in this lecture, we had a look at the find method, and the index methods. Let's start there. We had a look at the index method, which allows you to find the position of a piece of text within another, and if that piece of text doesn't exist, then it's going to give you a value error, which could potentially stop your code dead in its tracks. But you've got the option to use the find method as well, which will work pretty much exactly the same, except instead of giving an error when a piece of text doesn't exist, it's going to give you -1, which perhaps is a more friendly way of stopping your code or telling you there's a problem without crashing the whole thing. But it's up to you on how you want to design your program. Sometimes an error may be more appropriate. We also saw about the strip method. So you can use the strip method to strip away pieces of extra text from a string. For example, here we had Y with loads of zeros on either side. We stripped away the zeros, and that will remove zeros from the left and zeros from the right. Strip by default takes away both sides. You can just take stuff on the left, so L strip for left strip is going to remove them just from the left. R strip is going to remove them just from the right. And if you don't put anything inside the parentheses, like here, that will by default strip away any white space or any spaces that the user accidentally types. And this is very useful when you're taking input, like here, because the user might accidentally type a space, or in my case, loads of spaces. And by using strip, you can get rid of these issues and stop problems going on in your code later on. And also you learned about the len function, which is short for length, and that will find you the length of a string. Now you can look up all these and all the other things that are available for strings by going over to the Python docs. So I'll show you how to do that. Help, then Python docs, and you will see down here on the left we want to go into the Python standard library. So let's click on that, and there is if you look here in section 4.7, you can see the text sequence type, str. It's basically a string, isn't it? So let's click that. And if you scroll down to section 4.7.1, you can see string methods. So here you've got capitalize, you've got count, and other things like that. So there's quite a few of them. Is alnum, is alpha, is digit, is decimal. You've got things that we saw and new things for you to check out if you would like. So I will leave that there. Up next, we're going to be looking at an incredibly useful concept in Python, which is slicing. And yes, it is as cool as it sounds. Slicing allows us to take a slice of a string and play with it as its own little string. So this is useful for all kinds of things, such as moving around words and letters, as well as checking if certain pieces of text are how they should be, without checking the whole string, as a whole. So I won't spoil any of the good stuff here, but just know that slicing is super useful, and especially for our email slicer project, so you're going to want to know about it. So I will see you guys in the next video. Hello there, you beautiful people, and welcome to the Email Slicer project, where we're going to learn all about slicing up strings. Now, slicing is a very useful thing that Python allows us to do, and its simplicity really sets Python apart from other programming languages. Now, in this project, we're going to create an email slicer that will ask someone for their email address, and it will tell them what their username is and tell them who their email account is held with, or their domain name, which, in a very basic way anyway. So, before all of that, in this lecture, I'm going to explain to you what slices are, and I'm sure you'll agree by the end of it that they're super awesome. And by the end of the lecture, you'll know how to chop strings up to use just the information you want. So let's get into it. So what is a slice? Well, a slice, as you might imagine, is just a small piece of something larger. Now, for this to make any sense, we need to take a fresh look at what strings actually are. A string is basically a bunch of characters and letters that are strung together. So let's say if I have the string A, B, C, D, E, F, G, 1, 2, 3, 4, 5, and 6. Okay, so here we have a bunch of letters and numbers that are strung together to make a string. Now, in Python, strings are an iterable data type. Now, what the hell does that mean? Well, when something is iterable, it means you can go step by step along it until you get to the end. Iterable means you can go step by step along it until you get to the end. Now, each of these steps is called an element. So there would be one step, there's another step, there's another step, there's another step, and each of those are elements of the string. Now, each element also has a number that refers to its position. So this number is called an index, and by using the index, you can get to the element. So by using the index, you get to the element. Now, these index numbers start at 0. That means the first element is index 0, the second element is index 1, the third element is index 2, this would be index 4, index 3, this would be index 4, index 5, and so on. So the best way to show you this is if we had an example, a rather long word. So let's just say we have word equals supercalifragilisticexpialidocious. Okay, so let's just save that like that. Now, if you've ever watched Mary Poppins, then that word will make sense. If not, go ahead and watch Mary Poppins. Now, if we just want the first letter of this, the letter S, then we just have to take the first index, or index 0. Probably the best way to say it is the 0th index of the string. So we do that by typing word, which is the name of the variable, then opening up a pair of square brackets. And inside here, we type the number of the index that we want. So we want the 0th index, so we type 0. And that's going to give us S. Now, even though that I've just technically sliced out the letter S, the original data is still unchanged. So as you can see, I sliced out S, but it's still there in the original variable. And that's because strings are immutable, meaning they cannot be changed. So if you wanted to say it correctly, I mean, you could say that strings are an immutable, iterable data type, because they can't be changed and you can iterate over each element. So as a micro challenge for you, I want you to see whether you can just go ahead and pull out the letter P. Okay, so use just a mini slice to take out this letter P here from the string. So how'd you get on? The way that I do it, okay, is we know that this is the 0th index, this is the first index, and this is the second index, right? So what we do is type a word of 2, and that's going to give us the letter P. So what if we wanted to take more than one letter? Well, for this, we use a slice. Okay, these were just kind of picking out little elements here and there, but if we want to take a proper slice from the variable, then this is how we do it. So the format of a slice is like this. So you type a variable name, okay, then you open some square brackets, you put the index you want to start at, the index you want to go up to, and the step in between each element you want to select. So you have a variable name, in our case this would be word, and let's say we wanted to take we just wanted to take the word super, okay? Well, we want to start from index 0, because that's the letter S. Now the tricky part comes when you have end here. So we want R, right? We want R to be in our thing. So that's 0, 1, 2, 3, 4. This is index 4. But the way that end works is it is you put in the index of where you want to go up to, okay? So if we wanted to go up to, if we wanted R, we'd have to go up to the letter C, right? But not including it. So to take this word, we'd have to go up to here. Since here, this letter C has index of 0, 1, 2, 3, 4, 5, we put in there 5. And we want every letter, so we'd put 1 as the step. So let's watch that now. We see we get out the word super. We started at index 0 and included that one, and we went up to, but not including, the letter C. So that the letter C was index 5, so we put that there. We didn't want that, we just wanted to go up to it, and we wanted to go in one element every time. So if I just to show you what the step does, if I put 2 here, you see we get SPR, because this goes 0, go up 2, gets P, go up 2, get R. okay, but that's what the step's doing. But 1 was taking every single one. So as a micro challenge for you then, I want you to go ahead and create a slice that will take out the word Cali here. It'll take that out and print that to the screen. So go ahead, pause the video now, and try to use a slice to take out the word Cali from Word. So how'd you get on? Did you manage it? Well, here's the way that I'd have gone about it. I would know that the letter C is at index 0, 1, 2, 3, 4, 5. So I'd put that as the start. And I'd want to go up to the letter F. And the letter F is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so I'd put 9 in there. And I want every one, so I'd put a step as 1. And you see, we get Cali out. So if you got that, then absolutely fantastic. You're really getting ahead with string slices. Now, there are some shortcuts to using strings, which are super useful. So let's say we wanted to just take from the letter C all the way to the end. For that, all we'd have to do is type a word. Then the start was going to be 5, because that's where C is, right? And C is index 5. Then just type a colon. And Python is now going to automatically assume that I want from 5 all the way to the end, which is what we see here. Pretty handy, right? So here's another shortcut. What if I wanted to go from Cali, again, from the letter C, all the way to the end, but in steps of 2? Well, for that, I just type a word, move my mouse out of the way, word 5, and then just type another colon and 2. So you can see that we've left the end blank here, because it goes start, end, step, right? We've left end blank. We didn't tell it where to end, so it's going to assume that to go all the way to the end, but in steps of 2. And we're going to see that it does that. It goes C, then L, then F, then A. C, then L, then F, then A. I and T, and all the way up until the end. So that's a really useful trick as well. So what if we wanted everything up to index 7, let's say? So this is index 5, 6, and 7. So everything up until the L, but not including it. So for that, we would type word, leave the start blank, and type 7, just like that. And that is going to give us everything up to index 7. So since index 7 is the L, we're going to go up to L, but not include it. Okay, so that's something you've got to be aware of when you're using slices. It's always up to, but not including. If we wanted the L, we'd have to do up to 8, which is the one after the L. Right, so that would be that to get us the L. So if we go up a few lines, you saw that we typed 0 to 5 in steps of 1 to get super, right? And that will work fine. But now with our shortcuts, all we've got to do is type word colon 5 like that, because it's going to assume you want to start here at 0, and it's going to assume you want steps of 1. So if I just do that, we're going to get super straight away. So you can see just how much easier that is. Now this is super useful. You can actually reverse a string, well, the steps can actually be negative, right? And we can use this to reverse a string. So if I did word, and I just did colon -1, basically what that's going to say is go from the end to the start in steps of -1. And if I do that, we're going to see that we've actually just reversed the whole string in just one line of code. Now, doing that in any other programming languages is a monster, really. So being able to do that in such a simple way is a really powerful trick. So you now understand the basics of how to take slices, right? We know that strings are basically an iterable data type, which means they're made up of little elements. And each of these little elements has an index that starts from 0 that you can use to access that element. And when you take a slice, you put the starting element here, the starting index, then the way you want to go up to, and then the step. And we also know a few shortcuts here and there. But we have a main issue in that the way that I've been doing it so far is error prone. I'm kind of counting up the index from the beginning, and that can be time consuming and I can make errors, right? All it takes is for me to count one number wrong and I've messed the whole thing up. So what I'm going to show you in the next video is how to pretty much automate this process, right? Using Python's index function, which is a massively powerful trick when using strings. So I will show you that in the next video in the interest of time. So I'll see you there. Hello there, you beautiful people. So this is just another quick video about some useful tricks you can do when you're dealing with slices. The first thing I want to show you is you don't have to count from the very beginning in order to get up to where you want to go. So you can actually count from this end. So let's say I wanted U. Okay, I could count up 0, 1, 2, 3, 4, 5, all the way up until U, right? Or I could do word and count back from the other end. So this value here is actually index -1. So U would be index -2, okay? And there you see we get U. Let's say if we wanted this C, that would be -1, -2, -3, -4, -5. Word -5 should give us C, and it does. So this is a nice shortcut. You don't have to count all the way from this end. You can count from this end, remembering that the very end value is -1. So if you just want the very end value, you just type -1, and it's going to give us S at the end. But this doesn't solve the actual issue, which is that we're still counting, right, in our head as a human being, which can make mistakes. What we want to do is to leverage the power of the computer to do all the counting for us. And for that, we're going to use the index function. So let's say, for example, I wanted to just take the word Cali out. What I could do is I could type a word, and I want where Cali starts. So I could type in here word.index of Cali, okay? Because where Cali starts, let me just show you actually, let me just make it a bit simpler. Word.index of Cali is going to give us 5 because Cali starts at index 5, right? 0, 1, 2, 3, 4, 5. So and we want to go all the way up to Fragi, right? So Fragi starts at index word.index Fragi is going to give us 9. So what I could do is type word, then the first where I want to start at the index of where Cali starts, and I want to go up to where Fragi starts in steps of 1 by default, and it's going to give me out Cali because it's going to go from where Cali starts to where where Fragi starts, and that is going to pull that out. So using indexes, using the index function is a massive shortcut, right? I mean, it makes life so much easier to do it that way. Let's say if we wanted to take out the word docious. Okay, let's say we want to take this out. All we've got to do is do word of word.index docious, which is where it starts, right? And I want to go from there to the end. Just put a colon. It's going to assume I want to go up to the end and pull it out, which is fantastic. If I wanted to get out fragilistic, right? So I just do word of word.index fragilistic all the way up to where... Oh, I mean, to be honest with you, I could just do a exp, right? Word.index exp. Fragilistic, because I could just write expialidocious, or I could just write exp. Now, one thing you do have to bear in mind is that index only returns the first instance of that phrase that you're searching for. So if I wanted to get fragilistic again, okay, let's say I went like this, and I wanted to go up to word.index of e, I don't think that will work. It won't work, right? It'll just give us an empty string. And the reason is because the index of E, it finds the first E, which is over here, not this one. So if you wanted this one, you need to say where, you know, something longer starts, exp or expialidocious, or something that lets Python know that you definitely want this one rather than the first E, which is what causes this error here. So that's something to bear in mind. Awesome, so that's pretty much all there is to slicing, to be fair. Pretty easy, right? So let's just have a quick recap of what we've learned in the past 2 videos, just to make sure we've got everything down before we head into the slicer project. So we learned that strings are an iterable, immutable data type, and the fact that they are iterable means that you can access individual elements from the string. Each element is given its own index, and these start from the number 0. And you use that index to access the element. You also learned how to take slices from a string and how to take individual elements out. You also learned a shortcut for using the index by using the index function that can take a lot of the hard work of doing this out for us. Overall, you've got a pretty good understanding of what slices are and how to create them by now. So up next, we've got a quick quiz and coding challenge to check that you've fully understood what slices are. And after that, we're going to build our email slicer. So good luck in the quiz and the coding challenge, which you're going to need to get some practice and make sure you got it down. And then I'll see you in the next video. Hello there, you beautiful people, and welcome to the logic section of the Python Bible. It's very rare in programming that there's just one route for a program to take. Usually there's quite a few possibilities, and you need to do something different in each of the cases. Now this is where logic comes in. Logic is basically the key to building any clever program or anything really cool, and it allows your program what to choose when. So in this lecture, I'm going to give you an overview of this section of the course and tell you what you should be expecting to learn. And by the end of the lecture, you'll know where we're going next, and you should be suitably convinced that this section of the course is really going to be a game changer in your ability to program in Python. So let's get into it. We're going to start off by taking a look at the Boolean data type in Python. Booleans are the basic of all logic and are the building blocks for every logic system we ever want to build, so that's a pretty good place to start. You'll then learn what Booleans are and how to create them. Once we know what the little building blocks are, we're going to move on to some operators that we can use to build logic. These are called conditional operators. These conditional operators will allow us to do things like check if two numbers are equal to each other or bigger than each other and things like that. You're going to learn what conditional operators are, how to use them, and what they're for. After that, we're going to learn about a critical piece of the Python programming language that it has been absolute agony to hide from you up until now, and not knowing about them has really limited what we can do, even though we still made some awesome things. And what I'm talking about are if-else statements. These are how we build logic structures in Python, and it basically lets us do one thing in a certain case, and if that case isn't appropriate, we can do something else. So that's going to be a critical lecture. Then you're going to learn about special keywords such as not, or, and well, and that will make your logic more readable, more controllable, and more powerful. We'll also learn about something called the in keyword. So this is a super useful keyword in Python that basically makes it possible to check whether something is in something else. So clearly, we have got a lot to learn about in this section, but I promise you, your Python programming skills will be absolutely supercharged by learning and understanding this section on logic. It's almost impossible to think of a program that doesn't use logic in the real world, so understanding this section is absolutely critical to being a top-notch Python programmer. So hopefully you're suitably excited and committed to learning all about logic in Python, and in the next lecture, we're going to kick off by learning about Booleans, which are logic's building blocks. So I'll see you in the next video. Hello there, you beautiful people, and welcome to this lecture on Booleans and comparison operators. So what the heck is a Boolean? Well, Booleans are the building blocks of logic systems, and by learning about them, we pave the way for us to learn much more complicated things down the road. So in this lecture, you're going to learn what a Boolean is and how to create one, and you're also going to learn about comparison operators that allow us to compare two pieces of data and determine something logical about them. So for example, is x bigger than y, or is y equal to z, for example? Those would be some examples where you would use a comparison operator. So by the end of this lecture, you're going to know all about creating Booleans and using comparison operators to get your logic systems up and going. So let's get going. Okay, so what the heck is a Boolean? Well, Booleans are very simple data types and can basically only have two values, true and false. So let's go ahead and create a few Booleans. Let's say we had B is equal to true and C is equal to false. Pretty easy, right? So you can see here that idle has helped us out by turning the Booleans yellow so that we know that we've actually entered a valid value. Now, a common mistake is to spell Booleans all lowercase. So, for example, to have D is equal to true in lowercase like this. Now, you can see that that actually hasn't gone yellow. So if I try that, we're going to get an error, a name error saying true is not defined. So Python's actually looking for a variable called true, which doesn't exist, obviously. But if I did D is equal to true with a capital letter, that will work absolutely fine. Another common mistake that happens amongst beginners is that sometimes they type, let's say we had E, you type true within some quote marks like this. So yes, that is a text that says true, but if you look at the type of E, it's actually a string, whereas we want, like take B, we want bool, right? Type Boolean. This is just a string with the text true inside of it, whereas this is actually a completely different data type. It's a Boolean. This is just a string with the word true in it. So you need to understand that Booleans are a data type in their own right, just like strings, integers, floats. Booleans are also their own data type, and you define them just by typing them, but just with a capital letter. Okay, so just make sure you've got that concept down, and with that we can move on. Now, we don't normally create Booleans just by typing in their value. Normally we get them from doing some kind of logical comparison. So let me show you what I mean. Let me check if 2 is greater than 3. Now for that I need to make a logical comparison using the greater than comparison operator. So the way that I do that is 2 greater than 3. So this is a logical, this is a comparison operator that is comparing 2 and 3 to check if 2 is greater than 3, right? Now if I press enter, it's going to give me back a Boolean that's false. So this is how we normally get Booleans. We do some kind of comparison, and it tells us whether that comparison is true or false. So let's see if we can get the value true. Well, for this, we'd need to give a true, a comparison that was actually true, right? So for that, I could do 2 less than 3, because 2 is less than 3, therefore that's true. Okay, so if I just check the type of 2 less than 3, we see it comes back with a Boolean, because Python is going to evaluate this expression and it's going to give back a Boolean value. So you can see by doing these comparisons, this is actually how we create Booleans normally, rather than just typing them out like we did at the beginning of the video. So we now have got some idea of how we can check whether a number is greater than another. We can check whether a number is less than another. How do we check if they are equal? Well, let's say I wanted to check if 2 was equal to 3, which of course it isn't, but just bear with me. So what we need for this is the equality operator. So now if I try to just type 2 equals 3, it's going to give us an error, because we here have used the assignment operator, right? We've tried to assign 3 to 2, and it says you can't assign to a literal. You can't just make a number equal to another number. That doesn't make any sense. So to check for equality, we need to have the equality operator. And the equality operator is just 2 equal signs together. Okay, so this is an operator in its own right. So now we're checking, is 2 equal to 3? Is it equal to 3? And if we do that, it's going to tell us false, because that's not the case. Whereas if I did 3 equal, is 3 equal to 3 using the equality operator, then what that's going to give is true. So that worked absolutely fine there. So how can I check if two things are not equal to each other? Well, for that, I use the not equal to operator. So what's that look like? Let me just get some space here. Okay, so if the way that you do that is an exclamation mark, then an equals. This means not equal, not equal. So if I did 2 not equal 3, what do you think that's going to give me? If you guess true, then you'd be correct, okay? Because it is just checking, tell me, is 2 not equal to 3? It's going to say yes, right? Yes, it's not that. Yes, that's correct. So here is true. There's only really 2 other operators that that I need to show you, really, and then we've gone through all the comparison operators. So there is the greater than or equal to. So let's say if I did 4 is greater than or equal to 3. What do you think that's going to give? If you guess true again, then you'd be correct, because 4 is bigger than 3, so this makes sense. Any number that's greater than or equal to 3 will make sense. So if I did 3 greater than or equal to 3, what will that do? Again, that's going to give true, right? But if I had 2, if I did 2 is greater than or equal to 3, that's going to give false. Now, of course, as you may have guessed, you've also got the less than or equal to. So if I had 4 less than or equal to 3, what's that going to give? It's going to give false, right? But 2 less than or equal to 3 is going to give true. and same as 3. 3 less than or equal to 3 is going to give true. So there we have it. I mean, that's pretty much all there is to know about Booleans and comparison operators. It's more how we use them that actually makes the difference here. We now know that Booleans only have 2 values. They are true and false. And the way that you tend to generate them is by comparing or making a logical comparison between several pieces of data. So there are a few logical comparison operators. There is the greater than, there is the less than, there is the equality operator. Remember this one, it has to be 2 equal signs and not 1. If you just have 1, you're trying to assign the value to what's on the left, which is not what we want. We want to check whether they're equal, so we need the equality operator. You've got the not equal to. The exclamation mark means not, so you've got not equal. You've got greater than or equal to, and you have less than or equal to. So there are 6 of them. And you know, most of them are quite intuitive, right? The only ones that really might trip you up are these 2 here. So yeah, that's all you need to know there. So the thing that really makes these things come to life is what we've got in the next video, and that is the if statement, which we use to build up logical constructs. I'm not going to spoil it, but it basically uses these comparisons to tell the computer which code to execute when. So I have a quick quiz prepared for you right now, just to check your understanding of comparison operators, and after that we're going to jump right in to learn all about Python's if statement. So I'll see you in the next video. Hello there, you beautiful people, and welcome to this lecture on the if statement. This lecture holds the magic key to supercharging your programming ability, so be sure to soak up every last drop of knowledge from this lecture that you can. It's going to be so worth it, I promise you. So in this lecture, we're going to go over the if statement. You're going to learn what an if statement is, how it works, and how to use one to control your code. You're also going to learn about the else and else if keyword that will basically make you a logical genius in no time. So by the end of this section, you're going to know how to create logic in Python, and you'll be well on your way to creating smarter and more intelligent programs. So let's get into it. Okay, so first of all, what the heck is an if statement? Well, an if statement allows us to execute a certain piece of code only if a condition is true. Now this gives us fine-grained control over what pieces of our code are executed when, and allows our programs to be rather intelligent. Let's see what one looks like, right? So first of all, we type the if keyword, which you can see is all lowercase and it's gone yellow. You then type some condition, like what I was showing you before with the comparison operators, and then a colon. And then everything inside of this if statement will only be executed if this condition is true. So let me show you what I mean by this. I'm going to go ahead and create another file called if.py. So let me save this, desktop, Python Bible, if.py. So let me maximize this and we're good. So what I'm going to do is on the very first line, I'm going to type the word if, then the Boolean true, then my colon, and I'm going to press enter. Now you're going to see here that Python has immediately indented my cursor. And with when we use logic and all this kind of stuff where things go inside other things, called nesting, if you zoom out of the code, it makes the code look like it goes in and out and like moves around, and it kind of looks like a snake. Okay, so that's my personal reason why I like to think Python was called Python, but I think it was named after Monty Python, the old British comedy show. So anyway, that's an aside. Inside here, I'm going to print it worked. Okay, now I'm going to save and run this, and we're going to see that it prints out it worked. So let's break it down, see what happened. Let me open back up that code. I said that the way that you make your if statement, you have if, then a condition, then a colon, then something inside. All right, so let's just say the code inside. Well, the way that this worked is our condition, say if we did 3 is greater than 2, right? At the end of the day, that condition is either going to give back one of 2 values. It's going to give back true, or it's going to give back false, right? Now, whatever condition is here it's either going to give back true or false. If that condition gives back true, then the code inside the if statement will run. So by writing true here, it's basically just, it's got what the if statement wants. If I wrote false in there, the code won't run. So if I do this now, we see nothing happened, right? So only if this condition, whatever it is, comes back to give true, will the code work. So let's say I wanted to check whether a number was bigger than another one. Okay, so let's go back into our script. Where's the script? Right. So what I'm going to do is I'm going to create a variable called num1, and I'm going to set that equal to 100. I'm also going to create another variable called num2 and set that equal to 50. Now I want to check if num1 is bigger than num2. And if it is, I want to print num1 is bigger to the screen. So for that, I need to use an if statement. So let's just delete this and start from scratch. An if statement always starts with the if keyword, just like that. You can tell you've done it right because it's gone yellow. Then I need a condition. So my condition is going to be num1 is greater than num2. Now this condition, as we saw before, it's going to give back true or false, just like we saw in the last video. You then put a colon, hit enter, and the code's going to automatically indent. And I'm going to, inside this code, if that condition is true, I want to print num1 is bigger than num2. So if I save that and I run it, we're going to see that num1 is bigger than num2 gets printed to the screen. But if I change num2 to be 150, let's say, so now num2 is bigger, if I run that, we see nothing happens. Because what Python did is it checked, is num1 bigger than num2? Is 100 greater than 150? It came back with false. Therefore, the if statement won't run because the if statement only runs when its condition is true. So let me just set these numbers back to what they were to begin with. Okay, now we've got a condition. If this condition is true, this code will run. So how can we get something else to run if the condition is false? Well, for that, we need to use the else keyword. Okay, so let's say I would do else here, and let's say print num2 is bigger than num1. So if this condition isn't true, it will run this code. So let me show you. For now, num1 is bigger than num2, right? Because 100 is bigger than 50. So if we run it, it's going to say num1 is bigger than num2. Brilliant. But if I go back and I change it so that num2 is bigger, let's say make it 500 this time, now what's going to happen is it's going to say num2 is bigger than num1. Amazing, right? So now our code is being able to think and respond depending on the state of our variables. But what happens if I make these two equal to one another? It says num2 is bigger than num1, which isn't true, right? Now let me just break down why that happened. It first checked if num1 is bigger than num2. Okay, that's false because they are equal, right? 100 isn't bigger than 100. They're equal. And we told it in every other case, say num2 is bigger than num1, right? So when they're equal, because this is false, it's still going to print this, and that's not what we want. What we want to do is first check if num1 is bigger, and if it's not, check if num2 is bigger, and if it's not, they must be equal. So for that, we're going to use the else if or elif keyword. So let me show you what I mean. If num1 is bigger than num2, do this. Else, if, so elif num2 is bigger than num1, then print this. Print num2 is bigger than num1. Else, print num2 or num1. Actually, no. Both numbers are equal. So what happens here? If num1 is bigger than num2, print num1 is bigger than num2. Else, if num2 is bigger than num1, print num2 is bigger than num1. In every other case than these two, if both of these are false, just say both numbers are equal, which is what must happen. So if I run that, it's going to say both numbers are equal. Now, how cool is that? So if I go back in here and I change this to be 105, so num1 is bigger, it's going to say num1 is bigger than num2. And if I go in here and I change this to be 500, it's going to say num2 is bigger than num1. And if I change them both to be 500, it's going to say that both numbers are equal. Now tell me that isn't amazing. Epic. You've made a program that can think. Well done. So we've covered quite a lot in this lecture. So let's just have a quick recap to make sure that you've got it all. You first learned that an if statement is created using the word if in lowercase, followed by some kind of logical condition and a colon, which is the two dots on top of each other. When you press enter, the code's going to automatically indent to show you what's inside, what the code is that would run if this condition is true. That code will only run if the condition is true, and it won't if that condition is false. It's as simple as that. You then learned how to make something else happen if the first condition is false. So you'd have some condition here, you'd have some code, and then if that condition is false, you would run the second code, right? So it would check this condition. If that condition is true, it will run this. But if it's not, it will run this. If this condition is true, this code won't run. Okay, so that's where you use the else statement. Now, sometimes you want to check one condition, and if that's false, you want to check another condition. For that, you would use the else if. So you'd have condition 2, code 2, and you might have multiple of these as well. So you could have like condition 3, code 3, and otherwise you'd have code 4. So if the first condition is true, this code will run. If that is false and this is true, this will run. If that is false and that is false and this is true, then this will work. And if all three of these are false, then this one will work. Okay, so you can build up rather complicated logical systems using just these rather simple building blocks. So I'm sure you can begin to grasp just how powerful this can be in your programs, right? Especially when you can have variables in your conditions, and these variables can be updated from other parts of the program, and they can be automatically updating themselves and stuff. It's really, really powerful stuff. So there's still quite a lot of cool stuff to be coming up. Sometimes we want to combine multiple conditions together. So maybe you want to check whether two things are true, or if one thing is true or another thing is true in one condition. And being able to combine conditions together to make one condition is where we need logical operators, which are what are up next. So up next, I do have a coding challenge for you to check that you've understood this lecture. And after that, I'll see you in the next video to learn about logical operators to make our conditions a lot more powerful. Hello there, you beautiful people. Now, it's very common when we're working with logic to want to combine multiple conditions into one. And this is where logical operators come in. In this lecture, you're going to learn about the not, or, and logical operators. So by the end of this lecture, you're going to know what these powerful operators are and how and when to use them. This is useful basically everywhere in logic. In fact, without knowing about logical operators, you won't be able to do much real logic at all. So with that, let's get into it. So the first question is, what the heck are logical operators? Well, first of all, logical operators are different to comparison operators. Comparison operators like greater than, less than, equal to, and all those things we covered before, are used to compare pieces of information to make conditions. Logical operators, on the other hand, combine and modify the conditions to make bigger conditions. So comparison operators make conditions, logical operators combine the conditions together. So I'm going to start off by showing you the not logical operator. This is the simplest logical operator and basically gives you the opposite of what the condition would have been otherwise. So for example, not, you can see the way that it's gone yellow, not true gives false, not false gives true. So like for example, if I had not 2 less than 3, okay, 2 less than 3, what's that? That's true, right? So not true, false. What about not 3 greater than 1? Actually, that's going to be false again. Now, what about not 4 equal to 3? That's going to give true, because 4 equal to 3, that's true, not true, false. Now, we can use these logical operators in if statements. So, for example, if I had x and I set that equal to 10, and I had y and I set that equal to 20, and if I wrote the if statement, if not x less than y, actually no, if not y less than x, then print it worked. And we're going to see it says it worked. And the reason why, well, is y less than x? Is 20 less than 10? No, right? So that would come back as false. What's not false? True. So this whole condition here became true, and therefore this code worked. So you can see the way that the logical operator has managed to modify the condition in a rather simple way. Now we can actually represent this behavior in what's called a truth table. So down here I have a diagram of a NOT gate, or like a NOT operation. This is how they're drawn in circuit diagrams and things like that. So we have an input called A and an output. And instead of writing true and false all the time, but in these truth tables, people write 0 to be false and 1 to be true. And what you can see is that if A, or the input, is false, the output is true. And likewise, if you have the input is true, then not A, or the output, is going to be false. So basically, the NOT gate just gives you the opposite of the input, right? So with that out of the way, let's have a look at the AND operator. Now this is the truth table for the AND operator. You can see that unlike the NOT, which only had 1 input, AND has 2, right? So you've got A and you've got B, and you get 1 output. So the key thing about the AND is that it only gives you true if both of the inputs are true. So if A, another way of saying that is if A and B are true, then the output will be true. That's why it's called the AND gate. So if you look here, if A is false and B is false, you're going to get false. If either one of them are true, you still get false. But when A and B are true, you get true. So that's the AND gate. Let me show you an example of this in our Python code. So as an example, let's say we have C is equal to 10, and we have D, which is equal to 5. Now, if we have an if statement like this, if C is greater than 10 and D is greater than 1, print it worked. Now, why didn't that work? Okay, the reason why it didn't work is because, well, let's break it down. Is C greater than 10? It's not, right? Because C is 10. Okay, so is 10 greater than 10? That's false. So we've got false here. Okay, I'm just going to write this. False. We then have AND. And now what have we got here? We've got D greater than 1. Is 5 greater than 1? Yes, it is, right? So true. Now remember, when you have, this is basically input A, and this is input B. Only if both of those are true will you get true. Okay, so at the minute, we've got false and true, which is false overall. So this overall is false, which means the if statement won't run. Now, if I change it so that if C is greater than or equal to 10, okay, now is 10 greater than or equal to 10? Yes, it is. Okay, so we're going to get true for that. And is 5 greater than 1? Yes, it is. So we're going to get true and true, which is overall going to be equal to true. So this whole thing is going to be equal to true, which means if true, that means the whole code inside is going to run, doesn't it? So if I click that, There we go. So now, because both of the conditions are true, our code will work. So now I want to show you something that might blow your mind a little bit. Okay, we can combine not and together. Okay, to make a NAND, basically a not and. So let me show you what that is. At the minute, we've got this working, don't we? So what I want to show you is if I change C. Let me just take this and just make it just like it was before, right? So this won't work, okay? Because we have false and true, okay? That all comes to false, right? You're with me so far. This is exactly what we had at the top here. So what I'm going to do is I'm going to type if not, and then put in brackets like that, okay? Print it worked. So let's have a little breakdown of what this is going to do. Okay, now you remember from the BODMAS and math stuff that we did before, whatever's inside of brackets is going to be executed first. So let's start there. Is C greater than 10? Is 10 greater than 10? That's false, right? So that's going to be false. Is D greater than 1? So is 5 greater than 1? Yes, it is. So that's true. What's false and true? That's false, right? So this whole bracket here is going to be false. So this whole bracket here is going to be false. But what's not false? True, right? So now overall, just by putting the not there, it works. Even though we had the same and condition here as we did here, by taking the not of that, we managed to get the code to work, which is very useful. So the point that I'm trying to get across to you there is the way that you can use brackets to allow operations or logical operations to happen on each other, right? So we used a bracket here to say, take the not of whatever this bracket is, right? If I didn't have the brackets, what would happen is it would take the not of this and this. So that's super confusing, right? But it's the difference between taking the not of the whole thing and taking the not of just this one on the left. By putting the brackets, we say take the not of the whole thing. Without the brackets, we just take the not of what's on the left. So I know it's a bit confusing, but with practice, it makes sense. So in the interest of time, I'm going to cut this video short because we've just got one more logical operator to come on to, which is the OR operator. So I'll see you in the next video to talk all about the OR operator. Hello there, you beautiful people. So the final logical keyword, the final logical operator that we have is the OR operator. So what the OR operator does is it gives us true if input A or input B are true. So as we can see from the truth table, it gives us true if either one of A or B or both of them are true. So if B is true, you're going to get true. If A is true, you're going to get true. If A and B are both true, you're going to get true. But if they're both false, then you're going to get false. So basically, OR is a very forgiving type of logic. So you use it if you just want to check whether any of these conditions are true. So let me show you an example. Okay, so let's create a variable called C, and let's set that equal to 5, and D is going to be -1. So let's have our logic, our if statement, say if C is greater than 1, or in lowercase, sorry, or D is greater than 1, then print it worked. And that worked, right? So let's see why. So is 5, well, first thing it's going to check is C greater than 1? C is 5, so is 5 greater than 1? It is, right? So we're going to get true. Then you've got OR in the middle. Now, is D greater than 1? Is -1 bigger than 1? It's not, right? So that's going to be false. But because one of the inputs to OR is true, the overall thing gives us true. So that means the condition here is true. If I had if I had C... let's say if I had D is equal to 5, right? And had if C greater than 1 or D greater than 1, print it worked. Okay, so C's 5, right? Is 5 bigger than 1? Yes, it is. Okay, so we get true for that. Is 5 now, because D's 5, is 5 bigger than 1? Yes, it is. So now both of these conditions are true. And that also gives us true. The only way that this will fail is if both are false. So if I said if C is greater than 100 or D is greater than 100, print it worked. I can't spell. It worked. That's not going to work, right? Because C is 5. 5 isn't greater than 100, so you get false. And D is 5. 5 isn't greater than 100, so you get false. False or false? False. Okay, so that's how the OR operation works. Now you can combine this with the NOT, just like we did with the AND. So take, for example, if I did this, we know that that doesn't work, right? That comes false. But if I did a NOT here and put a bracket around all of this, now I'm saying take the NOT of whatever this gives. We know this gives false, so what's not false? It's going to be true, right? And now it's going to work. So that's how you can combine together NOT and OR to create a NOR, basically, which just gives you the opposite of what the OR would give. So combining together all these operations is how you make really, really powerful operations of your own. So let me show you a rather complicated example to show you what I mean about how you can combine these operators. Okay, now this is rather heavy, so bear with me, but it's going to show the point. I'm just going to give us some space here, and I'm going to create C equal to 6 and D is 2. Okay, C is 6 and D is 2, and I'm going to write this condition: if C is greater than 5 and D greater than 5, or C greater than 1 and D greater than 1, print it worked. Now I'm not going to press enter. I'm just going to walk you through what answer this is going to give. Okay, so let's start on the left, because that's how these things work, right? Let's start on the left here. C is 6, so is 6 greater than 5? That's true, right? That's going to be correct. Okay, so we've got true here. Is D greater than 5? No, it's not, right? Because D is 2, and 2 is not greater than 5. So we've got true and false. This whole bracket here is going to be false. Okay? So we've got false on the left side of an OR. Now on the right side here, we've got C is equal to 6. So is 6 greater than 1? Yes, it is. So that's going to be true. Now we've got D greater than 1. Is 2 greater than 1? Yes, it is. So this is true and this is true, which means this whole bracket is true. Okay, so we've got this whole bracket being false, this whole bracket being true. What's false or true? That's going to be true, right? So if I press enter, it worked. Okay, so this whole bracket became false, as I showed you. This whole bracket became true. False or true gave true. The whole condition was true, which means this code was ran. So I know that was a bit hardcore, but that's how these conditions are combined together to make more powerful conditions. What we'd be checking is if they're both bigger than 5 or they're both bigger than 1, run this code. Okay, so in plain English. So that's a very powerful ability to be able to combine all of these things together. And actually, to be honest, you could go another level if you really wanted, just for example purposes. We know that this works, right? That works. But I could make it not work by putting a bracket around all of this. I could make it not work, putting a bracket around all of it and typing not. Okay? And now that won't work because it was true. Not true is false. So now this whole condition is false and it didn't work. So you can combine and mix and match these operators as much as you like, which is a massively powerful ability. Phew, well, after all that logic, my brain is starting to hurt. So let's have a quick recap to make sure that we've got it all. So in the last lecture, we started looking at the not condition. The not condition basically reverses what you'd get otherwise. So not true is false, and not false is true. Simple. After that, we had a look at the and condition. The and condition only gives you true if both inputs are true. So if A and B are true. Then we had a look at the or condition. The or condition gives you true if A or B are true. So if either of the inputs are true, or is going to give you true. It also gives you true if both of them are. So or is like a more flexible and. Now we can combine these nor and or. Oh my god, that's so confusing. But you can combine these three conditions to make more powerful conditions like the one that we saw here. Now obviously this is a lot to take in, and the best way to do it is by practice and try and get in real life in your code. Trust me, when you know what you're looking for and what you're trying to program, all of this is really easy to do. So to help with that and to help give you some practice, I've got a multiple choice quiz up next to help you solidify the concepts, and then after that we're going to have a section review and move on to the data structures section of the course, which lend themselves very well to being worked with logic. So we should have some quite good practice there. So up next you have the multiple choice quiz, which I wish you the best of luck with, and I'll see you in the section review. Hello there, you beautiful people, and welcome to this section review of the logic section of the course. Now, I'm sure you'll agree that what we've gone over has probably just been a game changer in your ability to program in Python. So let's take a step back and have a look at what we learned. So first of all, we started looking at what Booleans were, and we learned that they're a data type in their own right, and they have one of two values. They can either be true or false. And the way that we tend to get Booleans is by using what are called comparison operators. So comparison operators compare several pieces of data, and if the comparison about them is true, you're going to get a true Boolean, and if the comparison about them is false, you're going to get a false Boolean. So comparison operators are like greater than, less than, greater than or equal to, less than or equal to, and not equal to. Now, the one thing that you've got to bear in mind is when you check whether two numbers are equal, make sure to use the equality operator, which is two equals symbols, rather than the normal one equals symbol, which you use as the assignment operator. Okay, so after that, we had a look at if statements. Now, if statements are the way that you can tell Python to run certain pieces of code or not, depending upon the case. So if statements basically each have a condition, and if that condition is true, or using some comparison operator, then the code will run. If it's not, then it won't run. And you learnt about how to use the else if to check for another condition, or how to use else as a catch-all for every other possible opportunity. Then we moved on to how to combine together multiple different conditions to make one big condition by using logical operators. In here we learnt about the not condition, which basically reverses what the condition would be otherwise. So not true would end up being false, and not false would end up being true. You also learnt about the and condition, which only works if two inputs to the and are both true. And you learnt about the or condition, where if any of the inputs to the or condition are true, the output will finally be true. So as a quick summary, if you understood all of that and you're feeling comfortable with all of that, then brilliant. You're definitely ready to move on to the next section of the course, which is about data structures. So data structures are pretty much a way in Python to combine together pieces of information into one nice, easy to use place. So I won't spoil it for now, but I'll see you in the next section where we're going to be learning all about data structures. So I'll see you in the next video. Hello there, you beautiful people. We now know a lot of stuff in Python. As well as knowing about variables and if statements for creating logic, you also know how to use strings, integers, floats, and Boolean data types, which is awesome. These are the building blocks of a lot of Python programs, and you should be super proud of yourself for making it this far. You've really, really learned a lot, and I'm very proud of you. So sometimes, believe it or not, it's actually inconvenient and inefficient to have these little pieces of data floating around, each with their own variable name. Python data structures make it possible to group massive amounts of data together and store them all under one variable name. Now, data structures make it possible to operate on thousands or even millions of pieces of data all at once in a single line of code. Crazy, right? So Python gives us a variety of data structures that we can use, including lists, tuples, and dictionaries. And in this section, we're going to teach you all about all three of them. We're going to cover what they are, how to make them, and some cool stuff that you can do with them. You're going to be building 2 projects in this section, which is quite cool, right? So first of all, you're going to build Travis, the ridiculous security system. Travis will have a list of known users in his security database, and he will be able to detect an intruder. However, Travis is ever so polite, so whenever he finds an intruder, he's just going to ask them if they want to be added to the list. This project will teach you all about combining logic with your Python data structures, which is an incredibly powerful ability, so you'll want to watch out for that. You're also going to be building a cinema booking simulator. The cinema is going to have a list of films with their appropriate age ratings and the amount of seats left. When a user comes to buy a ticket, the computer will ask for their age and check if there are enough tickets left before allowing the user to buy a ticket. Nice, right? So by the end of this section of the course, you're going to know about Python's data structures, how to make them, how to use them, and in what circumstances each type of data structure works best. So in the next lecture, we're going to jump in and discover the first and most common type of Python data structure, which are lists. So I'll see you in the next video. Hello there, you beautiful people, and welcome to this lecture about the most common of all Python data structures, lists. So in this lecture, you're going to learn what lists are, how to create them, and some things that you can use them for. We're also going to see how to add things to a list, how to get data from a list, and also how to slice a list into little useful pieces. So in the process, you're also going to learn how to create tables and matrices in Python, and you will also be introduced to Python's very useful in keyword, and you're also going to learn how to combine lists with logic. So let's get cracking. Okay, so first things first, how do we create a list? Well, we create a list by using square angle brackets. So let's say we had a variable called our list, and we set that equal to a list with 5 numbers in it. We would type our list equals, then open a pair of square brackets, and in here I'm just going to put 5 numbers with commas in between them. So let's say we've got 27, 46, minus 5, 17, and 99. Okay, now when I press enter, that's gone and saved itself in there. Now when I print our list, we're going to see that we had 5 numbers printed to the screen rather than just 1, which, you know, before when we use normal variables, you could only just get 1 value out. So that's pretty nice and easy, right? And if we use the type function, just to show it to you, type of our list, it's going to tell us that it's a list. Nice and straightforward. Now, a really cool thing about Python lists, unlike those in other languages, is that Python lists can have multiple data types inside them. For example, you can have a list that contains numbers, strings, and booleans. So for example, if I create a list called Jackson, and I set that equal to, inside here, A, B, C, 1, 2, 3, do, oops, I need a comma, do, re, mi, true, and false. Okay, so if I do that, that's all going to work fine, and that's totally valid code, and most of it is also a musical classic, which is a nice bonus. Now, lists in Python are an iterable data type, just like strings are. Now, if you remember from our previous discussion on strings, and if a data type is iterable, that means it can be broken up into little pieces called elements. And each element has its own index, which start at 0 and they count up from there to allow you to access the element. So for example, the letter A inside Jackson here would have index 0, this would be index 1, this would be index 2, and so on. So 2, 3, 4, 5, 6, 7, 8, 9, and 10. Okay, so how can I access a specific element? Well, the way that I can do it, let's say I wanted to just get the number 2 from here, right? That's 1, 2, 3, 4, oh sorry, 0, 1, 2, 3, 4, index 4. So the way that I'd type it is I'd say Jackson, open up some square brackets and type the index in there. Now when I press enter, we're going to get back 2 because number 2 is at index 4. What if I wanted to get Ray? Well, this is index 4, index 5, index 6, index 7 should be Ray, the string. So Jackson of 7. And we're going to get that out. And you don't have to count all the way from the start, like we discussed before. You can count back from the end. So let's say if I wanted this, the element at the very end has index -1, and this one would have -2, -3, -4, -5, and so on. So let's say if we wanted true, what we'd have to type is Jackson of -2. And if I press enter, that's going to give us true. So that's how you can get certain elements from a list. Now you can save these elements in variables as well. So let's say if I wanted to get just dough, I could say x equals Jackson of 0, 1, 2, 3, 4, 5, 6, 7. And, oh no, not 7, 6. And what that's going to do is it's going to hopefully save in there dough. So you can see you can take little pieces out like that. So what if you wanted to take out more than one element? Well, for this you need a slice. We've discussed slices previously in the section on strings, so go back and have a look at those lectures for more information, but I'm just going to give you the basics of how it works. So let's say we wanted to take out from Jackson A, B, C, right, into its own little list. Well, the way that we do that is we would basically say Jackson, open up some square brackets, just like we were doing for one element, and you tell it where you want to start, then a colon, where you want to go up to, but not include, so I'm going to call that end, you don't include that one, and then the step, okay? The amount of steps you want to take in between each item, which defaults to 1. So let's say we want ABC. We want to go from index 0, because that's A. We want to go up to the 1, but not including it, which is going to be index 0, 1, 2, 3. Okay, and if we don't do anything, that Python's just going to assume the step is 1. So let's just do that. And you're going to see we get ABC as its own slice of the list. Now, if we look at Jackson, the original data, you're going to see that that hasn't been changed. And the reason for that is slices just take a copy of the original information. They don't replace it at all. If I did want to replace it, I would have to overwrite the list in some way. Now, this is where lists get interesting. Lists can have other lists inside of themselves. That's right. We're working with listception. Okay. So, for example, let's say we had a list called. Let's just overwrite our list and set it equal to 1, 2. Then we put another list inside, which was 3, 4, 5. Then we had 6, 7, and 8. Okay, so you can see we've got a big list here, and then inside of it we've got another list. So let's save that. That works fine. So how can we get this big list from in here? Well, it works pretty much in exactly the same way. So this is index 0. This is index 1. This whole list is index 2. So if I show you that, our list index 2, we get a whole list out. But what if I wanted to get the number 3? Just the number 3. Well, the way that I do that is what I would do. Okay, so you agree that this gives us this list. Okay, what index in this little list is the number 3? It's index 0, right? Because this is index 0, index 1, index 2 of the small list. So we just put another little bracket here, and we say we want index 0, and that's going to give us out 3. So we want index 0 of the second index of the big list. The second index of the big list is 3, 4, 5, and index 0 of 3, 4, 5 is 3. Likewise, if I had index 1 of that, we're going to get 4. And if I wanted index 2 of that, we're going to get 5. Okay? And these follow all the same slicing rules. So I could say I want from index 1 to the end. And we're going to get 4 and 5. Or I could say I want from index 0 to the end in steps of 2. And we're going to get 3 and 5. So you can mix and match in any way that you'd like, which makes lists really, really powerful. So why the hell would you ever use this, I hear you ask? Well, this comes up quite a lot when you try to create tables in Python. So imagine if we had a list like this. We're going to call it our table equals, we're going to have a big list, then inside there, we're going to have 1, 2, 3 in its own list. We're going to have 4, 5, 6 in its own list, and we're going to have 7, 8, 9 in its own list. So let me just put some spaces in here so it's a bit easier to see what's going on. So we've got a list with 3 lists inside of it. Okay. Now, what happens if we type in our table of 0? What do you think that's going to give? If you guess it's going to give 1, 2, 3, you'd be right. And likewise, we can do our table 1 and our table of 2 to get the other lists inside there. So to select any one number, we need 2 coordinates, effectively, don't we? Say if I wanted the number 2, I'd have to type our table 0 and 1, right, to get the number 2. So what this means is the first coordinate, if you can imagine with me, the first coordinate is basically acting like the row, because if you imagine like a telephone directory, like, you know, the keys on your telephone, the first coordinate gets us the first row, or the row of it. So row 0 is 1, 2, 3, row 1 is 4, 5, 6, and row 2 is 7, 8, 9. And the second coordinate basically gives you the column. So if I have, this is column 0, column 1, column 2. Let's say if I wanted 6, right? That's going to be on row 1, column 2. So what I do is our table, row 1, column 2, and we get out 6. So what do you think, let's say 8. What do you think you'd have to do to get 8? If you guessed you have our table, row 2, because starts at 0, 0, 1, 2, and then column 2, or column 1, 0, 1, you're going to get 8, okay? So you can see we've basically made a table with rows and columns. Now you can have lists inside of these other lists to make 3-dimensional cubes and so on, and go on for as long as you like. You probably won't ever need to, but it's possible. And hey, it might come in useful if you ever want to create a Rubik's Cube solving robot, or something that you want to keep a track of where all the colours are on the cube, for example. Now we can take slices of these smaller lists if we wanted to. So let's say I just wanted 5 and 6. Yeah, I go our table, it's going to be row 1, and I want from index 1 to the end, and we're going to get 5 and 6, and so on and so on. And it basically gives you a lot of control about what data you want, but it's more useful to think of these things just as tables. First you set the row, then you set the column, and you can use slices and things like that to pick specific data that you want. Okay, so I'll give you a break there, as we've covered quite a bit in this lecture, right? So let's just take a step back and digest it all before moving on to the next lecture. We first took a look at how to create lists. You saw how simple lists are to create, as all you needed was a set of square angle brackets, and just put the data inside with commas in between it. And after that, you learned that Python lists can hold multiple different data types at once, which makes them incredibly powerful, and we made a list that held strings, numbers, booleans, and lyrical genius all at the same time. You then learn how to access certain elements from a list by using the element index. Because lists are iterable data types, just like strings, accessing elements was the same as we've seen before when working with strings and slices. And yes, you can slice lists as well, and that works exactly the same. So finally, you learned how to create multi-dimensional data structures, like tables, by putting lists inside of lists and then using several coordinates like rows and columns to access the elements. Now, while you won't be using these every day, it might come in handy, and you've got this lecture for reference, you know, when you're building that Rubik's Cube solving robot that you've been dreaming about. So one thing to bear in mind is that slices don't actually modify the list in any way. That's just something to bear in mind. It just takes a copy of the data that you slice out. Now up next, we're going to move on to our next project, which is going to be creating Travis, the ridiculous security system. By building Travis, you're going to learn how to combine lists with logic that we learnt in the last section, and this is going to level up your Python skills so much that it's crazy. So I can't wait to show you, and I'll see you in the next video. Okay, so how useful are lists if you can't add and remove data from them automatically? The answer is not very. So in this lecture, we're going to go over how to add and remove data from lists, and you're also going to learn how to use the in keyword to check whether something is in your data or not. To illustrate these points, we're going to create a rather ridiculous security program. This program, called Travis, is going to have a list of known users, and every time it runs, it's going to ask for your name. If you are in the list of known users, it will welcome you and ask if you want to be removed from the list. If it doesn't recognize you, it will ask if you would like to be added to the list. Now, this is the most ridiculous security program ever, but it will let us illustrate how to do some pretty cool things with Python lists. So by the end of this lecture, you're going to know how to add and remove items from your Python lists, as well as check whether certain pieces of data are in your lists or not. You're also going to know how to combine all of this with logical if statements to control your code. And on top of all of that, you're going to have built an utterly useless program and hopefully had a few laughs. What's not to love? So let's get cracking. Alright, so the first thing we're going to want to do is create a new script. I'm going to call mine Travis.py because Travis is the name of our security robot. So let me just go to the desktop here, Python Bible, Travis.py, and click enter. Maximize the screen, and fabulous, we are good to go. Right, so the first thing we're going to want is a list of known users. So let's create that first. Known users equals Alice, Bob, Claire, Dan, Emma, Fred, Georgie, and Harry. Okay, so there's our list of known users. And there's quite a few of them, right? If we wanted to know how many there were, we could just print the length using len of known users. Now, when I save and run that, we're going to see it tells us 8 because there are indeed 8 users in this list. 1, 2, 3, 4, 5, 6, 7, 8. The length function basically tells you the amount of elements in your iterable. So that's a handy trick to what you're going to want to keep hold of. Okay, now I'm going to cheat a little bit to make Travis a lot more functional by using something that I haven't actually introduced you to all that much yet. So I'm going to type here while true and type a colon, then go on to the next line. Now this is going to create what's called a while loop. Now don't worry about this for now, as we're going to cover loops properly in the next section of the course. But in summary, this line here is going to basically make whatever we type inside of the while loop run over and over and over and over forever. Okay, next I'm going to make Travis introduce himself. So I'm just going to type in here print, hi, my name is Travis. Okay, now we want to ask the user's name and store that somewhere. So as a quick micro challenge, try and use what you've learned about user input to ask the question, what is your name? And store the answer in a variable called name. Pause the video now and have a go, then come back here to see how you did. So how'd you get on? Well, I'd have done it like this. I'd have just typed name equals input, using the input function, what is your name, like that. And just for extra security, I'm going to put the strip function at the end in case the user accidentally enters a space. So if you got that, well done. You're definitely learning something from the course, right? And you've internalized all this information. So now we're going to want to check whether that name is in the list of known users or not. So for that, we're going to need some logic. So let me introduce you to the in Python keyword. I'm just going to jump over to the regular old Python shell, and I'm going to make a list called L, and I'm going to put in that 152, L equals 152629. Okay, now using the in keyword, we can tell whether something is in something else. So if I type 2 in L, we're going to get true because the number 2 is in L. Now, how cool is that, right? That's quite nice. If I did 10 in L, it's going to give us false because 10 isn't in L. So we can use these in conditions in our program. By the way, this is like a superpower when you compare it to how you'd have to do this in other programming languages. So just trust me on that. It's ridiculous in other languages. So we're going to need an if statement. Let's go back in here. We've got their name, right? And we want to check if that name is in our list of known users. All we have to do, if name in known users. Okay, then we do something. We would print, let's say, name recognized. Yeah, and if it's not, we just need to type else, print name not recognized. So let's save and run and test that, okay? So let's say I come in, it says, what is your name? I type in Alice, because Alice is in the list, and it says name recognized. Then the loop makes the program start again. So what is your name? And let's say I put in Z, and it says name not recognized. So now we've got a way, just using the simple in keyword, that the program can ask us for a name, and it can check whether that name is in the list or not, which is brilliant. So one thing that I want to show you is Alice with a capital A work correctly, right? Now, you know that strings are case sensitive. So watch what happens if I just type in Alice in lowercase. It's going to say the name isn't recognized because Alice in all lowercase isn't in the list, but Alice with a capital A is. So we need to fix that somehow and allow our user to pretty much enter their name however they like. So we're going to do that next. But by the way, if you want to stop a loop running, you hold Control and C, and that's going to cancel the loop. I mean, this isn't a problem. It just says keyboard interrupt. I just stopped the loop working. So let's head back on over to our script. And now I want to see whether you can remember, how do you make the first letter of a string capitalized? Now, you may have guessed that we use the capitalize method, right? So what I'm going to do, if you did, by the way, that's fantastic. What we're going to do is when the user inputs their name, we're first of all going to strip off any white space, and then we're going to capitalize it. So you can see here that we've got one function, we've used a method on it, then we've used another method on that, and you can just stick on, like, you know, methods after methods after methods, as long as they're all the same data type, by just using the dot method, you know, and stuff like that. It doesn't matter how many you have. So now we're stripping off the white space and capitalizing it. So if I save and run it, we're going to see that if I type in Alice with a capital A, that works. It says name recognized. But if I type Alice with a lowercase a, it's also going to say name recognized, because internally it is saving the name as capital A, and then it's checking that. So we've given our user some more flexibility, which is nice and cool. So as this video is getting a bit long, I'm going to cut it here, and we're going to continue building Travis in the next video. So I'll see you there. Hello there, you beautiful people, and welcome back to this video where we're going to continue building Travis, the ridiculous security system. So at the minute, we have a computer program that can ask a user for their name, strip off any white space, capitalize the name, and then check if that is in a list of known users. But at the minute, we kind of print out these very formal name recognized or name not recognized messages, right? And Travis isn't like that. Travis is very polite. So we want Travis to be able to say, hello, so-and-so, if their name is recognized. And for that, we're going to use string formatting. So as a micro challenge to you, I want you to go ahead and write some code that's going to print out the message, hello Alice, or hello Bob, or hello Emma, or whatever their name that they enter might be, as in this if statement here. So only if they are a known user. So pause the video now and print out to the screen a string that says hello, whatever their name is, using string formatting, and come back to see how you did. So how'd you get on? Was it all right? Well, this is the way that I'd have gone about it. I'd have deleted this ugly message here and typed print. Then inside here, I type hello, space, some blank, exclamation mark, then format inside that blank space their name. So the user's name is going to go in this blank space. So if they entered Alice, it would say hello Alice, or if it was Claire, hello Claire, or whatever it may be. So if you got that, or you managed to get the same functionality, then well done. You're honestly learning so much from this course, and I'm really proud of you now that you're applying these really complicated concepts. It's amazing. So now that we've replaced our ugly name recognized with a nice welcoming message, we want to ask the user whether they'd like to be removed from the database, because at the end of the day, Travis is pretty ridiculous. So let's create a variable called remove and ask them, using the input function, would you like to be removed from the system? Okay, and I'm actually going to put in y/n there so they can see that they've got to enter yes/no. Okay. So what that's going to do is the user is going to type in yes or no, right? Now, if we want to check whether they entered yes or a y, one way we could do it is this. We could have another if statement in here, and we could type if remove equals y, or remove equals capital Y, right? Because if they enter a lowercase y, this will be true. Or if they enter an uppercase y, this will be true. Then the whole condition will be true because we used an or statement. And then the code, whatever we put in here, is going to run. But that's kind of a bit ugly, right? Like before, I'm actually going to use the lower string method on here. So no matter what they enter, if they enter an uppercase y or a lowercase y, we're going to convert it to lowercase and save that in remove. So now all I have to do is just check if remove is lowercase, because we've already converted it to lowercase up here. We just have to check whether it's the lowercase y. So now inside of here, I'm going to want to remove the name from the list. Now there's a neat way to do this using the remove list method. Now list methods work exactly the same way as string methods, it's just they are for lists. So all we've got to do, if they want to be removed, we do known users dot remove name. It's as simple as that. That's how you remove someone from a list. So this is an excellent example of how Python makes something that could be incredibly complicated so simple and easy to read. This is going to remove the first occurrence of the name from the list. So bear in mind that we're going to remove the name. So say if there was Alice and Alice and Alice, if we just did remove Alice, it would only remove one of them. It would remove the first one that it found. So that's something you need to bear in mind. So this code is only going to work for us as long as the name occurs once. If it occurs more than once, you might need to use a loop to repeat the remove process as many times as necessary, but we'll save that discussion for another day. So let's just check this is working by printing out the list before and after the removal. So in here, I'm going to print the list. And down here, I'm going to print the list as well. Let me just get rid. Is there anything else I need to remove? Yeah, I just want to get rid of this bit up here where we print the length of the list. We don't need that. So let me just run this. It's going to say, hi, my name is Travis. What is your name? I'm going to say Alice. Hello, Alice. So our string formatting worked. Would you like to be removed from the system? Let's click yes. Okay. So at the beginning, we've got Alice, Bob, Claire, and that's what it was at the beginning. Then we removed it and we printed out the list again, and you can see that Alice has disappeared. So that's fantastic. We've managed to remove Alice from the system as we wanted. So now sometimes instead of deleting a specific value, let me just cancel the program here. Sometimes instead of deleting a specific value, you want to delete a specific index or a certain slice of indexes from a list. So for that, you'd use the del keyword. At the minute, we've searched for the value Alice and deleted Alice. Maybe we just want to delete index 1 or index 2 without really knowing what that value is. So for that, as I said, we need the del keyword. So if we create a list called L, and I create, it's 1, 2, 3, 4, 5, whatever. Let's say I want to delete the first index. For that, I'd use del L of 0. Okay, and that's just going to remove that from there. So L is going to be here. So I can't do L.remove 1 because I didn't know, hypothetically, that 1 was in the list. Okay, if I didn't know what the value was, I just wanted to get rid of the index, whatever was there, then I would use the del keyword. If I knew specifically what I wanted to delete, then I would use the remove keyword. Another reason to use del is because, do you remember when I said that the remove keyword only removes the first instance? So let's say if I had something like, let's call this list example, and I had A, B, C, A, and A, and B. Let's do that. Okay. If I do example.remove A, and I look at example again, it's only got rid of the first one, right? But A is still here. So let me recreate it. What if I wanted to get rid of this one? Well, I know that that is at index 0, 1, 2, 3. Okay, so I would use del example 3. And that now, if I show example, has gotten rid of that A right there. So it gives you a bit of flexibility on how you want to remove things. So this is definitely a useful keyword you're going to want to keep in your back pocket. Oh, and by the way, yes, you can delete slices using the del keyword. So example at the minute is ABCB. So let's see if I wanted to get rid of just the first two elements. What I could do is del example 0 to 2. So because 2 is here, we want to go up to there. That's going to cut from there backwards. And now if we look at example, you can see that we've only got CB left. So you can cut out slices as well. Okay, so we're nearly there. I mean, let's just go back to see what we've done. We've currently got a list of known users. The computer is going to say hello, very politely, or good old Travis, and it's going to ask the user for their name, strip off any white space, and capitalize it so that we can compare it with everything else in our database. Now, if the name is in our list of known users, we're going to print hello, so and hello that name. So if their name was Bob, hello Bob, and then ask them if they'd like to be removed from the system. And if they enter yes, say they enter it in whatever case, it's going to be turned to lowercase, and that's going to be saved in remove. If remove is lowercase y, meaning that they entered yes, then we're going to basically remove the list of, we're going to remove that name from our list of known users. And I'm just going to get rid of this this printing because that was just for demonstration purposes. So we're nearly there. All we've got to do now is we have to see if their name isn't in the list of known users, right? So if they are an unknown person, we want to say that we don't know them and ask if they'd like to be added to the list. So we're going to save that for the next lecture because this one's also getting a bit long. And I'll see you in the next video to finish up our work with Travis. Hello there, you beautiful people, and welcome back. Now in this video, we're going to finish off building Travis. So we're nearly there. We've just got to do something if the person isn't recognized. Well, first of all, because Travis is a very polite security system, we're going to get rid of this ugly message that says name not recognized. And we're going to put something a bit more friendly. So I'm going to make it say, I don't think I have met you yet. Then put that in there, the name. So if their name is Dan, I don't think I've met you yet, Dan. Now that's much better. So we then need to ask them whether they would like to be added to the list. So let's do that with an input statement. I'm going to create a variable called addMe equals input. Would you like to be added to the system? Tell them yes and no with the options, question mark, thing like that. We're just going to, I'm actually going to go up here and add a strip and lowercase, and then down here add a strip and lowercase. So now we've basically going to get the person's input. If they enter Y, it's going to, that means they want to be added to the list. So now we need an if statement to check for that. So if addMe equals Y, now we just need to add them to the list in here. Okay, so I'd like to show you how to do that. The way that we can add people to a list is use the append list method. So let me show you how we do that. We just type known users dot append that name. And it's as simple as that. The append method is going to take whatever you put inside of it. In this case, let's say it was, I don't know, John, right? If their name was John, we're going to append John to the end here. So let me show you that in example. We print the known users before we append, and we're going to print it after. Now let's save and run the code. And we're going to see, my name is Travis, what is your name? Let's say John. I don't think I've met you yet, John. Would you like to be added to the system? Let's say yes. We can see at the beginning that John isn't in the list. Then we append him, and he comes right to the end here. So that's how you can append names to, or append any item to a list in Python. So we're pretty much there, you guys. Let me just go and have a look at this code again to make a few finishing touches. So I'm going to first get rid of this whole print thing that I just used to display the point to you. Then we're going to get rid of that. Okay, now let's say they enter no to any of these things. So let's say if remove is yes, then remove them. Else, if remove is no, then print no problem. I didn't want you to leave anyway. Okay, so that's the first one, giving him something nice to say, and then we can just down here, elif add me equals no, then known users, oh no, not known users, print no worries, see you around. And that is pretty much it, you guys. Now, the cool thing, because I've got it in, let's cancel this. The cool thing, because I've got it in this while loop, it's going to continue to run over and over and over again. So let me show you what happens. My name is Travis. What's your name? Z is my name. I don't think I've met you yet, Z. Would you like to be added to the system? Yes. Hi, my name is Travis. Now, if I enter my name again, right? Hello, Z. Would you like to be removed from the system? Let me say yes. Hi, my name is Travis. What is your name? Let's say Z again. So you can see the way the list is updating on each loop of the program, which is amazing because now we're keeping a data structure, or pretty much a database, isn't it, really, that is being continually updated and kept in the computer's memory that we can do with whatever we want. And it contains more than one piece of data. So I hope you can see just how powerful that is. So I'm just going to click no here. No worries, see you around. And that's the end of that. Hello there, you beautiful people. So now that we've got Travis fully operational and up and running, there are a few more ways to add things to lists that I want to show you. So the first is just to use the addition operator. As we can tell, this operator has a lot of different uses. So lists, only lists can be added to lists. So for example, if I create a list called A, and I set that equal to 5, 12, 72, 55 and 89. What that's going to do, that's going to be absolutely fine. But if I want to add the number 1 onto the end here, if I try to just type A equals A plus 1, we're going to get a type error. And that's because you can only concatenate lists with lists and not integers. Now, the way that we can fix this is, well, first of all, of course, we could just use the append method that I showed you before. Or what we could do is we could type A equals A plus 1, but put the 1 inside a set of square brackets. And that is basically going to say, okay, add to A this list with just the number 1 in it. And that's going to work absolutely fine right there. But what if we want to add a string? So if I try to do A equals A plus BCD, let's say, this is still going to give a type error because you can only add lists to lists and not strings. However, because strings are an iterable data type, there are 2 ways to fix this issue. So first of all, we could do A equals A plus BCD and put all of that inside a list of its own. And we're going to see that you have just one element added on to the end. But the other option, so that's the first option. The other option is to use the list method. Now this is going to do something quite different. So if I do A equals A plus list of BCD, this is going to do something quite different. We're going to see here that instead of just adding BCD as one whole element, it's added B as an element, C as an element, and D as an element. So each of the elements of the string has been added as its own element to the list. Now you can't get this functionality for integers, and the reason is integers aren't iterable data types, and therefore they can't be converted into lists. So if I try to do A equals A plus list of 1, 2, 3, that's not going to work because, as it says, integer object is not iterable. But numbers are also kind of easy to work with in the sense that all we'd have to do is type A equals A plus 1, 2, 3, like that, and that would add them individually on the end. There is another trick though when you're working with numbers. Say for example, because I can't convert numbers into lists because they're not iterable, but I can convert numbers into strings. So if I did a equals a plus the string 1, 2, 3, right? That won't work because I'm still just trying to add a string. But if I convert that string into a list, so I convert the number into a string, then convert the string into a list, we now see that we get 3 strings with each of the numbers added onto the end there. So that's another potential option you might want to explore. So I thought I'd throw that in there. So let's just reset A really quick to avoid any confusion as we go forward. So A is this. Let me just press enter to copy it to the next line. A equals. So what if I wanted to add a list of numbers, right? So instead of just doing A equals A plus 5, 6, 7, 8, let's say, that's just going to add them all individually. So what if I wanted to add this list as its own element? So the way that I'd do that is I'd go A equals A plus that 5, 6, 7, 8, just like we did before, but we're going to put another square bracket around it. And that is going to put a square bracket basically around that list and add it as its own element. So now it should be the final element of the list. So if I do A minus 1 to get the final element, we see that we get that list out. So that's a way that you can do that. That's how you can add in extra lists as their own elements. Alternatively, you could just use the append method to do that. So a.append the list. Let's try another one. 10, 11, 12, and 13. That's just going to add that as its own list again, you see, because I put a list inside of there. So there's loads of different ways to do these kind of things. But there is a very important issue that I want to flag up when you use the append method that can cause big problems if you don't know about it. And this issue is that the append method returns an empty value. So let me show you what I mean. If I have A, I'm just going to reset it again, just up here. So A shows up completely normal. If I do A equals A dot append 10, now if I try to look at A doesn't show up. And the reason is A.append 10 gave back some empty space. That empty space, because of the assignment operator, was then saved in A, which basically just deleted the data, right? So if I find the type of A now, it's going to tell me none, which is another data type, but it's basically blank space. If I show you the type of A.append 10, what is the type that A.append 10 gives back? Well, actually, it's not going to work because I can't append anything to an empty list. So let me just make a blank list like this. Now, if I do try and find the type, it's going to tell me none, right? Because the type of whatever the append method gives back is none, and we saved that none into A, which basically deleted the whole thing. So that's something to really be aware of. Now, at the minute, I'm just showing you how you can add things to the end of lists. But what if we kind of wanted to insert something at any point in the list? Let's just make A long again. Let's make it what it was before. Okay, so now we've got our original, we've now got our original A back. Let's say we wanted to insert 100 between the number 12 and the number 72. So for that to happen, we want the number 100 to kind of be inserted here, right, and move everything along. Well, here is index 2. So what we can do is A.insert, right? Use the insert method. We want to insert at index 2 the number 100. And if I show you that now, we can see that the insert A is inserted 100 at index 2. And you can also insert slices. So if I do A.insert at index 2, let's say we wanted to insert 10, 20, 30, like that. We've kind of put in together, we've inserted the whole list at index 2. So that's something to bear in mind right there as well. So insert is something else that's very useful. But notice as well, I'm not typing A equals A.insert, let's say 2 50 or 60. Because if I do that, now A has been deleted again, because this method, again, has returned none, and that's been saved in A, unlike string methods where you do need to do this. And the reason is lists are mutable data types, not immutable, they are mutable, which means they can be changed after you've defined them. If I had a string and I had it as 1, 2, 3, I can't change this. So let's try and turn the letter 1 into 5. It's going to give me an error. String object does not support item assignment. But if I had a list called A, and I had that as 1, 2, 3, and I tried to change the first letter of A to be 5, that's possible. Okay, because lists are mutable, strings are immutable. So in this insert method and the append method and methods like that, list methods, it's kind of changing the list behind the scenes. And that means you don't need to reassign A to the new value. So you don't need to type A equals A dot append 5, because if I do that, A has been, it's been turned into a non-type. Same goes for the insert method. So just be aware of those things right there. So over the last few lectures, you've now built a security system. You've learned how to combine data structures and logic by using the in keyword, and you also now know how to create lists, how to add things to lists, how to remove things from lists, which, by the way, the remove method as well, if I did A equals A, let's just make a thing called A123. If I did A dot remove 3, that's going to work fine. But if I tried to do A equals A dot remove 2, again, that's also done the none. So bear in mind that all these list methods pretty much work the same. So you now know how to add and remove things from lists, how to create them, how to use them with logic, and you also know a few things to watch out for. So well done. I mean, we're pretty much there with understanding how lists work. So up next, we have Python's second type of data structure, which is called the tuple. And tuples are very simple. They basically work exactly like lists. So we're pretty almost like lists. There's a slight difference. So we're not going to spend too much time on them. But that doesn't mean they aren't important. They all have their own place. So I'll see you in the next video for some tuple-y goodness. Hello there, you beautiful people, and in this lecture you're going to learn about another one of Python's data types, tuples in this case. Now, tuples are quite common in Python, but they're very similar to lists in how we use them, with just a few differences, so this lecture won't be long at all. By the end of this lecture, you're going to know what tuples are and how to make them. You're also going to learn what makes them different to lists and when you should use tuples for maximum effect. As an added bonus, I'm going to show you a cool trick that you can use to create multiple variables in one line of code. So let's go. Okay, so what is a tuple? Well, a tuple is simply a data type in Python that works very similar to a list. The only difference is that once you have created a tuple, it cannot be changed. So because a tuple cannot be changed once it's been created, tuples are called an immutable data type. So let's go ahead and actually create a tuple. They're rather simple to make. Let's say we have a variable called our tuple. We can create that by just having a bunch of values that we separate with commas. So let's say we have 1, 2, 3, A, B, and C. Now if I just do that and click enter, that is created our tuple. So I can check this by using the type function. If I do type of our tuple, you can see that it says it's of class or data type tuple. So that's easy enough. Now, while we can define tuples using only the comma, it's much more common, for the sake of clarity and being obvious about what we're doing, to actually surround tuples in parentheses, like this. So I'm just going to copy and paste that line and just put some parentheses around it. This is how we normally see tuples created in practice. This gives exactly the same result. As you can see, there's no errors. The type of it is still a tuple, but it's much more clear about it's much more clear what you're doing. So I'm going to stick to using this method in the future. Tuples are an iterable data type, just like lists and strings, and this means tuples are made up of little pieces called elements, and we can select each of the elements and slices of elements from tuples just like in lists and strings using the element index. So for example, if I had our tuple and I took the elements 0 to 3 using square brackets just like normal, it would give me a mini tuple of 1, 2, 3. So when you slice a list, you get a mini list, and when you slice a string, you get a mini string, and when you slice a tuple, you get a mini tuple. Simple. So the only real difference between tuples and lists is that you cannot change tuples after you've created them. Lists are mutable and therefore can be changed. Tuples, like strings, are immutable and cannot be changed after they've been defined. So if I make a list called our list, and I set that equal to 1, 2, 3, 4, 5, 6, 7. Now I can actually change index 2 of the list, like this, our list, index 2, and set that equal to 100. Now if I show you our list, we're going to see that 100 has replaced 3, because 3 was in index 2. So that works fine for lists. But if I try to do that with our tuple, let me show you what that is again. Our tuple is this. If I try to replace the 3, again, our tuple of index 2 equals 100, and I press enter, we're going to get a type error, and it's going to say the tuple object does not support item assignment. And you get a similar error for strings. So if I had 1, 2, 3, 4, 5, 6, 7 as a string, and I tried to, let me save that as S. So let me just do that real quick. S equals 1, 2, 3, 4, 5, 6, 7. If I try to change the second element of that to another thing, I don't know, let's say A, it's going to say again, string object does not support item assignment. So you've got the same thing going on because tuples are immutable, strings are immutable, but lists are mutable and therefore can be changed. Now this behavior of tuples, the fact that they combine the ability to store multiple data types in them at once, store multiple pieces of data in them at once, but they cannot be changed, makes tuples excellent for a data type where you want to store pieces of data, but you don't want that data to ever be accidentally changed or altered in any way. So that's why you tend to use tuples. You've got some data that you want to protect but refer to later, so you use a tuple for that, whereas a list you might accidentally modify it without knowing. So tuples, you use them to protect pieces of data. You can also use the tuple function, or not tuple function, and you can tell we got it right because it went purple, to convert other pieces of data into a tuple. So let's say we have a list. I'm going to call it A, and this is going to be 1, 2, 3. I can turn A into a tuple by typing tuple of A, and that's going to give us that back. A hasn't been changed, but if I typed A equals tuple of A, now A is a tuple. So, and this will work for strings and other stuff like that. So just bear that in mind. Now, one cool trick that you can do with tuples is you can do multiple assignment. So let me show you what I mean. If I had A, B, C, this is going to be a tuple, right? Or if I did it a bit more explicitly. Yeah, like that. So A, B, C equals 1, 2, 3. Now, what happens if I look at A? A is 1, B is 2, and C is 3. So you can see the way that we actually define multiple variables in one go. Now, you can actually do that, which is good. That's quite cool on its own, but you can actually do that with other iterable data types as well, like lists and strings. So for example, if I used a list, I could have D, E, F equals 1, 2, 3, and we're going to see that D is 1, E is 2, and F is 3. I could also have G, H, I, and set that equal to, let's say, 7, 8, 9, right? Now G is going to be 7, H is going to be 8, and I is going to be 9. So if you've got an iterable data type, whether it be like a tuple or a list or a string, but you've got some kind of, I suppose, a tuple on the left, you can assign them to individual items like that. So that's a cool trick. So, you know, every now and then you might want to keep it in your back pocket for a cool party trick or something like that. Awesome. So that's really all there is to tuples. Tuples basically work like a list, except you can't change them once they've been made. This makes them very useful for keeping data from accidentally being messed up in your program. You can create tuples by using the tuple function or simply by separating a few values with commas. For more clarity, you should make sure that you surround your tuple definition with parentheses. As a bonus, you've learned how to use tuples, lists, and strings for multiple assignment. This trick won't be used everywhere, but it's a nice bit of style to throw around here and there in your code where appropriate and save a bit of space. So check you out. You've now actually added another data type down to your repertoire. Nice and easy, right? So up next, we have another complete game changer of a data type, Python's dictionary. Dictionaries allow you to store data under easy-to-remember keys, all within one data type. We'll be using this data type to make a cinema booking system later in the section, so I don't want to spoil too much here, so I'll see you in the next video. Hello there, you beautiful people, and welcome to this lecture on dictionaries. Now, dictionaries are a super badass data type in Python and are possibly my favourite of all the Python data structures. So in this lecture, you're going to learn what dictionaries are, how to create them, and also we're going to go through a quick example of how to use them so you can get a very good idea of how dictionaries work. Let's do it. Okay, so first of all, what the heck is a dictionary? Well, if you've ever used a real-life dictionary, you know that you have a bunch of words and each word has a definition for it in the dictionary. People look up the word and they get the dictionary definition back. Python dictionaries work in the same way, except they're much more powerful. First you look up a key in the dictionary, then you get back some value. So let's see this in practice. Here I'm going to make an empty dictionary called students. So I'm going to type students equals this empty dictionary. So as you can see, these squiggly brackets are used to create dictionaries. They're the same symbols that you use in string formatting, but they're not linked at all. It's just the same symbol. So inside of here, we want to define some keys and assign them some values. So for this, I'm going to define the keys as student names, and the values are going to be the students' ages. So let me just write this again. I'm going to have Alice as a key, and I'm going to type in age 25. I'm going to have Bob as another key, and we're going to have him as age 27. And you can see the way that I'm doing it. This is a key, and then I have a colon, then the value, and then a comma to separate the next key and value, and a comma to separate the next key and value, and so on. So we've got Claire. She's going to be 17. We've got Dan, who is going to be 21, and we're going to have Emma, who's going to be 22. Okay, so let me just click enter on that, and that's going in fine. So here's our dictionary of students. Pretty easy, right? Now notice how each of the keys is a string. I can't just put text in there without the string quote marks, because otherwise Python would give me a name error. So for example, if I tried to write, say, error students, right? This is not going to work. Say if I just tried to type Alice 25, Bob 27, let's see how that goes. That's going to give me an error because it's going to say name Alice is not defined. It's looking for a variable called Alice. But if I put quotes around it like this and make it a string, then that will work. Okay, now it's going to tell me Bob isn't defined, right? So you get the point there. So we now have a dictionary up here set up with a bunch of items. Each item represents a student, and each item has a key and a value. So we have items, keys, and values. Now, how do we look up a key? Right, so that's very easy. All we have to do is type the name of the dictionary. So we type students. Then we type some square brackets, like we did with slices, and inside we type the key. So for example, if we want Dan's age, we would type in the key of Dan, and when we press enter, it's going to look through all the items, find the one that has the key of Dan, and give us back the value, which is 21. Sweet. So what if another student joins the class who's called Fred, and Fred is 25? Well, what we can do is we can just assign the key of Fred to the value of 25 in the student's dictionary, like this. We type students, we'd put the key of Fred, and we'd set that equal to 25. Okay, now when we look up Fred like this, students look up the key of Fred, it's going to give us back 25. So what if Alice, our first student, had a birthday and became 1 year older to become 26? Well, all we have to do is type students, Alice, right? At the minute, she's 25. Students, Alice equals 26. And that is going to now, if we look up Alice again, she's now got 1 year older and she's become 26. But Fred is not a particularly dedicated student and very quickly drops out of the class. So how can we delete Fred from our dictionary of students? Well, do you remember the del keyword from before when we were working with lists? Well, all we have to do is type del students Fred. And this is going to delete the item with the key of Fred along with any associated values. So Fred should be gone now. So when we look up Fred, we are going to get what's called a key error, saying that basically the key Fred could not be found. We can get a list of keys from the dictionary using the dictionary keys method. So if I had students.keys, right? This is going to give us all the keys, but in a rather weird dict keys data type, right? So the dict keys data type is iterable, but it isn't indexable. So we can't really just pick out one of them. Like, for example, I couldn't go students.keys and I pick out like the first index or the 0th index. That won't work, right? Oh, sorry, I spelled students wrong. Let's give it a fair chance. That won't work, right? It says dict keys object does not support indexing. So, but the way that we can access certain indexes is to turn student keys into a list. So if we do student.keys and we turn that into a list, right? I'm going to save that as something called A for now. That's going to work. And now we've got a list. So now I can just take out the keys at any point, right? Like that. We can also take out the values by using the .values method. So students.values is going to give out a dict values, which has the same issues that we had before. These are actually very compatible with loops, especially for loops, just like the dict keys was, but we haven't covered those yet. So the way that you can actually convert this into a list, if you want to pull stuff out, is you just go list students.values. Like that. That's going to convert into a list, and then you can pull out slices, for example, as much as you'd like from there. But if I just tried it with students.values and tried to take a slice of that, that will give me an error because it says dict values object is not subscriptable or it's not indexable if I try to pick just one of them. So you've got these limitations, but you can always convert them into a list. But an important thing to note here is that a dictionary, unlike a list or tuple, does not have an order. The only way to access an item is to use its key. You don't use an index. So if I print out students, right? So let me print out students. You can see the way that it's been printed here. Dan, Alice, Bob, Emma, Claire is different to the order at the top that I defined it in, which was A, B, C, D, E, right? Because dictionaries don't intrinsically have an order. They basically just store the keys and values together. The keys and the values are always matched together, but the order in which they appear doesn't necessarily matter because you only use the key that you want to access the value. You don't use, like, for example, an index. I can't use student 0. It's going to say there's no key 0. You have to use a key. Okay, so this is probably a good place to take a break and digest what we've learned. First, you've learned that a Python dictionary works just like a real-life dictionary, in that you first look up a key, just like you'd look up a word, and then you get back some information associated with that key, or a value. So each key-value pair is called an item. You then learned how to create a dictionary, and we made a dictionary of students. Each of the keys in our dictionary was a student's name, and the value was the student's age. You learned how to look up a key in the dictionary using the square bracket syntax, and then we had the delight of a new student called Fred joining our class. You learned how to add the student to the dictionary simply by assigning a value to a new key, but unfortunately that student decided to go on and do other things and dropped out, which was quite convenient for you, however, as you got to learn how to delete an item from a dictionary using the del keyword. You can also update values, like Alice had a new birthday and her age changed from 25 to 26. All you have to do to change a value or in a dictionary is to take the key and assign it a new value. So for example, students of Alice, you just assign it whatever value. So let's say in 1,000 years, Alice will be, she'll be 1,026, I suppose. Damn, she old. So then we learned how you're going to get out all the keys from a dictionary and all the values using the dot keys and the dot items function. But you can also, the dot values function you saw. But you can also use the dot items function to pull out all the items. So if I did students dot items, you can see it gives us basically a list of tuples, and each tuple is an item. So that's quite a lot of awesome stuff about dictionaries that we've learned here today. It's quite a lot the dictionaries allow us to do, but we're going to take it to a whole new level of awesome in the next video, where you're going to learn how to give a single key multiple values. So for that, I'll see you in the next video. Hello there, you beautiful people, and in this lecture you're going to see just how powerful the dictionary data structure really is by allowing each key to hold multiple values. So this effectively makes one dictionary capable of storing a virtually unlimited amount of information, and each piece can be neatly ordered and uniquely accessible. So in this lecture, you're going to learn how you can combine dictionaries with lists and with other dictionaries so we can store more information about our students, such as their student ID and their grade, for example. So by the end of this lecture, you're going to be the Python data structure boss, and you're also going to know how to combine together different data structures into your bigger data structure, effectively however you like. So let's get into it. Okay, so let's recap what we have from last lecture. We had a dictionary of students like this, and we created it so that we had several students in it. We had Alice, and her age was 26. Well, not 16. 26. We had Bob, who was 27. We had Claire, who was 17. We had Dan, who was 21. And we had Emma, who was 22. Okay, so we had this list of students, and each student, their name was a key and their age was a value. And you can see that we only have one value for each key. Now, what if we wanted to store not only the student's age, but we also wanted to store their student number as well as their grade? Well, what we can do is, instead of storing just an integer in each of the values, you see how we've just got an integer, an integer, an integer, an integer. Instead of storing just an integer, we can store a list. So let's say the first thing we put is their student number, then their age, and then their grade. So I'm going to show you how we do this in a script. Let me just make a script here. And I'm going to save this on the desktop, again, in the Python Bible. And I'm going to call this students.py. Okay, so let me just take this. Save me typing, if I can. We'll give it a go. Hopefully I can copy and paste. And move into here. Yeah, there we go. So, right. So what I'm going to do is I'm going to make in here our dictionary. And I'm just going to break this up a bit. I'm going to put like an end line after each one of these. Which you can do in Python, by the way. This is actually totally allowed. Okay, so, and I'm just going to put that down like that. Okay, so instead of just having their age, I'm going to have a list here. And the first thing is going to be their student number. So let's say that's ID 0001. Her age is 26. And she is getting an A. Okay, then we're going to have another list for Bob. Bob's ID is 0002. He's going to be 27, and he's getting a B. Claire is going to have her own ID. She's going to be ID 0003. She's 17, and Claire is getting a C. Dan, ID 0004, going to be he's 21, and he's going to be getting that. And then Emma, ID 0005, 22, and E. Okay, so that works, right? So if I run this, just to show you, hopefully we don't get any errors, you see that's worked totally fine. So now what if we wanted to get all of Claire's data? Well, to do that, we have to print it because we're in a script, but we just type students of Claire, and that would give us all of her data, but we need to print it. So let's just print that, and we're going to see that indeed her ID, her age, and her grade come up. So what if we just wanted to get her ID? Well, what we could do is we could go in here, and instead of just printing all of her data, because her ID is the 0th index, it's the first thing in that list, we just put another square brackets and put the index 0. Now when we run that, we just get her ID. So what if we wanted to get Dan's age and Dan's grade? Well, what we could do is we could print students of Dan. Now his age and his grade. Well, his age is index 1 and his grade is, well, basically we just need the rest of the list from here, right? So we can just say from index 1 all the way till the end. And when I save that and run, now we get his age and his grade. So you can see the way that we can apply slices in our dictionary to get the information that we want. And this is all great because we've saved a lot of data about each student in one place. And as long as we know the order that each piece of information is stored, we know that the ID comes first, then the age, then the grade, then that's absolutely fine. But what if we wanted to make it a bit more clear what each index was? What if we didn't just have to remember that ID came first, and then the age came second, and then the grade came third? Well, that's what I'm going to show you how to do next. So what we can do is we can give each key its own dictionary as a value. So let me show you. I'm going to go back into the script, and in here, instead of having a list as a value, I'm going to make a dictionary. So what I'm going to do is I'm going to delete this, and I'm going to type in here another dictionary, and I'm going to say ID is ID 0001. Then I'm going to have a comma. Age is 26, and the grade is A. And I'm just going to copy and paste this and fill in the appropriate values for each student. So Bob, his ID is ID 002, he is 27, and Bob has a B for a grade. Then Claire, ID 0003, her age is 17, and she is on a C. Then we have Dan, who's on ID 0004. Dan is 21, and he's on a D grade. And then you've got Emma, who has ID 0005. She's 22, and she is on an E grade. Okay, now this looks quite badass, right? We've got a dictionary with dictionaries and keys and all sorts of stuff inside it, but it's actually really easy to use. So now I'm going to get rid of this, and what if we wanted Dan's age? Well, all we've got to type is students, Dan, and his age. Okay, now I need to print this to show it to the screen, but now we're going to see Dan's age, which is 21. And if we look back in, we're going to see, oops, wrong script again. There we are. Dan's age is indeed 21. So what if we wanted Emma's ID and Emma's grade? Well, we can make a new list that contains those. So if I said print, let's say I wanted to print students, Emma, her ID, and students, Emma, her grade, and now I save and run it. We're going to get her ID and her grade. And there we have it. I mean, how freaking awesome is that, right? As you can see, Python's dictionaries are an incredibly powerful data type and are really simple to use when you set them up properly. In this lecture, you learned how to assign lists to be values for specific dictionary keys. And while this was great because we could take slices of the output and so on, it was kind of awkward to use if we didn't know what order the list was in. So to fix this, you then learned how to assign dictionaries to be values for Python dictionary keys, which brought us to a whole new realm of dictionary epicness. So you can now use keys with easily recognizable names to refer to each of the values in a Python dictionary, and doing that was super easy. And that brings us to the end of our discussion of Python dictionaries. In the next lecture, we're going to actually apply this stuff to create a cinema booking system that lets the user book tickets to see a film. If the user's old enough and there are enough tickets left, we're going to let them book to see the film. And if they're not, then we won't. Awesome, right? We're basically creating a development business right now. So I won't spoil all of the goodness here, but that project is really going to tie together everything we've learnt in the course so far, all the way from variables, through logic, and through data structures, and all the other goodness. So I'll see you in the next video. Hello there, you beautiful people. Now it's time to put our data structure skills to the test by making a cinema simulator. So this project is going to let users choose from a range of films, and the user will pick a film and then the program will ask them for their age. If they're old enough to watch the film and there are enough seats available, then the program will let the user book to see the film. If not, the program will tell them that they're too young or there's not enough seats available or whatever. So pretty cool, right? Now, by the end of this project, you should have a great understanding of how variables, logic, and data structures all tie in together to build programs. So I can't wait to get started. Let's jump right in. So first of all, as I'm sure you know, first thing we're going to do is create a new script. I'm going to save that on the desktop, Python Bible, cinema.py, save that, maximize it, and we're all good to go. Right, so up first, we're going to create some kind of data structure to store information about our films. Now I'm going to use a dictionary for this, as each film is going to be its own key and have its own data. So since this current video is being filmed in about the middle of 2016, I'm just going to make you a list of some of the current films with random ages and seat numbers, but feel free to create your own dictionary with any films that you want. So the dictionary is going to store the age rating for the film and also the number of seats left. So let's make a dictionary called films, and I'm just going to create it like that. Okay, now inside here I'm going to put Finding Dory. 3. So the age for this I'm just going to say is 3, and there are 5 tickets, let's say. So, and then you're going to have Born. Pretty sure he's in the cinema. 18 and 5. Tarzan. Ghostbusters. Okay, so let's put that in there, 12 and 5. Okay, so there we go. We've got our dictionary of films. Obviously, you can add as many as you want and mix and match for what you desire, but I'm just going to leave it with those few. So I'm going to do a little cheat again now, and I'm going to use a while loop, so this program is going to run over and over again, just like we did for Travis. But don't worry, we're going to cover loops in detail in the next section, so just bear with me for now. I'm just going to type while true, and now put our code inside here. Okay, so now we need to ask the user what film they want to watch. So as a micro challenge, go ahead and ask the user what film they want to watch using the input function and store that choice in a variable called choice. You know the drill. Pause the video, have a go, and come back to see how you did. Okay, so how did you get on? I'd have done it like this. I'd have just gone in here, typed choice equals input. What film would you like to watch? like that. And just in case they enter some white space, I'm just going to strip it off right there. And also, actually, because as you can see, every single one of the films that I've put here in a key, every word starts with a capital letter, right? So what I'm going to do is I'm going to use the title string method as well to convert whatever they put into title case, so that if they enter Ghostbusters, then Ghost will start with a capital G and Busters will start with capital B, regardless of how, they might type it themselves. So we're just going to do that right there. Now, if you followed along with this, and if you got that actually, or you've just been following along, then you're doing absolutely brilliantly, because now we're going to start kicking off to more hardcore things. Okay, so now we need to check if the film that the user has chosen in choice is in the list of films. Now this is very easy to do just by using the in keyword, right? So let's just check if choice in films. Now, actually, I'm just going to introduce you to the pass keyword. The pass keyword basically just tells Python, just move on. Okay, this is just a blank placeholder. We're not going to actually write the code in here yet. I'm just building the structure. So if the choice is in there, just pass and do nothing. Otherwise, print, we don't have that film. And I'm going to make it build suspense, right? So that should be pretty good like that. Now when we run it, okay, when we run it, I'm going to say Tarzan. It's not going to do anything, right? Because it found the film, but it just saw pass and went back around the loop. Now, if we run it again and say Rocky 7, let's say, then we don't have that film. So our logic is working, which is brilliant. Okay, so let's stop this thing running. The next thing we've got to do is we've got to check whether the user is old enough to watch the film. So what I can do is if the choice is in the films, right? If the choice is there, we need to check whether the user's old enough. So let's say age equals input, how old are you? Okay, and I'm going to strip whatever comes off from there. So how can we take whatever they put and compare it with the age that's in here? Well, first of all, we actually need to make sure that age is a number. Now, if you remember, when I was talking about the input function, it always brings in a string. Okay, even if you type a number, it saves it as a string. So to convert all of this into an integer, we need to actually cast it from a string into an integer. So here we get a string, we strip any white space off it, and then we convert that whole thing into an integer, into a number, and save that in the age. Now what we need to check is if that age is greater than or equal to the age requirement for the film. So how do we know that? Well, we go in the films dictionary, look up the film that they chose. So let's say they entered Tarzan, right? This if we look up the key of Tarzan, it's going to give us back this list. Now, the age is the first element in that list, so I'm going to type in index 0. So we're looking up the choice as a key in the films. Now it makes sense why we had to get it in title case and we had to strip everything off. And once we've got the value, which will be this list, we're going to look up the first element in it, which corresponds to the age. And if their age is greater than or equal to that, then we're going to print enjoy the film. Okay, we'll come on to tickets in a little bit, but otherwise, if they're not old enough, we're going to print you are too young to see that film. Okay, so let's have a look at how that works. So what film would you like to watch? Let's say we want to watch Tarzan. How old are you? Let's say I'm 5 years old. You're too young to see that film. Okay, so let's say if we want to watch Tarzan. Again, let's say now I'm 99. Enjoy the film, right? So that works absolutely fine right there. Let's take another example. Let's say if we want to watch Finding Dory. How old are you? I am, say, 9 years old. Enjoy the film. That works fine as well. So let's cancel that out. And you're pressing Control C. And now we need to build the bit where it checks the number of tickets. So to check whether there are enough tickets, instead of just letting them, enjoy the film straight away after checking their age, I'm just going to write here, check user age in here. Wait a minute, just with a comment. Check user age. Now in here, we're going to check enough seats, right? So how do we know the number of seats? Well, the number of seats is this. It's the second element. So if the films of that choice, so this is the basically this list for the corresponding film. If the seats of that, which is element 1, is greater than or equal, but we can just say if that's greater than 0, right? Then we're going to tell them enjoy the film. We'll tell them enjoy the film, and we're going to subtract 1 from the number of tickets left. So films choice 1. Oh, I'm messing up. Films of choice 1 equals films of choice 1 minus 1. Okay, so we're taking whatever the value is for the number of tickets, and we're subtracting 1 from it, then saving it back in there. Another way that we could do this to make it a bit clearer, we could say num seats equals films of choice 1. Okay, and if num seats is greater than 0, we're going to say enjoy the film, and num seats is going to become num seats minus 1. But actually that bit won't work. Actually, no, we do need to change that. Films choice is going to become we did need to keep that the way that it was before. So we're just overwriting the number of seats right there. And that's pretty much it, to be honest, I think, you guys. Let's watch that work. So there's always 5 seats, right? So what film would you like to watch? I'm just going to say Tarzan because it's easiest to spell. How old are you? Let's say 3. You're too young to see that film. Okay. If I'm Tarzan, again, watching it. How old are you? I am 15. Okay. So now there should be 4 tickets. Tarzan, I'm 15. Okay, now there should be 3 tickets. Tarzan, I'm 15. Now there should be 2 tickets. Tarzan, 15. 1 ticket. Tarzan, 15. Now there should be no tickets left. Tarzan, 15. And it actually didn't say enjoy the film. Okay, did you notice the way that we ran out of tickets and it didn't say enjoy the film? We need to put in just another message in here. If number of seats is greater than 0, then do all that. Else, print, sorry, we are sold out. Now, you can trust me that works, or you can run the code yourself. But trust me, that's gonna work fine. One thing that I do want to highlight, though, can you see the way that we've got if statements inside of if statements inside of if statements and all sorts of stuff going on there? The way that Python works to have something inside something else is you can see that it's indenting it. I mentioned this a bit earlier in the course, but it makes more sense here. There's a certain amount of indenting going on, and this saves you from having to type loads of brackets and loads of stuff like that, which makes your code quite ugly, like in programs like Java and C and things like that. But you do have to have the indentation, otherwise Python just won't work. It won't be able to tell what's inside of something else. So make sure you get your indentation right. Idle's going to do it for you pretty much. I mean, if you just go to the end of the line and press enter, you can see the way that it's automatically indented. And if I typed another if, it's going to automatically indent it again. So, Idle's going to help you out with these things, but that does need to be right. So if your code's not working and it says indentation error or something like that, that's the problem. But awesome. Well, I mean, You see how quick that was? We've just built a program that can actually check whether a user is old enough to watch a film and whether there are enough seats left. Now, the system also updates itself when someone books a film and also reduces the number of seats by 1 when someone purchases a ticket. Now, if you understood all of that and followed along and did it yourself, you should be so proud of yourself, honestly. You're learning so much, and you should share this victory with your friends so they can celebrate along with you. This is a really big achievement. I mean, look at it, man. Look at it. You've got dictionaries, strings, lists, while loops, if statements, user input, updating variables, conditions, logic, all that stuff in there. You should be so proud of yourself. Honestly, I'm really proud of you as well. Now, in this project, we've applied data structures to create an assortment of films, use plenty of logic, data type conversions, converting here, we've been casting, and basically using everything since the start of the course into a functional program. And with that now, we're going to end on a high and come to the end of this section of the course on data structures. As you've likely learned so much from this section of the course, let's just have a quick recap in the next video to go over what we've learned, just to make sure it all sticks. And I'll see you in the next video. Hello there, you beautiful people, and welcome to the review lecture for this section on Python data structures. Now, in this whole section of the course, we've really covered a lot, and hopefully you've gotten a very powerful tool that you can use in your programs to structure your data and manipulate it really however you want. We started off by looking at lists, the most common type of data structure in Python. First, you learned the basics and saw what a list is and how to create one. After that, you learn that lists can hold different types of data, and that lists are an iterable data type, which means they can be broken up into little pieces called elements. Each element is accessible via an index, and you learn how to use indexes to access certain elements, and also how to take slices through your lists to access multiple elements at once. Then we stepped it up a gear, and you learned how to use lists to create multi-dimensional data structures like tables, and use indexes like coordinates to access certain rows and columns. You won't need this all the time, but it might come in useful when you want to make a Rubik's Cube solver or something like that. So after that, you built Travis, the ridiculous but totally lovable security robot. In that project, you learned all about how to add items to a list and how to delete them from a list. You learned how data structures can be combined with logic systems, and you also introduced to the in keyword, which checks whether some value is in an iterable data type. You also learned about the non-data type, which you learned how to manage the use of lists methods correctly so that you don't accidentally delete your data. And after that, we started talking all about tuples. You learned that tuples are basically like lists, except that they're immutable, which means they cannot be changed once you have created them, and this keeps your data safe at the expense of some flexibility. You learned how to create tuples, and you also learned a cool trick called multiple assignment, where you can create multiple variables with just one line of code. After that, we moved on to the dictionary data type. Now, dictionaries are a glorious data type that allow us to look up values with easy to remember keys. You made a mini database of students and stored their ages under their names. You learned how to add new keys to dictionaries, how to update their values, and how to delete them. You also learned about the keys, values, and items methods for dictionaries to get a dictionary's keys, values, and items respectively, and also how to get this information in list format using the list function. Now, as if all of that wasn't enough, you also learned how to put lists and even dictionaries inside of dictionaries, which gave your dictionaries superpowers basically. We use this to store not only a student's name, but also their age, their student ID, and their grade. Then finally, we combined all of the stuff we've learned so far in the course to make a cinema booking system. This program combined everything we know so far about variables, numbers, strings, logic, and data structures to really show off your skills as a Python pro. So bravo! This section has really brought a lot of new skills to the table, and I hope you really let these concepts sink in, as they'll come in useful time and time and time and time and time again. Oh, sorry, was I repeating myself? Well, that's probably because the next section of the course is on loops. Loops help to automate the task of programming itself and are a critical piece of every programmer's toolkit. Loops allow you to do in one line of code what might take hundreds or thousands or even millions of lines of code to do otherwise, and Python makes them crazily easy to do. Now, you're not going to want to miss this, so I'll see you in the next video. Programmers are said to be some of the laziest people on the planet, but that doesn't have to be a bad thing. In the process, programmers have discovered how to let computers even automate some of the task of programming. You can just type a small piece of code and let the computer repeat that task over and over and over hundreds or thousands or even millions of times. And the best part? Computers never get tired, they never complain, and they never get hand cramp. The programming structures that allow us to do this are called loops, and Python makes working with loops so easy that it's crazy. In this section, you're going to learn all about loops in Python, and this lecture is going to give you an overview of what's to come. We'll start off by checking out while loops by making a simple number counter. While loops are conceptually very simple, but practically very powerful. While loops have applications everywhere, but they're particularly prominent in video games. We'll then immediately apply the concept of while loops to building a program that will simulate the insatiable curiosity of a 3-year-old by asking you questions over and over and over again. It's going to be a lot of fun. After that, we're going to take a look at my favourite type of loops, for loops. For loops are incredibly powerful when combined with data structures that we covered in the last section, and they allow you to loop through thousands and thousands of pieces of data in the blink of an eye. They are absolutely incredible. Here you'll learn how to create for loops and also how to do list comprehensions, a powerful way of creating lists using for loops and logic, all in one line of code. Finally, we'll wrap up this section with another project where we'll make a pig Latin translator. This is going to be a funny translator that will basically convert our words into funny sounding gibberish, unless we understand how to read it. This is going to be a great project to make, to not only test your knowledge of Python, but to share with your friends for a few laughs as well. So this section is basically going to give you magical powers. No joke. You'll be able to do in one line of code what will take you thousands or even millions to do otherwise. Need I say more? I'll see you in the next video. Hello there, you beautiful people. Now in this lecture, you're going to receive magical powers. For real. No joke. You're going to get magical powers and you're going to get them by learning how to use the while loop. Let's go. Okay, so what the heck is a while loop? Well, a while loop is a type of loop that will repeat some code over and over and over again while some condition is true. So let me show you. The way that a while loop is structured is you have the word while in lowercase, you have some condition, a colon, and then inside there, some code. Okay? Now, while this condition is true, this code is going to run over and over and over and over and over again. Okay? So if I just type the word true in here, just like when we use if statements, that's going to satisfy the condition. And let me just print hello. Okay, now when I run this, whoa, right? I mean, the computer is just continually running hello, and it's going to run and run and run and run because the condition, if I can actually even get to the top, the condition at the top here is true. So as another example, if I write while 2 is greater than 1, print hello, we're going to see that that runs as well for over and over and over again. And why is that? Well, because, if I can actually even get to the top, man, this is a hassle. Okay, so the reason is because we have a condition, and that condition is true, because 2 is greater than 1. So that's going to give back true, and since the condition is true, the code inside will run over and over and over until this becomes false. And since that's never going to become false, it runs forever. Now, if I come down the bottom again, and I type while false, and I try and print hello, we're going to see that nothing happens because the condition is false. So a while loop will run over and over and over again while their condition is true. Okay, so now I'm going to go ahead and create a script to show you how we can use this in practice. So let's make a new file in here, and I'm just going to save this on the desktop, Python Bible, as while.py. Okay, now all that's well and good, but why are while loops useful? Well, let me show you. Let's say if I wanted to print out the numbers from 1 to 10. How can we do that knowing all that we know so far? Well, one way I could do it is I could just write 10 lines of code, right? I could just print 1, print 2, print 3, And I could, I could maybe copy and paste this. If I'm particularly advanced, I could print 4, print 5, print 6, keep going. Oops. Print 7, print 8, print 9, and print 10. Then when I save and run that, we're going to get 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay? And that worked absolutely fine. But, just look at how repetitive that code is. Surely there must be a way that we can automate it. Can you see the way that pretty much most of it stays the same? There's just something that changes. One thing changes, and it changes in a very repeatable fashion. Now, when you start seeing something like that, when you start seeing that kind of pattern, where one thing changes or a few things change in a very repeatable pattern, your brain should start screaming to you that you need to use a loop. So let's make a loop. In this case, a while loop. Now, the easiest way to explain this to you is just to show you the code and then explain it afterwards. So here it goes. I'm going to delete all of that, because you know what all that does, and I'm going to make a variable called number. And while number is less than or equal to 10, print number, and number equals number plus 1. Now, when I save and run that, you can see we get exactly the same result. So let's just take a step back and see what happened with the code. We started with a variable called number. Okay, we've got a box with the number 1 in it. Now, our while loop is going to repeatedly check whether that number is less than or equal to 10. Okay, so we start off, is 1 less than or equal to 10? Yes, it is. Okay, so that becomes true. We print the number, so we print 1, then we add 1 to the number. So number now becomes 2. So is 2 less than or equal to 10? Yes, it is. So we print 2. Add 1 to 2, so now it's 3. Is 3 less than or equal to 10? Yep. Then I add 1. Is 4 less than or equal to 10? Yes, it is. Is 5 less than or equal to 10? Yes, it is. So we print it. 6. Yep. 7. Yep. 8. Yep. 9. Yep. And 10. Is 10 less than or equal to 10? Yes, it is. So we print out 10, and then number becomes 10 plus 1, which is 11. Is 11 less than or equal to 10? No, it's not. So the condition becomes false, and then this code doesn't run anymore. So we don't run it. We don't basically print out that number. But if we go inside the shell, that's the wrong shell. If we go inside the shell, if I can get the right one, here we are. If we print out number, can you see the way that it's 11? Number was changed and Python checked, is 11 less than or equal to 10? But it's not. So the code didn't run. And that's pretty much exactly how a while loop is working. But the amazing thing about this is, number one, we only have to write the code once. And we can extend this for as long as we want. Okay, we don't have to copy and paste anything. We can just make it as long as we want. What if I wanted this code, instead of just counting to 10, I want to count 1,500, right? Now let's run that. Look at it go. It's going to repeat the code over and over and over and over again. And I don't have to copy and paste anything. I don't have to potentially make any mistakes. Once I've got it working for just one number, it's going to work for 1,500 and Python's not going to make any mistakes. Tell me how in any other way you could possibly do that without using a loop. How long would that take? And usually when you're dealing with computers, you do want to repeat operations thousands of times. You do want to do things over and over and over again. So look at just how powerful that is. Now there's another thing that I want to show you about how we can combine these loops with logic. So what if I only wanted it to print even numbers? Well, we can come in here and put an if condition, right? So we can say, while number is less than 1,500, if the number is divisible by 2, that's how we do that. We find the remainder of the division by 2, and if that's equal to 0, then it's divisible by 2. Don't worry about it, just trust me. Then we're going to print the number, okay, and increase the number by 1. Actually, no, just increase the number by 1 anyway. So it's going to come in, check if it's divisible by 2, then it's going to print it, and even if it's not, it's just going to add 1 to the number. So watch this. Just by adding a bit of logic, we are now printing out, I'll just show you, we're now printing out in steps of 2, right? We're printing out only the even numbers. And it's very simple. If I wanted to print out all the odd numbers, I just check when that's not equal to 0. And now we're going to print out all the odd numbers, 189, 191, 193, and so on and so on. So you can combine logic with loops and do thousands of computations in what, like 4 or 5 lines of code? I mean, just how ridiculously powerful is that? That's magic. Now, let me show you another example of this when you use lists, okay? Let's say we want to ask a user for a bunch of names up to a maximum of 3 names. Well, what we can do, let me just delete all this. What we can do is we can create an empty list up here, which I'm just going to call L, capital L. And what we can do is while the length of that list is less than 3, oh, it's a nice heart. While the length of list is less than 3, new name is going to be input. Please add a new name. Like that, okay? Now, whatever they input, let's say we strip it and we capitalize it as well because it's going to be a name. Okay, and then we want to append that to the list. L.append the new name. Okay, and after that, we're going to print, sorry, list is full, and print out the list. Okay, now when I run this, look what happens. Please add a new name. Alice, Bob, Carol. Sorry, list is full. Alice, Bob, and Carol. So we can even add things to a list automatically and repeat things over and over and over again. It's honestly, loops are just a game changer, right? See how neat this is. And even if we wanted 5 names, right, or we wanted 10 names, we don't have to repeatedly add this code. We don't have to keep, you know, having a new variable for each name, or we don't have to define a list of names. All I have to do, if I want 5 names, just change that number to 5. Now it's going to ask me, add a new name, and we're going to Alice, Bob, Carol, Dan, Emma. And now we've got 5, right? You see how powerful that is? I mean, that's just mental. We've managed to automate the task of programming itself. I mean, how crazy is that, right? So in summary, while loops will run a certain piece of code as long as a condition is true. And if that, as soon as that condition becomes false, the code won't run. It won't go round the loop another time. That's a more accurate way of putting it. Nice and easy to understand, right? So to really hammer this point home, in the next lecture, we're going to create a simple project that will simulate a conversation with a 3-year-old child using a while loop. I promise you're going to have some fun and in the next section, and you're probably never going to forget while loops as long as you live after making that program. So I'll see you in the next video. Hello you beautiful people, and welcome to this lecture where we're going to be creating a program that simulates a conversation with a 3-year-old. You know what it's like. Children have infinite questions, and basically no matter what answer you give them, they're always going to ask, but why? And the only way to stop them is to say, just because, and then they seem quite happy with it. So today we're going to be simulating this situation by using a while loop. And by the end of the lecture, you'll be very confident using while loops, and you will also probably be able to have a chuckle or two with your friends, and will never forget while loops as long as you live. So let's get into it. Alright, so as usual, I'm going to go ahead and create a new script, file new file, hit save, go to the desktop, Python Bible, going to call it baby.py, hit enter, save it, maximize, and we're good to go. Okay, so first let's get the baby to ask a question and get the answer that we provide stored in a variable called answer. So as a micro challenge, why don't you go ahead and do that? Pause the video now and just get the baby, or the computer in this instance, to ask any question you like and store the answer in a variable called answer. Use the input function and the prompt as your question. So go ahead and do that now. How'd you get on? Pretty standard right by now, right? So what I'm going to do is I'm going to have the baby ask why the sky is blue. Pretty reasonable question. We're going to have answer equals input. Why is the sky blue? Okay. I'm going to put a code on there and just leave that like that. So now I want the baby to continually ask why over and over and over and over until the user answers just because. Okay, so basically, while the answer is not equal to just because, we want the code to run, right? Now, as another micro challenge, I want you to try and construct a while loop that will run while the answer does not equal just because. So pause the video now and come back to see how you got on. How'd you get on? Well, here's how I'd have done it. I'd have just put down here, I'd have a while loop, while answer does not equal, just because. Okay, and that would be my while loop. Now, one thing that I want to make sure, can you see the way that just because is all in lowercase? Well, I want to convert whatever the user enters as the answer as into lowercase up here to make sure that it matches the same format. So brilliant. That's exactly what's happened there. Now inside, I need to have the baby continually ask why over and over and over again. Okay, so to do that, I'm just going to have answer equals input why, like that. Okay, and again doing the strip and lowercase. I'm also going to do a strip up here. Okay, so now we're going to continually get answers in from the user, which is going to update the answer variable. And so when the user enters just because, that's going to break this loop, right? So let me just show you it working. Why is the sky blue? And we could say something like, because that is how light passes through the atmosphere. You know, if you've got Einstein for a baby or something, right? You click enter, why? And you say something like, I don't know, wavelengths. Why? And you just go, oh, okay, just because. And that's it. The baby's happy. Now, how amazing is that, right? That's bloody, I think that's fantastic. So, however, it's kind of boring to just ask one question all the time, right? So why don't we make a list of questions and then pick a random one from the list for the baby to use? Okay, now go ahead and pause the video now, head over to your script and make a list at the top called questions. Okay, I want you to make a list of questions at the top. Let's say of at least 3 question strings that you'd like the baby to ask, and then come back to see how you did. Welcome back. So here's what I'd do. I'd have my variable called questions, and I'd have in here, why is the sky blue? I'd have, why is there a face on the moon? And I'd ask, you know, where are all the dinosaurs? Questions that trouble me to this day. Now we want to get a random choice from these questions and ask it in here, right? Instead of just asking why is the sky blue, we want to pick a random one from there. Now there's a useful function called it's called the random choice function. Okay, so for that we're going to need to import it because it's not available in Python originally. So up here I'm going to import random. Okay, and actually even better, I'm going to say from random import choice. Now that allows us just to use choice like this. If I just done import random, I would have to type random.choice. So you can see the difference. I've basically just imported the choice function so I can use it as it is, rather than having to do random.choice. Okay, so now I'm going to write the question. Question is going to be a choice from the questions, and then I'm just going to put inside there that question. So we're going to take a random choice from this list, and then we're going to ask the user that question and repeatedly ask why over and over. So let's see how that works. Why is there a face on the moon? Okay, so I'm going to say I don't know, to keep away all the ghosts. Why? And so and so. So we just say just because. Okay, and the baby's quite happy with that. Now if I run it again And actually, I'm just going to put that colon and space at the end of all these strings to make it look a bit nicer. Colon and space, colon and space. Maybe break the line there. Colon and space. By the way, you can do that, right? You can just put a colon. Sorry, you can break the line to keep everything all nice like that. So let's run it again. Why is there a face on the moon? We've just answered that. These persistent kids. Let's try one more time. Run. Where are all the dinosaurs? Dead. Why? Just because. Okay. We've obviously got tired of this baby's incessant questions. So, I mean, that's brilliant. Let's just now make it look like the child is quite satisfied with our answer. Okay. We're just going to get the baby to print. Oh. Okay. Like that. So now when we run it, why is the sky blue? Just because. Oh, okay. And there we are. That's brilliant. So hopefully you've had some fun making this program, and also you've got a better understanding of what while loops are now, and also how to kind of use them with data structures and things like that. Now, while loops are really useful, but there's another type of loop that I like better. For loops. For loops are ridiculously powerful, and I'd make the guess that for loops will come up in practically every single program you will ever write, if it's, of a serious enough length. Like, seriously, every single time I write a program, for loops have always come up. They're amazing, and I love them, okay? So for loops are potentially the single most useful thing in this whole course, and I can't wait to show you them because they're absolutely brilliant. I'll see you in the next video. Hello there, you beautiful people, and welcome to this lecture on for loops. This is possibly my single favourite lecture of the whole course, because what you're going to be able to do after finishing this lecture is going to be crazy. It's about to get real, you guys. So in this lecture, I'm about to show you what for loops are and how to create them. The most powerful thing about for loops, in my opinion, is how well they integrate with Python's legendary data structures and enable you to go through thousands of pieces of information in the blink of an eye, all with easily programmable results. So by the end of this lecture, you're going to know what for loops are, how to use them, and how to integrate them with lists, strings, dictionaries, and really any other Python iterable data type to blast through loads of data instantly. So let's get into it. Okay, so what the heck is a for loop? Well, for loops are made up of a variable and an iterable of some kind. On each round of the for loop, the variable becomes the next value in the iterable. This allows you to perform an operation on each value in the iterable and also makes Python for loops easily expandable. It's probably easiest if I just show you. So I've made a script called for.py, and just like in the last video, let's say I want to print out the numbers 1 to 10. One way I could do it is I could write print 1, print 2, and print 3, and so on. Okay? Now I don't want to do that. Right? I don't want to do that. I want to use a for loop. So I'm going to introduce you to a function that I haven't shown you yet. It's called the range function. Okay? The range function is going to create an iterable of numbers. So say if I had range 1 to 11. Okay? What this is going to do is it's going to basically make an iterable that looks like this. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. It's not going to be a list because a list is its own data type. It's going to make a range iterable. If you're using Python 2, first of all, well done on following through with this course because we've been using Python 3 all the way through. But if you're using Python 2, then range will give a list. But on Python 3, it gives a range iterable. Okay, but it's basically like this, right? You have an iterable of numbers starting at 1 and going up to, but not including 11. Okay, so that's how that works. Now, if I write for number in range 1 to 11, okay, remember that's 1 to 10, basically, print I. Oh, not I, print number. Now, if I run that, damn, look at how easy that was, right? So just by changing one piece up here, just by changing one number, I can now make this run for 1,000 numbers. Look at that. In 2 lines of code, we can get it to print thousands and thousands and thousands of lines or do operations thousands and thousands and thousands of times. That is amazing. So how did that work? Well, the first thing that it did first thing that we did was type the letter 4 in lowercase. Idle helped us out by making it go yellow so that we know, the syntax is all correct, and just to say we're on the right track. After that, we declared a variable. I called it number, right? Now, number is going to update every single time we go through the loop. We could have called this anything. We could have called it pancakes if we wanted to, but number is probably more appropriate. We then had the keyword in that we've seen before, and then we had an iterable. Okay, we use range here, but this could very well, it could have been a list. It could have been a list like that. So let's say if I had a list 1, 2, 3, 4, that's going to print out 1, 2, 3, 4. It could have been a string. So say, for example, if I had 4 letter in the string ABCD, right? That's going to, oops, sorry, I forgot to change this to say letter. Now it's going to say ABCD, right? So you have some kind of iterable, and on every time you go through the loop, this variable becomes the next step in the iterable, or the next element. So on the first way through, it's going to be A. So it's going to print A. On the next way through, it's going to become B. So we print B. Then C. We print C. And D. We print D. Now we use number to begin with, right? We use number in range 1 to 1001, let's say. Now, range just basically saves us from typing out a list like this, 1, 2, 3, 4, 5, 6, 7, 8, 9, all the way up to 1000. It just saves us doing that typing, but it's effectively the same. Thing. You can also choose the amount of steps. So if I did 1 to 1001 in steps of 2, I think that's the syntax. Is that the syntax? It told me then, you see. This is another trick. On idle, if you wait, it'll tell you how to do it. And yeah, it was right. You start what you want to start at, what you want to stop at, well, where you want to go up to, more correctly, and then optionally the step. Okay, so if I do that, we're going to go up in steps of 2. Let's just go up to 10 or 11. Now you see that we'll go up in steps of 2. 1, 3, 5, 7, 9. So let's see a situation of where this might be useful. Let's take an example where we wanted to go through a piece of text and count the amount of vowels and consonants in that piece of text. Also, by the way, for those of you who may not be familiar, the letters A, E, I, O, and U, these are the vowels, okay, in the English language. And you've also got consonants are basically everything else. So let's say we want to loop through a piece of text. Okay, we're going to set a variable to count our vowels. That's going to set that to 0. We're going to set our consonants starting off as 0 as well. Now, for every letter in the word, let's say, hello, okay, if that letter in lowercase is in A, E, I, O, U, these are all the vowels, yeah, then vowels is going to be vowels plus 1. Right? Does that make sense? So if the letter, so it's going to start off as H, we're going to convert it to lowercase, and H is a consonant, right? So is H in A, E, I, O, U? It's not. So it's not a vowel, so we won't add anything to that. But on the next time through, we're going to have E. Is E in there? Yes, it is. So we're going to add 1 to the number of vowels, and so on. That's how we're going to count up the vowels. Okay? Now, else if the letter is a space, because it might be if we've got a piece of text, we're just going to pass and do nothing. But otherwise, then consonants equals consonants plus 1. Now I know this doesn't take into account other potential punctuation, but it works good enough to demonstrate the point. Now what we want to do is we want to print out there are some amount of vowels, format in there the vowels. Now let's copy and paste this. So this is just some string formatting. There are this many consonants, and we want to take the consonants. So we are expecting this to say there are 2 vowels because of E and O, and there are going to be 3 consonants. So let's see how that works. 2 vowels, 3 consonants. Perfect. Okay. Now, we could change this to be anything. Let's say if we took our example from before, supercalifragilisticexpialidocious. Okay, now let's run that. Apparently there are 16 vowels and 18 consonants. So you can just see how powerful these for loops are, right? It's absolutely mad. Now, in the interest of time, I'm going to cut this discussion of for loops short and save it for the next video. But here, I hopefully, you're starting to understand the power of how all of these things are starting to come together, how we're getting loops in, and we're going to get logic in, and strings and numbers to create these powerful functions, okay? So I'm going to leave that there, and we're going to pick up this discussion in the next video. So we've just seen in the last lecture what a for loop is, how it works, and how to use it with lists and strings, as well as the range function. But how do we use one with dictionaries? Well, first, let's make a dictionary. We're going to make a dictionary of students, and we're going to section them by their gender. Okay, so we're going to have in here, we're going to have male, and as a key, and we're going to have a list of names. We're going to have Tom, we're going to have Charlie, we're going to have Harry, we're going to have Frank, like that. And we're also going to have as another key, female. And in there, we're going to have Sarah, we're going to have Huda, we're going to have Samantha, we're going to have Emily, and we're going to have Elizabeth, like that. Okay, so there's some girls' names and some boys' names in a dictionary. Now, we have a dictionary with two keys. The first key is the word male. The second key is the word female. And under each of these keys, we have a list. So let's say we want to go through all of these names and only print out the names which have a letter A in them. Only a letter A in them. So for this, we might want to access the keys of the dictionary. And now if you recall, we can use the keys method to generate an iterable of dictionary keys. So let me show you what I mean. For key in students.keys. Okay, so I need the code on at the end. So this is going to give us an iterable. Remember, for loops need iterables. It's going to give us an iterable, which are all the student keys. It's going to give us male and female. And then as the loop goes round, the key is going to become male, and then it's going to become female, or whichever order it happens to come in. So let me just print out the key to show you this. Print the key. There you are, male and female. Okay, so that's working fine. Now we actually want to get each of the names. So what happens if I print students of that key? We're going to get two lists, right? We're going to get the male list and the female list. Now we want to go in there, right? We're going to want to go inside this this list and pull out each of the names. So now watch this. For name in students of that key. Okay, so first we get out the list here. Actually, no, we get the list here. And then for every name in that list, if the letter A is in the name, print the name. Okay, that's all we need to do. So now if I run that, we're going to get Sarah, Huda, because it's got an A there, Samantha, Elizabeth has got an A there, Charlie's got an A there, Harry's got an A there, and Frank has got an A there. But you notice Tom hasn't come out, and Emily hasn't come out, because they don't have the letter A in there. So let me break it down again what happened. We made an iterable of all the keys in our dictionary. On each go round, the outer loop, the key became the next key in the dictionary. We made a list. We took each of the lists, right? Because students of that key, so if the key was male, then students of that key is going to become this list, isn't it? It's going to become the list of male names. Now, for every name in that list of male names, if A is in that name, print the name. Now, on the next way round, the key is going to become female. So students of female is going to give us this list. For every name in that female name list, if A is in that name, print the name. So basically we go through every single piece of data in just 4 lines of code. If it's got an A in it, we print it out. Now that is mad, right? I mean, just look how powerful that is. That is crazy. So, I mean, that's can you just see how freaking powerful that is? Now, don't worry if you didn't get this in the first attempt. This is how the glorious for loop determines who is worthy of understanding its awesomeness. Jokes aside, it may be worth watching this lecture as many times as you need to make sure that it all sinks in, okay? And playing with it yourself, just get for loops down, okay? You really need to understand that they're insane, right? For loops are an incredibly useful programming tool that you need to know, okay? It's going to open so many doors for you. So with that, let's just do a quick review of for loops and what we've seen so far. You've learned that for loops are another of Python's loops, obviously, and they are made up of a variable, like here we have key, which changes on each cycle around the loop. And the way that it changes is you have some kind of iterable, something that is made up of elements. And on every cycle around the loop, that variable becomes the next value in the iterable. You also learned how to use the range function with for loops to set up numbers to easily create iterable number lists. Well, they're not lists, but number iterables. And you also saw how to combine logic in with your for loops and how to put for loops inside of one another, which is very useful. And just generally, just watch these videos, these past few videos over and over again until it really makes sense. I'm begging you, okay? This is rather advanced, what we've done here, but once you've got it, honestly, it's going to make your life so much easier when you program things in Python. So I'll leave you there, and in the next lecture, we're going to look at list comprehensions, which is how you can combine lists, for loops, and logic all in one line of code to create data structures, and it's mad, okay? It's really good. So I'll see you in the next video. Hello there, you beautiful people, and welcome to this lecture on list comprehensions. Now, list comprehensions are as close as you can get to magic, as far as programming goes anyway, just to their pure simplicity but raw power. In this lecture, you're going to learn what a list comprehension is and how to perform one for yourself. Let's go. So what the heck is a list comprehension? Well, a list comprehension is basically a shortcut method or a bit of shorthand to combine variables, for loops, and if statements to create a list or to comprehend a list in all one line of code. So let me show you an example. Let's say if I want to go through all the numbers between 1 and 100 and create a list of all the even numbers. All I need to write is even numbers equals x for x in range 1 to 101 if x, when divisible by 2, is equal to 0. Now if I print the even numbers, there we are. We've done in one line of code, we have made for every number between 1 and 100 all the even numbers. Now tell me that isn't magic, right? I mean, look at that one line of code, come on. So how does this work? Well, first of all, we have a variable, okay, which we're going to call x. And then this variable x is what is going to be stored in the list, okay? Now, x is going to loop through range 1 to 101. So this is x is going to go, it's going to be 1, 2, 3, 4, 5, 6, 7, 8, all the way up to 100, okay? Now, we only keep x if x when is divisible by 2. Okay, so we go through this iterable, the range 1 to 100, and we only keep x if x is divisible by 2. Okay, so that's how list comprehensions work. Simple as that. So what we could do, let's say, I mean, you could do, it's very easy. I mean, like, it's simple enough if I wanted one called odd numbers, x for x in range 1 to 101, where it is not divisible by 2. And if I do that and print odd numbers, we're going to see that now we've got all of the odd numbers. So let me show you, list comprehensions don't just work for numbers, right? They work for any data type, including strings. So let's say we have a list of words, and our list of words is going to be the quick brown fox jumps over the lazy dog. Okay, now I'm now going to make another list which is called answer, and that is going to have a kind of it's going to be a list of lists, right? And I'm going to call it w.upper. Let me move my mouse out of the way. w.upper, w.lower, and the length of w. Now, what's w? Well, this is what we tell it now. For w in words. Okay, so W is going to become each word. It's going to become the, then it's going to be quick, then it's going to be brown, then it's going to be fox, then it's going to be jumps, then it's going to be over, then it's going to be the, then it's going to be then it's going to be lazy, then it's going to be dog. Okay, and what we're going to store in our list is another list which contains the uppercase version of the word, the lowercase version of the word, and the length of the word. So let's see that now. Print answer, uppercase, lowercase, length, uppercase, lowercase, length, uppercase, lowercase, length. Okay, and you see the way that it's a list of lists, which is absolutely unbelievable. But the reason I just want to hammer home, why have we got a list of lists? Because we have, I mean, when you do a list comprehension, you always have to have an outer list. But then, like up here, when we just had X, instead of putting X, we put another list inside, and we said w.upper, w.lower, and length of w. And then we told it what w was, w in words, and we didn't actually need an if statement because we just wanted every single one of them. That's going to work just like that. So again, just showing you don't need to assign it and then print it. You can just save it just like that. So I hope you found this absolutely mind-blowing. List comprehensions just really show off Python's ease of use, but incredible power, and let that shine through. And they make creating lists super, super easy once you get them down. Now, when you have your list, you can, of course, feed that into other for loops for more processing, and that's just going to depend on what you want to do. But I'll leave that witchcraft for another day. Up next, we have a project instead. Now, in the project, we're going to create a Pig Latin translator. This is a funny word translator that's going to convert words into a secret code called Pig Latin that will not only combine our knowledge of loops, but it's also going to make you giggle and give you some fun with your friends. So for that, I'll see you in the next video. Hello there, you beautiful people, and welcome to the Pig Latin Translator project. This project is going to be a load of fun and is going to tie together a lot of what we've learned in the past few sections nicely into one project. In this lecture, we're going to have a quick look at what Pig Latin is, and we're also going to see what to expect from the project. So by the end of this lecture, you should have a good understanding of what the project is, how we're going to tackle it, and you should have some idea about how what we've learned about loops, data structures, strings and logic might all fit in. So let's get into it. Okay, so first, what the heck is Pig Latin? Well, Pig Latin is a simple joke language, it's imaginary, that makes regular words hard to understand. So let me give you some examples. If you had the word pig, that would become igpay, right? If you had the word happy, that would become appyhay. If you had the word duck would become uckday. And if you had the word glove, that would become uvglay. And things like that. So it just makes words sound a bit more confusing than they otherwise would be. So basically, the way that it works is you take the first few consonants, the first consonant cluster of a word, and you move those to the end of the word. So GL goes to the end. Okay? Then you add the word AY, the sound A to the end. So like if we had pig, right? What's the set of consonants, right? We've just got the letter P, right? So that becomes, we basically take P and move it to the end, ig, p, and then you add A, igpay. Simple, right? So that's if it starts with a consonant. But if the word begins with a vowel, right, then you simply just add yay to the end. Right? So that's easy enough, right? If you had apple, apple would become apple yay. If you had eat, that becomes eat yay. Okay, so now with those two simple rules, we want to build a program that will ask a user for a sentence and then convert the entire sentence into Pig Latin. Cool, right? So let's plan out our program now using Python comments, as there's quite a lot to do to make this work. So I'm going to go ahead now and create a script. I'm going to go File, New File, Save, Desktop, Python Bible, and I'm just going to call it pig.py. Okay, save, maximize it, and we are good to go. So let's plan out our program now. First of all, we're going to need to ask the user for a sentence, right? So get sentence from user. Then we're going to need to split that sentence up into individual words. So we're going to split sentence into words. Now we're going to loop through all of those words and convert them into Pig Latin. Loop through the words and convert to Pig Latin. Okay. Then we're going to stick those words back together into a sentence. And finally, we want to output the final string. Okay, so that's the general model that I'm going with, and what we're going to follow as we go through making this project. Now, you should immediately start noticing some opportunities to use lists and for loops to make this whole project come to life, as well as a few string methods. Now that you have an idea about what the project is, let's get building it. For that, I'll see you in the next video. Hello there, you beautiful people. So let's get into building this Pig Latin project, shall we? Now, we already have our outline from the last video, so let's just get on with the first task. We need the user to enter a sentence. Now, as a micro challenge, I want you to get the user's input sentence and store it in a variable called original. Okay, but as an added challenge, I want you to convert that sentence all into lowercase before you store it, and I want you to strip away any extra space from both ends of the string before you store it as well, using the appropriate string methods. So go ahead now and give that a go. Now, don't be afraid to look in the Python docs or have a cheeky Google search if you can't remember how to do it, as that's how you're going to program in real life anyway, right? So get the user input, store it in a variable called original, but before you do so, convert it all to lowercase and strip away any blank text from the side. So go ahead and do that now, and I'll see you in a minute to see how you did. Okay, so how'd you get on? Here's how I'd have done it. I'd have done original equals input. Please enter a sentence. Space like that. Convert it to, strip away any text. Convert it into lowercase. Job done, right? Very nice. If you got that, then well done. It's really brilliant use of the course content so far, and you should be very proud of yourself. Now, the next step is to split that text up into individual words, which we can convert into Pig Latin. Well, there's a useful string method called split. Okay, this method will split a string by default at each word, so in between each word, and create a list. So let's make a list called words. Words equals original dot split. Okay, now I'm actually just going to print words just to show you how that works. Okay, so I'm going to enter a sentence. Let's just say this is Pig Latin. And as you see the way that now it's broken them up in between each word and created a list of each word. Very nice. So cool. Now what we need to do, if I go back to our script, now what we need to do is to loop through all of those words and convert them into Pig Latin. So first of all, we need a place to store the new words. So let's make a new variable called new words and just set that blank as a blank list. Now, for the actual conversion, there are a few rules. Let me write them in the comments. If it starts with a vowel, just add yay. Otherwise, we're going to move the first consonant cluster to the end and add a, not yay. Okay, so those are the two rules that we're going to follow. So the first thing we're going to need to do is create a for loop that's going to go through each of these words. So I'm going to get rid of the print. It's going to go through each of these words and apply these rules and then save them in new words. So as a micro challenge, I want you to create a for loop that's going to go through each of the words in this list, in words basically, and print them out to the screen. That's all I want you to do. So go pause the video now and have a go at making a for loop that will print out each of the words in the list, and then come back to see how you did. Alright, so how did you get on? Well, I'd have done it like this. I'd have just gone for word in words, print that word. Okay, now if I file it, save and run this, it's going to ask us for a sentence. This is pig Latin. It's going to print out each word. This is pig Latin, but all in lowercase. Fantastic. If you got that, then well done on basically internalizing the stuff we've been talking about with for loops. So this is fabulous, but we don't just want to print out all the words, we want to actually convert each word into pig Latin and add it to the new words list. So let's head back on over to our script and let's build the case if the first letter was a vowel. Okay, so what we're going to do is in here, we're going to type, well, the vowels in English are A, E, I, O, U, right? And what we want to do is to check whether the first letter of the word is a vowel, right? So the first letter is going to be, this is how we're going to do it. We're going to say if the first letter of word is in those vowels. Okay, now we've got a way of checking whether it starts with a vowel, because the first letter, this is how we get that. If that's in the vowels, i.e. if it's a vowel, all we need to do now is just add yay to the end of the word. So let's create a variable called new word and set that equal to the original word plus yay. Not equals, plus yay. So whatever the original word was, we're just going to add yay to the end. Now we need to put that inside the new words list. So very simply, new words dot append new word. Okay, so we're going to go through each of the words in the original sentence, and if that word starts with a vowel, we're going to add yay to the end of it, and then put that inside our new words list. So that is the case for vowels done. Now let's just see how that. Let's just see if that works, right? So let me just print out at the end new words. Okay, I'm just going to print that out actually out here. Now if I just type in eat, it's going to say eat yay. There we go. So that works absolutely fine. That's pretty much what we wanted. What if we had apple? Apple should give us apple yay. So if I run that, apple yay, fantastic. And if I give them more than one, does that work? Let me just go in here. Does that work if I give them more than one? Eat yay, apple yay, working perfectly. Now if the word doesn't start with a vowel, we need to do something else. So let's type the else keyword here. Okay. So what we can do is we need to move the consonant cluster to the end of the word and then add yay. The problem is, how do we know where the consonant cluster ends? Well, what we can do is we can loop through each letter in the word and find the index where the letters turn into vowels. So for this, we need to keep track of the index somehow. So let's make a variable called vowel pos, short for vowel position, and we're going to set that equal to 0 to begin with. Now let's make a for loop to loop through each letter in the word. So for letter in the word, because remember the word is a string. Strings are iterable, so we can do this. We can go through each of the letters. Now if that letter isn't a vowel, we want to increment the vowel position by 1. So if it is a vowel, we just want it to stop looping through because we know where our consonants end. To stop it looping through prematurely, what we're going to do is Okay, I'm going to say, first of all, if that letter is a vowel, actually, if that letter is not in A, E, I, O, U, then we're going to say the vowel position equals vowel position plus 1. Okay, so we're just going to continue to move up this vowel position and always assume that the vowel is coming next. Always assume that the vowel is coming next. Okay, but if it is a vowel, so I'm going to put else here. If it is a vowel, we just want to stop looping through, because now we know that's where our consonants end. And we're not going to increment we're not going to keep going through every letter in the word anymore. We're just going to stop the for loop. So for that, we need to use the break keyword. Now the break keyword will break us out of a loop. It'll also work for while loops, and put us back inside this else statement, because we're in a loop at the minute. We're going round, and by using the break keyword, we're going to break out of the loop and come back into the else statement up here. As a side note, there's also the continue keyword, which kind of does the opposite. That just takes from where you are and goes right back round to the top of the loop again, which we may encounter in the future. It just skips the rest of the loop and goes straight back to the top, which is the next iteration. But for now, we're going to use break. Okay, awesome. Now we know where our consonants end. Okay, so what we want to do is so if it's a vowel, basically, our vowel position is going to be exactly where the first vowel is. So now we need to take a slice of the word up to, but not including that vowel index. So what I'm going to do is I'm going to go in here, and we are going to take a slice like this. The consonants are going to be the word all the way up to the vowel position. Okay, so now we've got all of our consonants in this variable called cons. Now, positioning this actually is rather important. We need this to be inside this else condition for this to work. Now, the rest of the word, right, we're just going to call that the rest, which is going to be everything after the consonant cluster, is going to be the word from the vowel position, including the vowel, and all the way to the end. Okay, sorted. And that's a bit complicated, but bear with me. Now we just need to take the consonant position and add that onto the end. Okay, add all the consonants onto the end and add yay. So now new word is going to become the rest plus the consonants plus the word or the phrase a. Woohoo! We did it, right? So I think that should be pretty much it. Now we just need to append that word to the new words list. New words dot append new word. Okay, so what we've done is we have found out where the vowels begin. We've cut up to that point and stored that in consonants. See, up to the vowels. Then we've taken the rest of the word, which is the vowels and onwards. And we've created the new word by taking the rest of the word, adding the consonants onto the end, then adding a, just like our Pig Latin rules say we need to. Then we finally added that word to our new word list. So let's try both words together, okay? Let's say we have egg and glove. It's going to say egg yay of glay. Perfect. That's exactly what we wanted. So let's well, that's pretty much it. Our code is totally working. Okay. Now we just need to stick these words together to make the sentence. Now to do that, let me just get rid of all this. We just need to stick the words back together, then print it out. Okay. So to stick it together, all we have to do is put a blank space and use the join method. Okay. The join method is another string method. And what this is basically saying is join each of the words in the new words list together, but put a space in between them. So let's say if we had a word that said happy and we had birthday, then this would give us this joining thing would give us, but it would basically give us one string that said happy space, birthday, because we joined both of these together with a space. Okay, so hopefully that makes sense. We basically just joined each of the words together with a space to make a sentence. And that should be... Oh no, and we do need to save this in a variable called output. So now we actually have to save that somewhere, and now we just print out that output to the screen. And that's that. So dun dun dun, we can finally print the output. Let's see how this works. Let's enter a sentence, shall we? Let's say, hello, my name is Ziad, and it's great to meet you. Hello, hey, my a, amin a, is ye, iad ze, and ye, it's ye, eat grey, ote, eat me, ooh ye. What the hell? Okay, that's fantastic. But for sure, you're going to want to share this with your friends and have a few laughs. I hope that made some slither of sense, right? It's quite complicated, but you can see there's nothing in there that you've not been introduced to before, right? It's just the way that you apply these bits and pieces to make your programs, which really is just going to come from practice, and it's going to come from a bit of hard work trying to understand how this works, right? So just watch the video again a few times, try and go through it and make it yourself. This is just kind of what you've got to do to start thinking like a programmer and how you can make these things work, because you know all the little pieces. You know string concatenation, you know slices, you know for loops, you know if statements, you know lists, you know string methods, you know input. So you know all these things. Sometimes it just takes a bit of a push, and you just got to stretch yourself a bit to be able to build more complicated things. And I believe in you. You totally can do it. If you've got this far, this won't be too hard if you look at it once, twice, 3 times. Okay? Reminded me of a song by Lionel Richie. Anyway, okay, this project has been jam-packed with stuff. Some of it was familiar. A little bit of it was new, right? We had the... what was new? We had this join keyword, and we had the break keyword, this join method, sorry, and we had the break keyword. But other than that, you've seen most of it. And use string methods, use all this stuff all together. And honestly, if you followed with me through this, I'm really, really proud of you. And if you didn't and you found it a bit tough, don't worry, I 100% believe in you. You're going to get it if you watch it 2 or 3 more times. So with the end of that, what we're going to do is we're just going to go for a section review of this section of the course on loops, just to make sure that we've got everything that I've talked about and you've got the main concepts, because that's what's important. And for that, I will see you in the next video. Hello there, you beautiful people, and congratulations on making it to the end of yet another section of the Python Bible. Let's have a quick review of what we've done in this section on loops, and also have a peek forward at what is to come in the remainder of the course. So we started off by looking at while loops. You learned that while loops are loops that continue to run while a certain logical condition is true. To really hammer that point home, you made a program which simulates a conversation with a 3-year-old child that's infinitely curious about everything, as 3-year-olds tend to be. The program will continue to say why, over and over until you said just because, which is usually enough to satisfy the curiosity of a 3-year-old child. After that, we moved on to my most favourite thing in the world, for loops. For loops create a variable and then change the value of that variable as they iterate over a certain iterable. For loops can iterate over lists, strings, and any iterable data type, anything that can be iterated over or indexed. You learned how to make for loops work with dictionaries in our segmented mini database of student data, which was quite awesome. You then learned how to do magic by harnessing the power of list comprehensions. List comprehensions basically give you superpowers. They combine loops, logic, variables, and data structures all in one simple, elegant line of code and can have really complicated functionality. I highly recommend you learn to use list comprehensions thoroughly, as they are absolutely amazing. After that, we tackled our toughest project yet, the Pig Latin translator. This project had it all, from variables to lists to logic to loops to slicing to concatenation, everything. If you followed through with that project and you understood it all and you went back until you understood it, I am super, super impressed with how well you're doing and how far you've come. You are truly and utterly inspirational when we look back from how we started in this course, so well done, and you have my absolute best congratulations. But we aren't done yet. The next section is going to introduce another critical part of any programmer's toolkit: functions. That's right, you know all those useful things we've been using throughout the course with our code? Well, in the next section, you're going to learn how to make your own. And you're also going to build a functioning tic-tac-toe, noughts and crosses, XO, you know that game where you've got to get 3 in a row? That game. You're going to build that in Python so you can play and share it with your friends. Now, this is going to be another game changer of a concept, functions are. And it's really going to help you keep your code manageable, organized, and easily scalable so that no matter what projects you take on in the future, you'll be ready. Now, you're not going to want to miss that section of the course on functions, so give yourself a well-deserved pat on the back for learning all about loops, and I'll see you in the next video. Hello there, you beautiful people, and welcome to this section of the Python Bible on functions. Functions allow you to break up your program into little reusable pieces of code and make keeping your code organized much, much easier. We've been using Python functions all the time throughout this course, and in this section, you're going to learn how to make your own. This section is going to show you what functions are and how they work, and we're also going to tie together everything we've learned so far in the course into a really awesome project where you're going to make a game of tic-tac-toe, also known as noughts and crosses. Whatever you want to call it, it's this game right here. This project is really going to show off your newfound proficiency as a Python programmer, and by the end of the section, you will have actually made a game. Epic, right? So by the end of this section, you're going to be the master of Python functions, so let's jump right in, and I'll see you in the next video. Hello there, you beautiful people, and welcome to your very first lecture on Python functions. This is going to be a complete game changer of a lecture for you, and it's going to really open up a lot of the possibilities for what you can build, and it's really going to deepen your understanding of how Python actually works. So in this lecture, you're going to learn what functions are, how they work, and how to create them for yourself. And by the end of this lecture, you're going to know all about defining functions, returning values, and also how to pass arguments and parameters into functions. If that all sounds like a foreign language to you, then you're in the right place. Let's get into it. So what the heck is a function? Well, a function is a block of organized and reusable code that performs an action or gives some result. Okay, so let's just jump right in and make one that simply adds together two numbers. Functions are made by defining them. Okay, you have to define a function, and to define a function, you use the def keyword, like this. So I just type def. Now let's say we wanted to create a function called add, and it takes two numbers. Whatever they might be, we're just going to call them x and y. So we type def add, and then open some parentheses or some brackets and type x, comma, y, and close the brackets. Then type a colon. Okay? Now def tells Python, the def keyword tells Python that we are defining a function. Add is the function name, and whatever is inside these brackets, inside these parentheses, are parameters to the function. They're called parameters. These are basically what pieces of information you need to give the function in order for it to work. So in our case, in order to add two numbers together, we need two numbers, right? X and Y. These parameters can be called whatever you like. I could have called this tuna and apple, right? But that doesn't really make much sense. But you can call parameters whatever you like, as long as you separate them with a comma, so x comma y, like that, and you stick to Python variable naming rules. So they can't start with a number, they can't have spaces in them, just as you would normally name a variable, just name them the same way. So now inside the function, we're going to type some code that we need in order to perform the operation that's going to add two numbers together, right? So if we want to add together x and y, we're just going to type x plus y, right? And that's it. That's our very first function. We use the def keyword to define a function called add, and add takes two parameters, x and y. The function then simply computes x plus y. So if x was 5 and y was 10, the add function would do 5 plus 10, which is 15. So let's see it in action. So now to get our function to run, we need to call the function. Okay, it's called calling a function. So the way that we can make this work is if we did add, just type the function name, and then you type in your parameters. So let's say we want to add together 5 and 10. Okay, now actually you may not have noticed it, but so let me just go back and show you. If I type in add and open the brackets, you can see this little pop-up come up here. That's Python telling us what parameters we might need. So we need two numbers, let's just say 5 and 10. So that's something quite useful. Now when I press enter, now why didn't that work? Well, this was an intentional mistake to highlight something really important when you work with functions. If you want to get something out of a function, the function needs to return a value to you. Okay? Sometimes you just want the function to do something. It doesn't need to actually give you back a value or give you back anything. It just needs to do something. Those you don't need to return anything, but we want to get the answer back. Okay, we want to get the answer back, so we need to return whatever this is, whatever this number is here. So the way that we do that is we use the return keyword. We type return x plus y. Okay, now I'm just going to make sure I've got my indentation right. Oops, let me just get rid of this and start again. Def add x and y, return x plus y. Okay, now when we call the function add 5 and 10, you can see that it returns back to us the number 15, which is fantastic. Now, because this function actually returned a value, we can store that value inside of a variable to use later. So for example, if I had answer equals add 120, now when I press enter, if I show you what answer is, we can see that answer is 120. Now that's awesome, right? We can use functions to do procedures. We didn't have to code this again, okay? We just had to code the function once and it will give us the correct answer every time. Functions, this is why functions are used, to make your code nice and reusable. It's got the idea of write it once, use it over and over and over again, which makes them incredibly powerful. So that's pretty sweet, right? Now there's an incredibly important point that I want to show you, as it's a very common mistake when using functions, especially if you're a beginner, okay? The point is returning values is not the same as printing, okay? I'll say that again. Returning values is not the same as printing. So let me show you what I mean. If I change our function, okay, if I change our function here, and instead of saying return x plus y, I print x plus y, okay? Now, when I run it, let's say if I just add, oops, in capital, let's say if I just add 5 and 2, you see we get back 7. We see 7, right? But if I try to store that value in a variable, like answer equals add 5 and 2, we see 7 comes up, but if I try to look at answer, nothing comes up. If I actually look at the type of answer, we see none, right? It's empty. And the reason is print just showed the value on the screen. It didn't do the required processing to store the result under a variable name in the computer's memory. So watch out for that. Print, in general, just if you're going to assign it something, it always returns none, right? So if I had a equals print hello, right? And I look now at type of a, we're going to see that it's none. Print doesn't return anything. It just shows things on the screen. So watch out for that, as it's a very common mistake for beginners. So I'll mention the point one more time. Returning is not the same as printing. Okay, I think we've got that now. All right, let's make another function. So what if I wanted to use a function that would take in some text and write it backwards? Well, in Python, you can reverse iterable data types with a neat trick using slices. So let's say I had a word, and it contained the string, let's say the word was just pen, okay? Now, to reverse it, all I'd have to do, using slices, is type word, open my square brackets, colon, colon, -1, and we see nep come back, which is pen written backwards. So let's define a function that can use that. And by the way, this trick here is magic, but totally amazing. Now, as a challenge for you, go ahead and create a function called rev, so R-E-V, and let it take in a parameter called text. Then, using the trick that I just showed you, return the reverse text of whatever they put in. So pause the video now and have a go at creating your own function, then come back and see how you did. How'd you get on? Did it go okay? Well, here's how I'd have done it. I'd have typed def rev, and we're going to take in a parameter called text, like I said. So we're going to type in there text. Remember, this can be called whatever we want. This could be called bananas, right? But I'm going to call it text. So what we're going to do, if I just typed text ++-1, That's good enough, but we want to get the value out. Okay, so we need to return the value, not print it. Now, if I run this, so let me just click that enter. We've now defined that function properly. And if I run this and I type rev and I give it the parameter of pen, we're going to see that we get nep back. Now, this is also going to work with lists, right? Because this trick that I showed you here just works for Python iterables. So I could type in rev of, let's have a list 1, 2, 3, 4. And it's going to give us back 4, 3, 2, 1. So fabulous. We now have a function that can reverse any Python iterable. And the best part is it only took 2 lines of code. Awesome. So if you got that right and you followed through with that challenge right there, you're well on your way to becoming a Python function master, which is a cool thing, I promise. So I think we'll have a break there and just have a quick review of what we've learned so far. So first of all, you learn that functions are pieces of reusable code. They take inputs sometimes, and those are called parameters, and they sometimes return an output for you to store in a variable and use later. Now after that, we jumped right in and actually made a function that adds together 2 numbers. We learned the difference between returning and printing, and why returning values from functions is important if you want to use the value the function gives you back later. After that, you learned that functions can work on any data type really, and we made a function that can reverse any iterable using this slicing trick, and it will give it back in its new reversed form for us to use in any variable later on. So okay, great. Now that you know how functions work, we define them, give them a name, and give them appropriate parameters and some code, and have a return statement if necessary. We're going to dive a bit deeper into what happens to the values you pass into the functions when they are actually inside the function itself. Now, functions can hide certain pieces of information from the outside world using something called variable scope. Now, this is an incredibly important concept, and it's really instrumental to how you'll work with functions in the future. So up next, you've got a quick coding challenge to check your understanding of functions so far, and after that, we're going to jump right in to discussing variable scope. You're not going to want to miss this, so I'll see you in the next video. Hello there, you beautiful people, and congratulations on finishing that last coding challenge, and welcome to this video on variable scope. Now, scope is a very useful programming concept that allows you to keep certain parts of your program from interfering with others, and it's especially applicable to Python functions. Now, knowing how to use scope can make your life easier, but not understanding it can have you scratching your head, wondering where it all went wrong. So in this lecture, we're going to take a deep dive into the world of variable scope and how it applies to Python functions. By the end of this video, you're going to know what variable scope is and why it matters. So without further ado, let's get into it. So the first concept you need to understand is that there are only really 2 types of variable scope in Python. The first, there's one big global scope, okay, and there are multiple little local scopes. Now, if a variable is in the global scope, it's called a global variable and can be seen anywhere in your program. Now, on the other hand, if a variable is in local scope, it's called a local variable and can only be seen within the specific local scope that it's in. In Python, functions create local scopes, whereas loops and if statements don't. So let me show you an example. I'm first going to open a new script called scope.py. Okay, so file, save as on the desktop, Python Bible, scope.py, save it, maximize it, and we're good to go. So inside here, right at the top, I'm going to create a variable called a and set it equal to 100. Now I'm going to make 2 functions called f1 and f2. So define f1. It's not going to take any parameters. Parameters are optional depending on the function. And we're going to print a. Okay, then I'm going to do exactly the same for f2, and we're going to print a. Okay, now when I run both of these, so I'm going to do f1 and f2, this is going to call f1 and then f2, and when I run it, we're going to see that 100 gets printed out twice. Awesome. Now, why does this happen? Well, the reason why this happened is because a has global scope and was therefore visible inside both of these functions, and by that I mean global variables are visible everywhere inside your program, and therefore these functions could see the variable a. Now watch what happens if I move A's definition inside of function 1 using just a cut and paste there. So we now define A inside function 1. When I save and run this, we now get an error, right? We get an error because function 2 can't see the variable A. It says here, look, error in function 2, name A is not defined. And the reason for that is because the variable A was outside of F2's scope, because A is in F1's local scope, and therefore F2 can't see it. So an important thing to know is that functions always create local scopes inside themselves. So F1 has its own local scope, and F2 has its own local scope, and neither function can see what is inside the other function. In the previous example, they could only see A because A was global and therefore visible to everything. So imagine this local scope being like a little bubble for each of the functions, and whatever's inside is protected, and anything global outside can also come inside the bubble. Now, if I recreate F2 like this, okay, I'm going to go inside F2 and I'm going to say A is 50. Okay, now we can see if I save and run this that both functions work, but they give a different answer, even though they both use, if I can open up the thing, they both use a variable called A. And this is because the different local scopes that each function has. Local scopes, as I say, are like little bubbles. And the benefit of using local scopes is, imagine if I had 50 functions in an epic beast of a program, right? I wouldn't need to worry about making up a new variable name every time I wanted to use the functions, in case I overwrite something, right? I might be concerned about overwriting a variable. All I need to do is make sure that the variable scopes don't overlap, which is much easier to deal with. Now check this out. It's pretty crazy. What if I create A at the very top here in the global scope to be 250, okay? And I redefine A in each of the local scopes. Okay, so I say A equals 250, then in F1 I say A is 100, and in F2 I say A is 50. Okay, now I'm going to run function 1, run function 2, and I'm also going to print A. Okay, so whatever A is finally is going to be shown there. Now when I run this, we're going to see that function 1 prints 100 as expected, function 2 prints 50 as expected, but down here A is still 250. So why didn't A change even though I was overwriting it in each of these functions, right? It was first 250, I said make it 100 and print it, make it 50 and print it, but down here it's still 250. Well, this is because when you try to change a global variable from inside a local scope, Python stops that from happening and automatically creates a local variable with the same name. So in F1, we didn't actually change A up here. Python created a local variable called A and set that inside the function because Python thought, I don't want them changing the global variable because that could cause problems. And the same thing happened in F2. We didn't change A up here and we didn't change the A here. Python actually created a local variable called A inside function 2, made that 50, and then printed that. So finally, because the global value of 250 was protected, that is what was printed when we printed A down here. So to recap that main point there, you can't change global variables inside of functions automatically. And by the way, in case you're curious, these local variables are destroyed when the function finishes. Okay, so Python gives the variable some memory space. When the functions run, it just removes that variable from memory. So now you can't change global variables from inside functions automatically, but you can use the global value as long as you don't change it. You can use it, but not change it automatically. So for example, let me create a variable called B and set that equal to A plus 10. inside of here. So what I'm going to do is I'm going to say b is equal to a plus 10. Okay, and I'm going to print b in here. Now I'm going to leave f2 the same, and I'm going to keep all this the same. Now what we're going to see when it runs, oh my goodness, it's slow. Okay, so now we're going to see that function 1 actually printed 260. Function 2 just printed its local variable, and the global variable was printed here. So you can see that function 1, it looked inside of itself and it said, I can't see inside of my local scope a variable called a. So it looked outside into the global scope and was like, aha, I see a variable there called a, I'm going to use that. So it had 250 here. And then it did 250 plus 10, and that was 260, saved that in b, and then printed 260 out, which is what we see right here. Okay, now with function 2, we defined a as 50. Python was like, okay, we're not going to let you overwrite the global variable, we're just going to create a local variable, and it printed that. And because the global variable was protected, when we printed it out, it still had its original value of 250, which is what we see there. Now, in the interest of time, I'm going to cut this video short here, and we'll continue discussing about variable scope in the next video. But just to hammer home the points that you've learned in this video, there is global and local scopes. Okay, functions create local scopes, and everything inside of a local scope is only visible within its own little bubble. Global variables are visible from everywhere, and they can be accessed from everywhere, but they cannot by default be changed from inside a local scope. If you want to change a global variable, you either have to be in the global scope, or you can use a trick that I'm going to show you in the next video. So I'll see you in the next video to finish up our discussion of variable scope. Hello there, you beautiful people, and welcome back. So what we learned in the last video was that if you have a global variable, you can use that value inside of a local scope, and Python's going to be totally fine with that. But until you try to change that global variable, at that point Python's going to stop you, and it's going to create its own local variable inside the function with the same name. So here, where I had b equals a plus 10, that's fine, because Python is going to say, oh, okay, he just wants to use that value and save it use it and save the answer somewhere else. That's fine. But here, they're trying to redefine a, it's allowed, but what Python's going to do is it's going to create a local variable called a, and that is completely different from the global one up here. Now that's the default. In this video, I'm going to show you how you can actually use this, how you can actually basically overwrite a global value from inside a function. And the way that you can do that, if you absolutely want to, is to use the global keyword. Okay, and let me just up here, I'm going to type global a, and I'm going to say a equals 100. Now I do need to have two separate lines for this. I can't say global a equals 100. Okay, I have to say global a to let Python know, hey, I'm going to change the global variable called a sometime soon. Then I do it. I say a equals 100. And then I print a. Okay, so what's going to happen is we start off with an original global value. We say Python, we're going to change it, watch out, and we're going to set it equal to 100 and print it. And then let's just show you what happens. Okay, so what we see is we get 100, 50, 100. And the reason we got the 50 in the middle, okay, actually let's just start from the top. We had a global variable called a, okay? We then say to Python, hey, I'm going to change it with this global a statement. We then change it to 100 and print it. Now in function 2, because we didn't type global a, the same rules apply the same default rules apply, I should say. in that Python is going to see that you're trying to overwrite a global variable. And it's going to protect itself and it's going to stop you from doing that. Okay, so this is just going to create a local variable called a inside the function f2. So this is going to be local. This is going to be the global value. Okay, we then print. We then do f1, which is going to print the global value. We then do f2, which is going to print the local value. Then we print the global value again, and we see that we see the global value as 100. It's been changed in function 1. We then print the local value of 50, and again we print the new value of global A. It was 250, but because we changed it in function 1, it has now been changed to 100 down here. So I hope that makes sense. Okay, by using the global keyword and defining what variables you want to access, you can override the default protection. And bear in mind, you can't write, again, I know I said it, but you can't write global A equals 100. Okay, if I do that, it's going to say invalid syntax, and it's just not going to run. You have to type global A and A equals 100. Now that will work. So there's a slightly special case of these rules, and that's when you use lists or dictionaries. Okay, so let's say I change A, instead of being a number, I change A to be 1, 2, 3. Okay, I'm going to get rid of this, that global statement, and I'm going to just say in here, I'm going to try and set A to be 10. Okay, we're going to see that, as usual, the global value is protected. Okay, because it just will. We can't overwrite the whole list. However, what we can do is, without using the global keyword, I can change a little piece of it. Okay, so let me say I want to change the first number to 5. Now watch what happens here. You can see that the first value has been changed to 5 in function 1. Function 2 stayed the same because we tried to overwrite the whole list, but you can see that the global value has also been changed just because we overwrit a little bit of it. And we didn't have to use the global keyword. So do watch out for that, because that can trip you up, and it's strange behavior, and it works the same for a dictionary. So do watch out for this when you're working with lists and dictionaries. And awesome, I mean, that's pretty much everything you're going to need to know about variable scope. However, it can be confusing, so let's just have a nice recap of what we've learned, okay, in the past few lessons. The first thing you learned was that there are 2 types of scope, okay? You know, there's 2 types of scope. There's global and local. Now, Python functions create local scopes, okay? But loops and if statements don't, okay? Just the functions do. And you saw that global variables are visible everywhere, and you could define a variable called A in the global scope, and everything inside the local scopes will be able to see it. And they can use that value as well. They could print it out if they wanted. So let's say if I got rid of this, we could, as usual, print it out. And that's going to, every local scope can access the global functions, global variables. The difference is you can't overwrite a global value from inside a local function, or local scope, sorry. And what happens instead is Python, if it sees you wanting to overwrite a global value, it's going to block you unless, and it's going to create a local variable with the same name, unless you use the global keyword. So let's say I type global A, and I said A equals 100. This is going to now overwrite for everyone the value to be 100, and we're going to see that that's going to propagate through all 3. Now, the exception to this is when you're using lists or dictionaries, and they also do not let you overwrite the whole thing, but without using the global keyword, you can, in fact, overwrite a little piece of it. So I could say A0 is 5. and that is going to as well change for all three functions. So I hope that makes sense. It's quite a lot of stuff to take in, so don't worry if you have to rewatch these videos a few times if you're still a bit confused, as it is a rather confusing topic. Just watch it again, take good notes, and try it out for yourself. I mean, that's the best way to learn it, right? And I'm sure you'll have a eureka moment sometime soon. And it's well worth learning this properly rather than skipping it and ending up confused for hours and hours when your program breaks or does something unexpected in the future. So just spend the time now, get the concept down, and you'll thank yourself later. So if you do feel comfortable with all of that, next we're going to be coming on to the difference between function arguments and function parameters, which is a critical thing, and it's very important you need to know about. So I'll see you in the next video. Hello there, you beautiful people, and welcome to this lecture on keyword arguments and default parameters for functions. So we're first going to have a quick discussion of what a function parameter is, and also what the difference is between function parameters and function arguments. This is a problem known to keep many people in the programming community up at night, but it's rather simple really. After that, we're going to learn how to use keyword arguments and also how to use default parameters so that we can make our functions much more flexible to use. And by the end of this lecture, you're going to know the difference between a function argument and a function parameter, which is always good at parties, and you're going to be able to give your functions default values. So let's get into it. So let's go ahead and make a function that's going to tell us about someone. We're going to use the def keyword, which is short for define. Our function is going to be called about, and we're going to give it three parameters. We're going to give them the person's name, their age, and their likes. Okay, now what we're going to do, we're going to make, first of all, we're going to have a local variable called sentence, and we're going to say meet blank. They are blank years old, and they like blank. And we're going to format in there their name, their age, and their likes. Okay, awesome. And we just want to return that sentence. Okay, so to call this function, we'd use about, and let's say we're going to say the person's name is Jack, they're 23, and they like Python. And we're going to say it says meet Jack, they're 23 years old, and they like Python. Brilliant. So here we can clearly see the difference between a function argument and a function parameter. The parameter is what we use in the function definition. So the parameters in this case would be name, age, and likes. Those would be our parameters. But the arguments are what we actually pass to the function, or what we give to the function when we call it. So here our arguments are Jack, 23, and Python. The argument Jack matches to the parameter name. The argument 23 matches to the parameter age. And the argument Python matches to the parameter likes. And the reason it does that is because we type them in a specific order. But we can enter our arguments in any order we like, as long as we make it clear which parameter they associate with. And when we do that, they become keyword arguments. So let me show you what I mean. Instead of typing it like this, which requires every one of them to be in the correct order, what we could do is we could say age equals 23, comma, name equals Jack, comma, what was the other one? Likes equals Python. And when I run that, it's going to give us exactly the same thing, but you can see we've got some flexibility in the order. These are keyword arguments because each argument is associated with a keyword which matches the parameter in the function definition. Now this is all fine, but what if we didn't want to give a specific value, but we still wanted the function to work? I mean, maybe we didn't know what the person liked, for example, but we knew their name and age. I might be able to change the order, but at the moment I have to enter three arguments. If I didn't, let's say I just took out their likes like that, and I just tried to type in Jack23, we're going to get an error, and it's going to say the about function is missing one required positional argument, and it's missing likes. By the way, when I said that these things have to be in a certain order, those are called positional arguments. When we give them the keyword, they're called keyword arguments. They're basically the same thing, it's just one has more flexibility than the other. So how can we actually make this function run without having to give the likes? But we still want to be able to do something with it, right? We still want to be able to process the likes if we've got that information, but if not, we still want the function to run. Well, to do this, we have to give the function, we have to give the likes parameter a default value. So if we don't give the function what that person likes, it's going to default to another value. Okay, and the way that we can do this is I'm going to take my function definition down here, and what we do is in this function definition, under the one that you want to give a default value, you use a equals sign, and let's say by default that person is going to, everyone that uses this function is going to like Python, because who doesn't like Python, right? So that is going to set the likes value by default to be Python. So now when I use about, I can type Jack, and his age is going to be 23, and by default you can see meet Jack, they are 23 years old and they like Python, even though I didn't enter it. But if I do enter it, let's say they like football, which is a lot more realistic, isn't it? If I do that, meet Jack, they're 23 years old and they like football. So now we have a lot of flexibility. We can enter that value or not. But there's something rather important to know when you're dealing with default values. Default parameters must go at the end. Okay, so for example, I couldn't, when I was defining the thing, I couldn't say name equals, let's say by default their name is Jack, and then after it I just have these two ones without default values. No, I'd have to put age, then likes, and then put the name. Okay, I'd have to do it like that. Your parameters with default values have to go last. So I'm just going to put that to the way that it was before. And I can have as many default parameters as I want. Obviously, I could have, let's say, okay, they like Python. Let's say I had hair color. Right? I could set that to a default value there, and you can have as many of those as you want, but as long as your default values come last. So just bear that in mind. So watch this as well. If what I can do is, if I gave all of them default values, let's say the default name was Ziad, the default age was 23, and the default likes was Python. Okay, so let me define that function again. Now I can, if I want, I could say about, let's say we want Jack, he's going to be 29 and he likes football. Okay, that's going to work just fine. But if I just call about with no parameters or no arguments in this, no arguments, it's not parameters, hit with no arguments, then I can press enter and it's going to use all of the defaults. So that's quite awesome, right? Your function's going to work whether you give it information or not. This is a general case and that gives you a lot of flexibility. So you're going to want to hang on to that. And that brings us to the end of this lecture on default parameters. So let's just have a quick recap of what we've learned. We started off with a discussion of what a function parameter is and why they're different to function arguments. You learned that parameters are what are in the function definition and arguments are what you actually pass the function when you call it. After that, you saw how to use keyword arguments when passing arguments to your functions so that you can enter your arguments in any order that you like, which is opposed to positional arguments which have to be put in the correct order. You also saw that you can actually leave out certain arguments as long as you have a default parameter in your function definition, and you can have as many default parameters as you want, as long as you put those default parameters after the non-default parameters when you define the function. So like up here, likes had to go last. And there you have it. You now understand the difference between a function argument and function parameters, and you can use keyword arguments and default values in your functions at will. So check you out. Now, in the next lecture, you're going to be learning techniques that will make entering arguments to functions much easier, especially when you have a lot of them. And also when your functions get a lot more complicated, this is going to come in really useful. So you're not going to want to miss this, and I'll see you in the next video. Hello there, you beautiful people, and welcome to this lecture on packing and unpacking variables. Now, sometimes entering values into a function is a bit restricting or a downright pain. Now, in this video, you're going to learn some tricks that's going to make working with functions an absolute dream, especially when they get quite complicated. So the concepts we're going to be looking at might be a bit tricky, but I'll try my hardest to simplify them as much as possible. We're going to look at the concepts of packing and unpacking variables, and while potentially difficult to grasp, these are incredibly useful concepts. We're going to look at unpacking arguments and packing arguments, as well as unpacking and packing keyword arguments. So after this lecture, you're going to be able to make much more flexible functions, and also using functions should be a lot easier for you as well as your projects get bigger and bigger. So let's get into it. Okay, so first of all, let's check out how to unpack arguments. To show you this, I'm going to use the simple print function. If we do print of 1, 2, 3, 4, 5, you can see that we're passing in 5 arguments to the print function, and it's just going to print them all out on one row. Okay, now if I have a list of numbers and I put in there 1, 2, 3, 4, 5, if I print numbers, yeah, we're just going to see a list pop up, okay, because we've passed one argument to the print function, which was just one list. Now, if I unpack the list before we print it, like this, okay, we're going to put numbers in there just like normal, but at the front, I'm going to put an asterisk or a star, okay? This is what you use for multiplication. It's the same symbol. So now we're going to unpack the list before we print it. And what happens then? You see we get exactly the same result as earlier on. Okay, so what's happening now when you unpack arguments is that we take each item from an iterable data type like a list, and each of those items becomes its own argument to the function. So instead of having one big list of 5 numbers, we now have 5 mini arguments, 1 number each. Pretty sweet, right? So you can unpack any iterable data type before they go into functions. So this means this is going to work for strings as well. If I just print ABC, right, I put in one argument to the function, and you see ABC just as one string come to the screen. But if I print the unpacked version of ABC, using this star at the beginning, now we're going to see A, comma, B, comma, C. Okay, that's the same as typing this. Oops. So you can see it unpacks into each individual item as an argument to the function. And you see we get exactly the same thing right there. So that's pretty useful, right? Okay, so the next thing is how to pack arguments. We've done unpacking. How can we pack them? The way this happens is it works inside a function. So let's create one. Let's create a function that adds 2 numbers. So define add x and y, and we're going to return x plus y. Simple, right? Just what we did a few videos ago. Now, if I put 2 numbers in this, okay, this function's going to work great. I can do 10 plus 10, and that's going to work absolutely fine. But it's slightly limited because this function only has 2 parameters. It won't work for 3 numbers, or 4 numbers, or 5 numbers, and so on. It's only going to work for 2. So what we can do is, instead of putting x and y up here, we can just type this. Okay, we're going to do that. We're going to copy and paste the thing, and I'm just going to pack in as many numbers as possible. Now, what's going to happen is it's going to pack whatever arguments that come in into one tuple called numbers. Okay, and because tuples are iterable, we can loop through them and add them up. So what we can do is we can say total equals 0 for number in numbers, total equals total plus number. Then we're going to return the total. Okay. Now, watch what happens here. Now I can add in as many numbers as I want. 1, 2, 3, 4, 5, 6, 7, 8, 9. And we're going to see that's going to give us back 45, which is true. Okay. What happens is all of these arguments get put into a tuple called numbers. It's basically like doing this. It's basically like taking all of this and saving it in a tuple called numbers. Then we loop through that tuple and add them all up and then print out whatever that value is. Okay, so or return back whatever that value is. So we can now add up any amount of numbers. And what we've learned is that packing is very useful when you don't know how many arguments you're actually expecting, and it makes your function a lot more flexible. So instead of just having to define x, y, z, a, b, c, d, e, f, g to take up all the things and taking all the numbers and giving them a default value of 0, for example, if they weren't entered, all we have to do now is just pack them all in to one tuple and loop through the tuple, and that tuple can be as big as we want. So it's given us a lot of flexibility. So that's packing. So what about keyword arguments? Well, keyword arguments, just so you recall, are if you have a function, if I can just get rid of this line, if you have a function like add, okay, and instead of just typing 1 and 2, let's say, where these are positional arguments. So the first thing we've typed is going to become the first parameter, and the second thing we've typed is going to become the second parameter. Keyword arguments would be like this: y equals 1, x equals 2. Okay, so we're saying which parameter this value is. How can we pack and unpack these? Well, we're going to start with unpacking, and this is basically going to, instead of producing, it's basically going to work on the concept of dictionaries. Okay, so let's bring back the function we made previously that tells us about someone. We're going to say define about, name, age, likes, and we're going to have a sentence, meet so-and-so, they are blank years old and they like blank. And we're going to format their name, their age, and their likes. And then we're going to return that sentence. Okay, so now let's say that we have a dictionary like this. Okay, our dictionary is going to be name, and that's going to correspond to Ziad. We're going to have age, and that's going to correspond to 23. And we're going to have likes, and that's going to correspond to Python. Okay, so we've got a dictionary like that. Now we can unpack this dictionary into this function. And the way that we do that is, instead of just typing 1 star, we type 2 stars because they're keywords. Okay, let's just remember that. 1 star for normal arguments, 2 stars for keyword arguments. And we type the name of the dictionary, which is dictionary here. Now when I show you that, that's going to say meet Ziad, they are 23 years old and they like Python. And the good thing about dictionaries is I can type these in whatever order, right? Because it's the key that is this is becoming the parameter, and this is becoming the argument. This is becoming the parameter, this is becoming the argument. It doesn't matter what order that I put those in, it's still going to work the same. So this is exactly the same as typing about name equals Ziad, age equals 23, or not like that, age equals 23, and likes equals Python. It's exactly the same thing, but you don't have to type it by hand, you see. You can just have some kind of automatically generated data structure and then just pack them all in at once. So that's pretty straightforward, right? Now, for this to be useful, you need to remember that the dictionary will very likely be generated automatically somewhere else in your program, so you won't be typing it out by hand like I just did. That kind of defeats the point. So finally, let's have a look at how you can pack keyword arguments using the double star operator, just like we did here. So I'm going to make us some space, and I'm going to define a function called foo and pass it just one parameter, or give it one parameter called quargs. Now quargs is just a convention. It's short for keyword arguments. There's another convention as well where you just have star and args, which is just short for normal arguments, which is what we've been seeing up here. So you know how you see how up here we called it numbers? In the Python community that would be called args, but you know, you can call it whatever you want. It's just a convention. So I'm going to stick with double star quargs. Now when we pack something, when we pack down these keyword arguments, we're going to produce a dictionary out of them, and that dictionary is going to be called quargs. Just like up here we made a tuple of them, we made a tuple called numbers. Here we're going to make a dictionary called quargs. And what we want to do, we just want to print and show what the key was and what the value is for that specific, I guess, that specific keyword pair. So what we're going to do is we're going to say for key comma value in quargs dot items. Okay, this is going to give us basically a set of tuples, and each one is going to have a key and a value, and the key is going to match the key and the value is going to match the value. Basically, we just want to print blank comma blank and format in there the key and then the value. So now watch what happens if I do foo of Huda equals female and Ziad equals male. We're going to see that that is going to produce a dictionary of these keywords, and then it's going to loop through that dictionary and give us the appropriate format, which is quite neat. So if you've got a bunch of keyword arguments that you don't know what they're even going to be called yet, we didn't define a keyword to be called Huda, we didn't define a keyword to be called Ziad, but this kind of dealt with the whole process. So this could be as long as we wanted. We could have John is going to be male as well. You see that it works in exactly the same way. So that's how you pack down keyword arguments into a dictionary and loop through them. And that's it. Now, I know this is quite a hardcore lecture to digest in just one bite, so have a go at playing it a few times to help it sink in, and also, you know, just have a go. Just jump in there and try it out yourself and see if you can get it to work on your own. You'll learn a lot more by doing, trust me. Now, let's have a quick review of what we've done in this video to help you remember all of this stuff. First, we use the star operator, and the star operator is used to pack and unpack just regular old iterables. You can pack them into tuples inside of functions, or you can unpack them as arguments when you put them into a function. So the example where we used this was to make the add function. Do you remember where we could add up any amount of numbers that we wanted? So after that, you saw the double star operator, which is exactly the same concept. It works for keyword arguments. Now you can unpack keyword arguments into a dictionary inside of your function, or you can pack them into a dictionary for your function. Okay, so it's going to work in pretty much exactly the same way. It's just it uses a dictionary because there's two pieces of information, right? There's the keyword and the value, whereas before there was just a value. So if it doesn't all make sense in the first time you've gone through this, just watch it again and again, and I promise you'll most likely get it by the third time you see it, I promise. So and if you aren't following along and trying it out and coding along, then give that a go. Practice makes perfect. Now the next video holds this section's project. It's going to be an XO, tic-tac-toe, or noughts and crosses game, however you want to call it, but it's going to be quite a challenge, and it's going to use almost everything that we know. but it's going to be an amazing feeling to actually play a game that you've actually created yourself, and it's going to be a great testament to just how far you've come by using the Python Bible. So to get started making our game, I'll see you in the next video. Hello there, you beautiful people, and welcome to this project where we're going to be making a game of tic-tac-toe, noughts and crosses, XO, 3 in a row, whatever you want to call it. You've most likely played it, and it's going to be epic. So this is going to be quite an involved project, and it's going to use a lot of what we've done so far. As we're getting towards the end of the course, I'm going to step up the difficulty to show you what's possible, and also really use those pieces of the course that perhaps you might have forgotten. So it's going to be a good reminder as well. Now, if you follow along, even though it will be hard, by the end of it, you won't recognize yourself. You'll be so much better at programming Python than you are now, and will have built, with your own hands, a very playable game, and will totally be a great Python programmer. If you're ready, let's jump into it. So I've gone ahead and created a script called game.py in the usual place, and we're going to start off by making the board. So how can we make a board in Python? Well, the board, if we think about it, has 9 spaces, right? 3 columns of 3. So the data type that we need to use to make the board needs to be able to hold multiple things inside of it. So we're going to need a data structure of some sort. So that means if we're going to use a data structure, we're going to use a list, a tuple, or a dictionary. So which one is it? Well, the board can change as, players make moves. So therefore, we can't use tuples because tuples are unchangeable. And the simplest way to access each of the spaces would be to use a number, just to number each of the spaces. And because lists allow us to access elements using numbers, we're going to use a list. So we're ready to go. Our board is going to be just an empty list to start with, and needs to have 9 elements. So what we could do is we could type board equals and give it blank spaces like this 9 times. But I'm quite lazy, right? I don't really want to type that 9 times. So what I'm going to do is I'm going to use a list comprehension. And I'm going to say, give me a blank space for I in range 9. And that's that. Now, I isn't actually being used, but this loop is running 9 times, and it's giving me a blank space. Okay, so that's going to give us a board with 9 blank strings in it. Brilliant. So if I print this board, you should be able to see that. There we are. 1, 2, 3, 4, 5, 6, 7, 8, 9. Told you list comprehensions were useful, right? So let's just close the shell. Okay, so now we have our empty board. But when I run this, right, it doesn't really look like a tic-tac-toe board, right? A tic-tac-toe board is a grid, is a 3x3 grid. So we want to actually see something like that if this game's going to be believable. So let's just head back over to our function. And the way that I'm going to have this board printed is I'm going to use a function, okay? And I'm going to define that function. I'm going to call it print board. Now, to create each of the rows, I'm basically just going to print a string. So row 1 is going to be a string of blank, blank, blank. Now, if you're wondering where I'm getting these, they're called pipe symbols. On my keyboard, it is, I press shift and I press the key next to the letter Z. So it's just above the backslash on my keyboard. Yeah, I can't help you if it's not in that position, but just look for the pipe symbol on your version of your keyboard and you should be able to find it. Now, in each of these, this is going to be the first space of the board. This is going to be the second space of the board. This is going to be the third space of the board. So to do that, I'm going to format board 0, board 1, and board 2. Okay, so that's row 1 as a string. I'm going to copy and paste that onto the next line, making sure the indentation's the same. Did you see how it was indented 1 across? That would mess Python up, okay? Now it has to all be in line. So row 2, it's going to be board 3, board 4, board 5, and one more time. Okay, so row 3, we're going to get board 6, board 7, and board 8. Okay, now to actually make it print out, we're going to print a blank line, print row 1, print row 2, and print row 3, and then finally a blank line underneath the board. And these extra blank lines here are just to make it look nice. Okay, they don't really do anything else. So that's our function. Let's go save that. Now when I print the board, when I run the print board function, all of this code's going to run. And what we're going to see is we're going to get our beautiful tic-tac-toe board on the screen. How nice is that? Now this code is slightly repetitive, right? I could write a for loop to print this out, but because it looks so beautiful, I think we'll leave it just as it is, don't you? Now down here, we're going to have, instead of this print board, we're going to have a while loop that basically runs forever, so the game will continue to run. This is in game programming, this is called the game loop. Okay, and basically the rest of our code is just going to go inside of this. So player 1 is going to play as X. Now we need to ask them where they would like to place their move. If the player enters 1, they're going to move to the top left. If the player enters, I don't know, if they enter 5, they're going to go here. Okay, if they enter 8, they're going to go here. So just imagine these blank spaces being like the numbers on a telephone. 1, 2, 3, 4, 5, 6, 7, 8, 9. So to ask for this move, we're going to create a variable called choice, and I'm going to ask for the input, enter your move 1 to 9. Okay. Now I'm going to want to strip away any white space, and because these are numbers, I'm also going to convert it to an integer. Okay, so now we're going to get a number of actual integer data type inside this variable here called choice. So we can now update the board with that move. But there's something we need to bear in mind, however. Because of the fact, the way that the Python list, its indexes start from 0, if they enter 1, to move to the top left, we actually need to say that that is board index 0. Okay, so we need to actually enter an X at the index below their choice. So what I mean is, instead of writing board of choice equals X, we actually want to write board of choice minus 1 equals X. So when they enter 1, 1 would be choice, 1 minus 1 is 0, and that is what goes there. Now actually, before we run this, what I'm going to do is actually up here, I'm just going to change this into 2 spaces. And the reason I'm going to do that is just to give a little bit more space inside of our board. So now when I run it, we're going to see our board pops up and enter your move. Let's say we want to go straight into the middle. Okay, so we're going to 5. And bang, there pops up an X. So what if I want to go at the top right? Type in 3. There that is. And come on, let's just win a cheeky game. Go number 7. And there we go. And we can stop this by pressing Control and C. So that's amazing, right? We've now got a updating board depending on which, when you enter your moves. But what we need to do, we need to make this so that you can only enter a move when that place is empty. Okay, so for that, we're going to need to check whether our board holds an empty space or not. So right here, we're going to say if board of choice minus 1 is 2 blank spaces, because I've got 2 blank spaces up here, then if it's empty, basically we're going to say board of choice minus 1 is going to become an X. But otherwise, print a blank line and say that space is taken. I'm going to remove this extra line of code here and save that. So what's going to happen is now we're going to have our empty lit thing. I'm going to go straight in the middle and it's going to go fine. But if I try to press the same space again, it's going to say that space is taken but it still remains our move, which is kind of just like real life. So we've made a lot of progress in the game so far in this video. We've made the board, printed it to the screen, and allowed player 1 to make valid moves. So that's quite great, right? Now up next, we're going to continue working on our game and get player 2 into it. So I'll see you in the next video. Hello there, you beautiful people. So let's continue working on our game. Now in this video, we're going to make it possible to process moves for player 2. Now when we process moves for player 2, it's going to be basically the same as for player 1, right? So what I'm going to do is I'm going to create a function called player move, okay? And the reason I'm creating a function is because I don't want to just be repeating myself. I just kind of want a general function that's going to do a move for a player. And I'm going to give it a parameter called icon. Okay. Now inside of here, I'm going to move all of this inside of there. Okay. And instead of just printing X for every player, I'm going to print that icon. So, for example, if I did player move and I gave it the icon of X, that would mean that it was the X player moving. And the processing is going to be exactly the same. If it's a blank, then you can put that icon there. And if it's not blank, then the space is taken. It doesn't matter whether it's an X or an O, the game works exactly the same way. So, but one thing we do want to add is we want to tell the player whose turn it is. So let's say print your turn, player, like that. And we're just going to put in the icon. So whatever it is, it might say your turn, player X, or your turn, player icon. Or what we could do, actually, is we could have a an if statement. We could say if icon equals X, number equals 1, else if icon is O, number equals 2, and you go your turn player number. Okay, so now it's going to say your turn player 1 or your turn player 2. So that's good like that. Let's save that. So let's run this. Okay, actually no, let's not run it just yet. First, what we need to do is in here, when we've printed the board, we're going to say player move X. Then we're going to print the board to show what happened, and then we're going to do player move for the O. Now when we run this, okay, it says your turn player 1. We can see that it's moving. We can see this working, right? So let's start with the X, go straight in the middle. Popular tactic that. It's going to say your turn player 2. Let's say we want to move up to the top left. Or top right, sorry. And there you go, actually. So we can see that is working fine. Now we've got an O in that place. Let's say we want to move the X down 1. That's moved there. And then we want to move the O right there. Okay, so we're getting the game's working, right? And if I try to move on top of someone else, let's say I want to move on player 2, it's going to say it's not possible for both of us. So we're doing well. So I hope this highlights to you just how important functions are, right? We've managed to write a function once, but made it general enough that it's worked for 2 players. So I hope that really helps you figure out how useful functions are. Our next step is that we need to check whether someone has won the game or not. So let's make a function called isVictory. Okay, define isVictory. And we're going to give it the icon here. So instead of making a function saying did X win or did O win, we're just going to say is it a victory for that icon. Now how do we know if someone has won? Well, there's 8 ways to win, right? They can have all of row 1, they can have all of row 2, or they can have all of row 3. They can have all of column 1, column 2, or column 3, or they can have either of the 2 diagonals, which makes 8. So this is rather simple to program, it's just a bit repetitive, but copy and paste is going to do the job. So let's check if they won on row 1 first. What we need to do for that, if board 0 is equal to their icon, and board 1 is equal to their icon, and board 2 is equal to their icon, then that means they have row 1 and they'll win. But what we're going to need more space for the other 7 conditions. So let's break up this if condition on more than one line, and we can do that by using a backslash. So I'm going to say or, and then type a backslash like that, and you can see the way Python's kept us all nice and in line. So let's do it for the other rows as well. So let's copy and paste this. The second row is going to be board 3, board 4, and board 5. And we're going to say or like that. Now let's do the last row. So board 6, board 7, and board 8. Okay, so that's all of the rows. We now need all of the columns. So for all of the columns, what we're going to need for that is we're going to need board 0, 3, and 6 for the first one. So that's column 1. We're going to need, for the next one, we're going to need 1, 4, and 7. Oh, that was fine, actually. 1, 4, and 7. And we're also going to need 2, 5, and 8. 2, 5, and 8. Okay, so now for the diagonals, we are just going to want to have 0, 4, and 8. And for the other diagonal, going to have 2, 4, and 6. All right, so that's how we're going to check if they win. So if either of all these conditions are true, then actually I don't need an or there. I'm going to put that colon. If either of these conditions are true, we're going to just return true. Otherwise, return false. Okay, so this function is going to give us back true or false. It's going to give us back a Boolean. Now, to make this work in our game, we need to check for a victory after X moves and after O moves. So let's do X first. So X is going to move. We are going to put this here. We're going to say, okay, we should print the board first. So let's check if it's a victory after that. If it's victory for X, we're going to print X wins, X wins, congratulations. And break. And this break is just going to end, it's going to break us out of the while loop. Okay, so that's just basically going to finish the game. So if X has a victory, this is going to give us true, which means the condition here is going to be true. Notice how you can use a function to give you a Boolean rather than just using a normal conditional operator, which is a really useful thing because you can define how you're going to get your Booleans depending on the conditions that you want. So if X wins, this is going to be true and this code will run. If not, we're just going to let player O move. So the only difference now when player O moves is purely for formatting reasons. We're going to need to put a print board inside of this victory condition. So what we're going to do, just purely for formatting things, so let's just pull this over one. Again, make sure the indentation is right. Actually, no, sorry, that needs to be in there. That does need to be in there, inside the if statement. Now, inside of here, we're going to put a print board. We're going to check the O victory, and we're going to say O wins. Okay, so let's have a look to see how that works. So we're going to say X is going to go there, O is going to go there, X is going to go there, O is going to go there, and then X is going to win by just going on 8. And it's going to say X wins, congratulations, and the game will finish. And hopefully the same is going to work for the O, so let's check that. Okay, so we're going to have X is going to go in number 1, O is going to go number 2, X is going to go number 3, O is going to go 5, X is going to go at 6, and O is going to go in 8, and it's going to say O wins, congratulations, and show us a thing. So fabulous, we now have a fully working game. But one thing that we know that happens quite a lot in the game of XO is that there's draws. Okay, so most of the time the game draws. And so we need to make another function called isDraw. Def isDraw. And how do you know if there's a draw? Well, the game draws when there's no space left, right? So what we're going to do is we're just going to say if the double space is not in the board, then, by the way, is that going to work? Yes, it will, because we've defined the board as global, right? So the global variable is going to be in here. If double space is not in the board, then return true, because that means the board's full. Otherwise, return false. Simple as that. So we're going to check for the X victory. We're going to check for the O victory. And then right at the end here, we're just going to say if is draw. Oh, sorry, we're going to say, actually, we're going to, yeah, we're just going to check here, elif is draw. We're going to say print, it's a draw, and we're going to break. So the reason I put it here is because X could move, not win, and the board be full. Okay, so we need to check if the board is full before we let player O have a go, because otherwise the player O could be playing on an already full board. And I'm going to do exactly the same down here. Okay, so we're going to let O move. If he wins, then great. If it's a draw, then stop the game. Otherwise, just go around and let X have a go. So awesome. We know if I run this, that should be pretty much a fully working game. Let's have a look here. 1 is going to go there. I'm just going to type in random numbers, to be fair with you, see what happens. He's going to need to go there. He's going to need to go there. Let's say 6. He's going to go there. He's going to go in number 7 to block him, and then number 9. And it's going to say it's a draw, which it is, because now the game is completely full up and there's no spaces left. So that's working. I mean, that's pretty awesome, right? You now have a game that you can actually play with your friends, XO, that you programmed yourself. So there's plenty of things we could add to this. We could tidy up our code a bit, or we could get the screen to clear itself so we only have one board on it at a time. But I'll leave them for you if you want to program them on your own, rather than dragging everyone through it if they don't. So in general, this is a really quite an awesome project, right? This is something much different to what we've done before, which has normally just been printing stuff to the screen. So you should be super proud of yourself for building this. So why not reward yourself by grabbing a friend or loved one and playing a good old game of tic-tac-toe. Either way, that brings us to the end of this section of the Python Bible on functions. In the next lecture, you can have a review of what we've learned and also get a taster for what's to come in the section on classes, which is going to be all about object-oriented programming, and it's going to take your Python skills to really a massive next level, like industrial level. So I'll see you in the next video. Hello there, you beautiful people, and welcome to this section review lecture for this section of the Python Bible, all about functions. We've really covered a lot of stuff in this section, and hopefully you now have a good idea of how functions are used in Python. Just to make sure that it's all stuck in your head, we're going to do a quick recap, and after that I'm going to introduce you to the next section of the course on object-oriented programming. So let's get into our review. The first thing we learned is that functions are a piece of reusable code that performs an action or gives some result. You made your first Python function that simply added together two numbers and returned us a value. You learned that the return keyword is how you return values from functions, and you use this to store the result of a function operation for later. Most importantly, you learned that returning is not the same as printing. Returning a value lets you store that value in a variable to use later, whereas printing just puts text on the screen. You then smashed a coding challenge, and after that we started talking about variable scope. you learned that there are two main types of scope. There's global scope and local scope. Functions create local scopes inside of themselves, and this acts like its own little bubble. You learned that global variables can be viewed anywhere in your program, but local variables can only be seen inside their local scope. This saves us from having to worry about whether all of our variable names are unique all the way through our program. You can reuse variable names as long as they're unique within their own scope, and you won't overwrite any of your data, which is pretty nice. You also learned that when you try to change a global variable from inside a local scope, Python just makes a local variable with the same name. If you want to change the global variable, you need to use the global keyword. However, you also learned that you can change little pieces of global lists and dictionaries from a local scope, although you can't overwrite the whole thing. After that, you learned the difference between a function argument and a function parameter. Parameters are what you define in the function definition, and arguments are what you pass to functions when you call them. You also learn how to give your function parameters default values to give yourself more flexibility when using your functions, and you also learn the difference between positional arguments and keyword arguments. Positional arguments are based on the order that they're entered, and keyword arguments are entered with certain keywords. Name equals Jack or age equals 15, for example. You then learn how to pack and unpack arguments and keyword arguments, or args and quargs, using the star and double star syntax. Finally, we made a game of 3 in a row using all of our skills from the very beginning of the course, and this gave us a good grounding in just how powerful functions are for building real-life programs. So whatever way you look at it, that is a lot of stuff. And if you look back on where you started with this course and where you are now, it's hard to believe you're the same person. Your transformation has been completely and utterly inspirational, so well done to you if you've been following along. But we aren't there yet. Up next, we're going to be talking about how to use Python for object-oriented programming. Object-oriented programming, or OOP, is an extremely common programming methodology that allows you to build incredibly powerful programs by just thinking of things in your code as real-life objects. I won't spoil too much here, so I'll see you in the next video. Hello there, you beautiful people, and welcome to this section of the Python Bible on Python classes. Now, in this lecture, I'm going to give you an overview of what to expect from this section of the course, and by the end of the lecture, you should have a good idea of where we're going and what to expect next. So in this section, we're going to be learning all about object-oriented programming, or OOP, in Python. OOP is an incredibly powerful and popular programming discipline that helps us make codified representations of real-world objects. First, we're going to learn about what objects are, what classes are, and how the two relate to each other. This is going to give you a good conceptual framework for what the heck is actually going on. Then we're going to jump right in and start creating objects. You're going to learn about creating classes, creating objects, and also how to define class methods and class variables, and how all of these different things tie together. You're also going to learn about class constructors and class destructors and how to use them to set up and destroy your objects automatically. In this section, we're basically going to scale up from modeling a coin object to modeling a set of coins, all the way up to modeling our very own bank. We're going to use classes to create bank accounts for different people and allow them to deposit and withdraw money, just like in real life. So basically, in this section, you're going to learn all about object-oriented programming Python and use it to make your very own bank by the end of it. How awesome. So let's not waste any time and jump right into the next video, where we're going to learn all about classes and objects. Time is money, after all. Hello there, you beautiful people, and welcome to this lecture on the difference between objects and classes in object-oriented programming. So in this lecture, I'm going to give you a really intuitive analogy for what a class is, and also for what an object is, and how the two relate together. Now, this is probably going to give you an excellent conceptual framework moving forward in your programming career, so let's get into it. So first of all, let's talk about classes. Now, seeing as we're making a bank in this section, I'm going to use coins as my example here. Somewhere in a mystical factory, these coins are being produced, right? The coins you and I spend every single day. Now, I'm in the UK, So this factory, inside our factory, there will be a template for a 1p coin, a template for a 10p coin, and a template for a £1 coin, and so on and so forth. Now, each of those templates in programming speak is called a class. We use these templates in real life to make physical coins. And likewise, in programming, we use a class or a template to get an object. So if you can imagine this template in a factory that repeatedly makes the same coin over and over and over again, that template is a class, and the objects that come from it are instances of that class. So every object is just a physical copy, also known as an instance, of a class. If you've managed to understand that, then you've understood the core principle of object-oriented programming. I'll say it again. Classes are templates, and when you make an instance of a class, you get an object. Great. Now that we understand what classes are, let's take a closer look at what makes up classes. Classes are simply made up of variables, also known as states, and functions, which are known as methods. That's right. We've used the word methods before when talking about string methods, list methods, and things like that. And this is because each variable type in Python is its own unique class. There's a class for strings, a class for lists, and so on. Now, different variable types, as we know, behave differently. And what makes them behave differently, amongst other things, are these states and methods that make up the class. So, for example, with a coin states might be its value, its color, the number of edges it's got, might be 1 if it's a circle, its diameter, its thickness, and whether it's heads or not. And that will pretty much define a coin's states. Now, we use class variables to define these states. Class variables are just like normal variables, but we put them inside of a class. Now, a coin can also have several behaviors. For example, you can flip it. For flipping, we would create a function, or more correctly, a method called flip. This method will then change the coin state to be heads or tails randomly. So in this way, by using variables and methods, we can represent the states and behaviors of a real-life coin in a class. Cool, right? Now, I know this is rather theoretical, but I really want you to understand it because it's very important if you're going to do anything with object-oriented programming. So let's just have a quick recap of these concepts just to make sure they've sunk in, okay? First of all, classes are just templates. We instantiate a class to make an object. Another way of saying that is an object is an instance of a class. Another way of saying that is each 50p coin is the result of using a 50p coin class. Okay, that should be pretty clear by now. Now, if you understand that concept, you've gotten the core idea for object-oriented programming. Now, objects in the real world are made up of two things. They have states and they have behaviors or actions they can do. Now, because classes make objects, classes are made up of states and behaviors as well. To create states, we use class variables, and to create behaviors, we just use methods. And by the way, methods are exactly the same as functions. We just call them methods when we're referring to classes. Okay? So if you're comfortable with all of that, then you're set up perfectly to start working with objects in Python. Well done. Up next, we're going to be using these concepts to create our very own coin class in Python. I'll see you in the next video. If you've ever wanted to know how to print your own money, then you've come to the right place. Hello there, you beautiful people, and welcome to this lecture where we're going to be making a coin object using a class. So the first thing we're going to do is create a class that will be a template for a £1 coin. And then we're going to create our very own object, our very own £1 object, and play with it to see how objects work in Python. And by the end of this lecture, you're going to know how to create classes, how to instantiate objects, and also how to access a class's variables using an object. So it makes more sense when you see it. So let's get into it. Alright, so the first thing I'm going to do is I'm going to create a new script called coins.py. So on the desktop, Python Bible, coins.py, save it, maximize it, we're good to go. Now in here, we're going to create our class. The template we're going to make is for a £1 coin. So to make a class, we need to use the class keyword and give the class a name. Now class names in Python by convention start with an uppercase letter. So we're going to type the class keyword in lowercase and then pound in uppercase and type a colon. You don't need brackets like this. You don't need any of that business, just a colon. And that's how you define your class. Now, our class is basically going to have 6 states. It's going to have the value for the coin, it's going to have the coin's color, the number of edges the coin has, the coin's diameter, the coin's thickness, and whether the coin is heads or tails. So let's go ahead and make those states right now. So a pound coin's value, by definition, is going to be £1. So let's make that as a float. We're going to have a variable in here called value, and we're going to set that to 1.00 pounds. Now the color for a pound coin is gold, so I'm going to have that as a string. Because a pound coin is circular, it has one edge, so num edges equals 1. And according to Google, a pound coin's diameter is 22.5 millimeters. So let's put in diameter equals 22.5. And let's put a comment that that's in millimeters. And also it is 3.15 millimeters thick. So 3.15 millimeters. Okay, finally we need a state of whether it is heads or tails. Now I'm basically going to create a Boolean called heads. So I'm going to say heads equals true. If heads was false, then that means it's tails, right? So heads is true is what I'm just going to settle with here. And there we have it. We have 6 states inside of our class to define our coin. Let's leave out methods for now and just make our very first object. So remember, an object is just an instance of a class. So to make our object, we simply need to give it a name. So let's come down here outside of the class and let's just name it coin1 and make that a pound, just like that. And that's it. We'll now have our first pound coin called coin1, and we can see the type of it. Okay, so let's print the type of coin1 and save and run that. And we're going to see it says it's a class of pound, which is fabulous, okay? That's right, ladies and gents, we've made our very own variable type, our very own class. Now, how can we access these states? Well, what we can do is we can type our object name in the shell or here. I'm going to do it back in the script. We can type our object name, so coin1, and then a dot or a period. And you can see if you wait long enough, something pops up here. You can kind of select all of the different states inside here. So let's say if we want to print the value, we just do coin1 dot value like that, no brackets, nothing like that, just coin1 dot value, and let's print that out. And let's delete this print statement here and save and run that. And you're going to see 1.0 comes out. Awesome. So what about the color? Well, I can do it in here to say what coin1 dot color. It's going to say it's gold. Now, what if we wanted to change these values? Okay, well, you can change them. Let's say our coin rusts a little bit and goes a greenish color. I can just say coin1 dot color equals greenish. Now, if I look at coin1 dot color, it's going to say greenish. So that has indeed changed. But now watch what happens when I create another coin. Let's say coin2 is going to be a pound. Okay. Now, if I print the color of coin1, as we know, print coin1 dot color, that's just going to say greenish. But watch what happens when I look at the color of coin2. So print coin2 dot color. It's going to still say gold. And this is the difference between objects and classes. Classes are the base template that all new objects are made from. Once an object has been made, each object can have its own unique characteristics depending on what you do with it, and it's independent of other objects from the same class. Amazing, right? So for example, if for some reason a greenish coin is more valuable in some weird world, we can set its value to 1.25. So coin1 dot value, let's say it becomes more valuable and it becomes £1.25. And we can see that coin1's value has changed, but coin2's value still remains the same at 1, which is amazing, right? Coin1 and coin2 came from exactly the same class, but now as objects they can behave independently. Awesome, so in this video we've created a class for a pound coin and given it some variables to represent object states. We also made several objects from that class and saw how to access and edit those object state variables. More importantly, we saw that the class is the template, but once you have the object, objects behave independently from each other. We made a lot of changes to each object states, but what if we wanted to make all of these changes to states happen automatically in one line of code? You know, to make objects a bit easier to deal with. Well, for that, we'll need to make class methods, which are up next. So I'll see you in the next video. Hello there, you beautiful people, and welcome to this video on class methods. Now, sometimes we want our objects to have certain behaviors, and class methods let us do that. For example, we might want to give our coins the ability to rust. That rusting behavior would be its own method. We might want to let our coins be flipped, which would be its own method as well. Now, in this lecture, we're going to learn all about class methods and making some to create some behaviors for our coins. In the process, we're going to learn all about class constructors and class destructors. These are special methods that let us set up and destroy our coins when we want to. So, by the end of this lecture, you're going to know all about class methods by making a coin that can rust. It can also be cleaned, it can be flipped and be spent, as well as learning about constructors and destructors. So we have a lot to do, so let's get into it. So at the moment, we have a very basic class. All it has is a few states, and we want to create some class methods. So to do this, we're going to need a constructor. And in Python, the constructor is defined like this. You type def for define, just like you would with any other function, and you use the init method. And the way that is, you go underscore underscore init underscore underscore, and then you put a pair of brackets like that. Okay, so and actually inside here you need to put the word self. Now, what this looks like is a function, but we have self as a parameter. And this is our constructor method. Now, what is this self? What's this self going on here? Well, self is what we use to refer to a specific instance of this class when we write the class code. So, for example, if we made coin1 using this class later on, inside the code, self would be replaced by coin1, the name of our instance. Okay. If we made a coin called coin7, when the code runs, self would be replaced by coin7. Note that it doesn't have to actually be self. This is just a convention. It could be anything. But I'm just going to be keeping it to self, and I recommend you do too, because that's basically what everyone else uses. Now, inside of our constructor, we're going to move all of these states that we've got inside of there. Use some tabs to knock them in. Okay, so now they are all inside of our constructor. But the thing is, we actually have to, we can't just leave them like value, color, num edges. No. What we've got to do is we've got to type self.value, self.color, self.num edges, self.diameter, self.thickness, and self.heads. So remember, if this was coin1.value is £1. Coin1.color is gold. And it doesn't matter what you call it, it's just that's going to help you set up your states regardless of the object's name. Okay, so by running through and setting up all these states, you're effectively constructing your object states. Okay, you're constructing and making your object work correctly. A constructor could have more than one parameter. For example, let's say it took a parameter called rare. Okay, it could take a parameter called rare, and that's going to be a Boolean that's going to be true or false to tell us whether the coin was rare or not. If the coin is rare, it's worth slightly more. And I'm going to say by default that's false. Okay, and in here I'm going to say, okay, self.rare is rare, and if self.rare, or if self.rare is true, it's exactly the same thing, then self.value is £1.25. Otherwise, self.value is just £1. Okay, so what's happening here? If we have a coin, well, let me show you. I'm just going to run all that. That's made our class. Okay, I'm going to take coin1, and that's going to be a pound coin. and its rare is going to be true. Okay, and I'm going to take coin 2, sorry, make it a pound, and it's rare. I'm just not going to do anything. Okay, is coin 1 rare? Yes, it is. Is coin 2 rare? No, it's not. What's the value of coin 1? £1.25. What's the value of coin 2? Just £1. So you can see by taking extra parameters when you define your class, you can change how it's set up. Okay, so our constructors helped us set up our object states and works in exactly the same way, really, as any other function. Okay, it's just got self at the beginning. And the only difference is that it actually doesn't return anything. You don't type return inside your constructor. Okay, it helps set up your class like this and just make sure you have the self dot. Okay, that's just the way that it is. Now let's say that we want a method that's going to make our coin rust. And when our coin rusts, let's say its color changes from gold to greenish, like this. So it'll change from gold to greenish. Okay, so let's set that back to be gold. So to create a method, we need to be inside the class, and we're going to come down here and type def rust. Now the first parameter to any class method has to be self, or whatever you decided to call it up here. Okay, we called it self, so self has to be down here. Now, okay, so make sure that is the same. If you don't put self in here, the code will fail and Python will tell you something's wrong. Okay, so now what we're going to do is if our thing rusts, then self.color is going to become greenish. Okay, and that's it. Nice and easy, right? So let's see this in action. I'm going to run this again, and I'm going to create coin 1, which is just going to be a normal unrare pound, and coin 2 is going to also be a normal unrare pound. Coin 1's color is gold. Coin 2 color is also gold. Now let's rust coin 1. What we do is we type coin 1 dot rust. Okay, we call the rust method on the coin 1, on the pound object, which is coin 1. Just like, for example, if we had a list, if we had a list 1, 2, 3, 4, and we do dot append, yeah, we say we want to append 5. Then if you look at that, well, that would do something, right? You're calling the list method. Likewise, now we're calling the pound method. We're calling the pound method called rust. So coin 1 dot rust. Now if we look at coin 1's color, we see that it's gone greenish, whereas coin 2's color is still gold. So what if we wanted a method that could clean our coins if they're rusty? Well, let's just go back in here and let's just make another method called define clean. Again, remembering to put self as the first parameter. Okay, and this is just going to send self.color equals gold. Okay, now we can show you what happens here. Let's make a coin 1. Now if I do coin 1.rust, that's going to change coin 1's color to be greenish. But if I do coin 1.clean, oops, I type coin 2. If I type coin 1.clean and I do coin 1.color, that's going to give us gold again. Okay, so the clean method is working as well. Alright, now we want to make our coin flip randomly. Okay, so you just, like, you know, when you flip a coin, it's going to give us a random value of heads. So for this, we're going to need to import the random library all the way at the top here. Import random. Okay, and what we're going to do is we're going to make a method down here called flip. Define flip. Again, putting self as the first parameter. Okay, now what we're going to do is we're going to have a list of choices or options, and that can either be true and it can be false. Okay, this is for heads. Maybe I'll call it heads options. Heads can either be true or it can be false. Okay, now to take a random choice of these, we need to do random. So let's say choice equals random dot choice from heads options, if I am correct. So that's going to just take a random choice of that. I need to spell options right. And now what we need to do, self.heads is going to be the choice. Okay, so let's run that. And let's create a coin again. Coin 1 equals a pound. So what's coin 1 heads? It's true. Okay, so it is on heads at the minute. Now if I do a coin 1.flip, and now I look at coin 1.heads, it's now false because now it's flipped to tails. And if I do coin 1.heads, flip again, and I look at the heads, it's now heads. Let's try again. Coin 1.flip, coin 1.heads. It's now false, but it won't always do this, right? It won't always go heads, tails, heads, tails, heads, tails. It will randomly flip in between the two. Okay, so that's working great. So finally, we want to allow our coin to be spent. Okay, now spending a coin from the perspective of our program basically destroys the coin object. Okay, so for this, we're going to need to use a destructor method. A destructor is called automatically when our program finishes and is used to destroy an object. And the Python destructor is called underscore underscore del underscore underscore. And you got to put self in there as well. So init up here is our constructor, and del is our destructor. And by the way, I could define the destructor up here. It doesn't have to be at the bottom. Okay, rightio. Now then, let's actually make this work. Okay, all we want this thing to do is to say coin spent. Okay, when the coin has been destroyed. Awesome. Now, how do we actually make this work? Well, let's go in here and let's create coin 1 again. It's going to be a pound coin. Now, all we have to do is use del coin 1, and that's going to say coin spent. And you can see now that coin 1 is no longer defined. The same will work for coin 2 as well, of course. If I set that equal to a pound, I can flip it, right? And then as soon as I delete coin 2, it's going to say coin spent, call the destructor, and coin 2 is no longer defined. We've spent and deleted our coin. Awesome. So we've now got a coin that can rust, it can be cleaned, it can be rare, it can be flipped, and it can be spent. What more could you ever want from a coin? So let's have a quick recap of all the cool stuff we've done in this video. In this video, you learned all about class methods. We started off by looking at the init method, which I'm just going to browse to right now. We started off by looking at the init method, and which we used as a constructor to construct our class's states. And it allowed us to do methods because we needed this self keyword here. So then we made our rust class method, which changed the color to green. We made a clean method, which changed the color to gold. And basically, what I want to get at with this is you saw the way that coin 1 and coin 2 could have different internal states to each other, right? One could be rusty and one could be normal, and it doesn't matter what the other one is doing. Now, this is the object-oriented programming principle of encapsulation, where your states can be encapsulated inside a bubble and hidden from each other. So we saw encapsulation as well. We made another class method that cleans it. We can flip it using the random module. What else did we do? And we also encountered the destructor, right? We encountered this del function here. So the del function, or the underscore underscore del underscore underscore, is our destructor. And the way that you call that is if you have a coin, say it's coin 1, you just type del coin 1, and that is going to delete your object by running the destructor method. So we've totally just modeled a pound coin in code. That's pretty epic, right? It's not bad at all. Well, the only issue is, what if we wanted to create all the other coins? Okay, what if we wanted the 1p, the 2p, the 5p, the 10p, the 50p, and the £2 coins? Well, as you can imagine, that would be a whole lot of typing if we did it the same way as we did here over and over and over again, right? Well, luckily, there's an object-oriented programming principle called class inheritance that's going to do a whole lot of this work for us. So in the next video, we're going to create all of these coins. That's right, in about 1 or 2 videos, we're going to create all of these coins and learn about the other object-oriented programming principles of inheritance and polymorphism, which are super cool. So I'll see you in the next video. Hello there, you beautiful people, and welcome to this lecture where we're going to be making all the coins. And in the last project, we made a £1 coin, but in this project, we're going to make all of them. That's right, the 1p, 2p, 5p, 10p, 20p, 50p, £1 and £2 coins. They can all rust, they can all be cleaned, they can all be flipped, and they can all be spent. Now that sounds like quite a lot of work, right? Well, it's not actually. Well, not when we use the object-oriented programming principles of class inheritance and polymorphism. And by the end of this lecture, you're going to know what they are, and you're also going to know about abstract classes, parent classes, and child classes, as well as seeing about how to use packing and unpacking that we covered in the last few lectures, how to use those in the real world. So let's go. The first thing we can notice is that all coins work pretty much exactly the same way, right? They all have a diameter, they all have a number of edges, they all have a color, they can all be heads or tails, etc. They can all rust, they can all be cleaned, and they can all be flipped. So instead of making that stuff just specific to the pound class, we're going to make a generic or abstract class called coin, and then every other class gets to inherit abilities from that general abstract class. So let me show you what I mean. So right at the top here, I'm just under the import statement, I'm going to make another class, and I'm going to call it coin, okay? And I'm going to put a constructor in there. I'm going to say define init self, and I'm going to give it two parameters, whether the coin is rare or not, that's going to be default false, and whether it's clean, and that's going to be by default true. So let's set our rare and clean values. Self.isRare equals rare, and self.isClean is going to be equal to clean. Now we have a little bit of an issue. When a pound coin is rare, we've said that its value becomes £1.25, but not all coin values will become £1.25 if they're rare. So what we can do is we can say the value of the coin will become 25% more than what it was originally if it is rare. So let's do that. If self.isRare, then self.value equals self.original value multiplied by multiplied by 1.25, and this is just going to give us 25% extra. So otherwise, if it's not rare, then self.value is going to be self.original value. Okay, but what is this original value? Well, we haven't defined it yet, but you'll see where that comes later on. And we've also got a similar issue for cleanliness. If the coin is clean, we can't just say it becomes gold, because not all coins are gold, right? Some are silver and some are bronze. But what we can say, however, in this general class that's going to work for everything, what we can say is that if the coin is clean, then the coin's color becomes its original color. But if the coin is rusty, then the color is the rusty color. So let's do that. Let's make another if statement. If self.isClean, right, then self.color is going to be self.cleanColor. And we're going to say otherwise, self.color equals self.rusty color, okay, if it's not clean. So there we go. So what are clean color and rusty color? Well, we haven't defined those yet either, but we'll come to them, I promise. So for now, let's just copy over our class methods. So first of all, we have the rust method down here. I'm just going to copy that. But one thing we need to bear in mind is that, by the way, if you're following along, make sure that your methods aren't inside one another. You need to have them outside. Now, we can't really say that when every coin rusts, it's going to go greenish, right? Because not all coins go green when they rust. However, what we can say in this general case is that when a coin rusts, its color is going to become its rusty color for that coin, whatever that might be. So self.color is going to become self.rusty color, whatever that is. We're going to define the rusty colors later. Now, what about the clean method? Well, again, we can't, because this is a general class, we can't say self.color is going to become gold. And the reason we can't say that is because not all coins are golden when they're clean. But what we can do is we can say the color becomes its clean color. So define clean self.color is going to become self.clean color. whatever that clean color might be for that coin. Okay, great. Now what about the destructor? Well, fortunately, that's going to work the same for all coins, so I can just copy and paste that straight over. All coins, when they're spent, are just going to be spent. It doesn't matter what type of coin they are. So that was a nice and easy one. And the same actually goes for the flip method, because every coin, no matter what, it's going to be flipped the same way, right? It can either be heads or tails. So let me just copy and paste that. Okay, we're going to just paste that in there. Define flip, heads options is going to be true or false. You can take a random choice of that, and self.heads is going to become that choice. One thing I am going to add, however, is just another default parameter up here. I'm going to say heads, it's going to be by default, it's going to be true, and self.heads is going to be heads. So they can choose whether that coin is going to be heads or tails or not. Okay, great. Now that we have our general class, what we're going to do is we're going to delete what we have inside the pound class. I'm just going to delete all of that. Okay, actually, well, delete didn't work. Even Python doesn't want us to get rid of it. Okay, there we go. Now what we're going to do, we're going to make this pound class inherit from the coin class. So we can put coin in parentheses here. Okay, so we're saying we're going to make a class called pound, and it's going to inherit from its parent class called coin. And can you see how just reading that makes sense, right? Class pound coin, right? The pound is what's different, but the fact that it's a coin stays the same. Awesome. Now, when something inherits from another class, so pound is now inheriting from coin, it's going to get the flip method, it's going to get the del method, it's going to get the clean method, it's going to get the rust method, and it's going to kind of get the init method. By default, it kind of just takes all that's in there and pastes it into itself. That's called inheritance, okay, which is totally awesome and saves us a lot of copying and pasting. But we still have some weird stuff lying around, right? What's this rusty color and this clean color and original value business that we've got going on here? Well, those values are specific to each type of coin, right? So what we're going to do is we're going to give our coin, our pound coin, a dictionary of data and store all of this data about the coin, the specific data about a pound. So what I'm going to do is I'm going to make a constructor inside of our pound coin. And in here, I'm going to make just a dictionary called data. Okay, just a normal dictionary. And what I'm going to do is I'm going to say, okay, original value is 1.00. Its clean color is going to be gold. Its rusty color is going to be greenish. Its number of edges is going to be 1 because it's a circle. That needs to be a comma. Its diameter is going to be 22.5 millimeters. Need a comma. Its thickness is going to be 3.15 millimeters, and its mass is going to be 9.5 grams. Okay, so we've now got this dictionary of data for the pound class. Now, what we're going to do, well, what we can see here is the original value for the pound coin is £1, right? Its clean color is gold. Its rusty color is greenish. It's got 1 number of edges, and all this stuff. We've got all this data. Now, here's the tricky part. We want to use the parent class, all this, to set up everything else. Okay, everything else for the pound coin, but we've just got this data. So instead of writing self.original value is 1 and self.clean color is gold and self.rust color is greenish or whatever in every child class, we just want the parent class to take care of all that. So what we do is we go inside the init function for each small class or each child class, and we run the parent's init function and pass it this dictionary. So let me say that again. First, our class's init function is going to run. Okay, we're going to create a pound coin. All this is going to run. It's going to make this data thing. Then inside our init function, we're going to get the parent's init function, the parent's constructor, to do the rest of the setup, because the only thing that's specific about each coin is its data. And then we're going to call the generic class to set up everything else. Okay, so we're just going to pass all this data into the parent's init function and let it deal with the rest. So to run the parent's init function, we need to access the parent class. And to do that, we use the super function. So super, like that. Now a super class and a parent class are the same thing. So super just means the parent class. And in this class, we want to run the init function or the constructor and pass all our data as keyword arguments. So original value equals 1, clean color equals gold, rusty color equals greenish. Okay, and how do we do that? Well, what we do is we unpack the data, okay, from this dictionary into keyword arguments. And if you remember about packing and unpacking that we did in the function section of the course, this is where we'd use it. So what this is going to do is it's going to run the coin class constructor and pass it original value equals 1, clean color equals gold, rusty color equals greenish, num edges equals 1, diameter equals 22.5, thickness equals 3.15, and mass equals 9.5, okay? All as keyword arguments. Now, what we need to do is let the parent class be able to accept all that data. So we're going to go at the top here, and we're going to pack down all that information into keyword arguments called quargs. Okay, and I think that's the right place to put it. I'm pretty sure. So let's just leave that there, put the quargs right at the end. And what this is going to do is it's going to take those keyword arguments and pack them down into a dictionary called quargs. So what we've done is we've got a dictionary of data here, and we packed it down and put it in the function as keyword arguments. We unpacked it, sorry, and put it as keyword arguments, and then we packed it down back into another dictionary called quargs. Now, as with any constructor, we need to do all this self.original value equals blah, self.rusty color equals blah, self.diameter equals blah, clean color is blah, whatever. Now, the way that we do that is we loop over those quargs, those keyword arguments. We're going to say for key, comma, value in quargs.items. Keys is going to store the keys in the dictionary, and value is going to store the values. And we're going to use the set atta, short for set attribute, or set state, basically. What we're going to say is self, key, and value. So let's say if we sent into it original value 1, this is going to make the code self.original value equals 1. And this is a really beautiful piece of code, because we could send in as many as we wanted. This data could be as complicated as we wanted, and it's going to set up all of the states for us just like that. So what this is going to do is it's going to loop through all of the items. Let's say the first item has the key original value and the value of 1. The key is going to become original value, the value is going to become 1, and set attribute is going to basically write self.original value equals 1. Okay, that's what it's going to do. If it said thickness, it's going to say self.thickness equals what is it going to say, 3.15. Okay, but the thing is, it's done it in a flexible way that we don't need to worry about passing in or typing it out ourselves. And this is going to work in general for any dictionary that you pass in. So we've now taken care of all the variables here that we haven't defined yet, like clean color and rusty color, and our classes should work. So that's pretty much it. So let's see this work for a pound coin. So let's run this. We're just going to run this code, and that's worked fine. Now let's make a £1 coin and make that a pound. Now you can see that that's worked, right? So let's have a look at the color. Let's just see the £1 coin. dot color, and it's going to say it's gold. Magic. Okay, let's rust it. £1 coin dot rust, and now look at the color. Now it's greenish. Amazing, right? So even though we defined the rust function all the way up here, this is the only place that we see the rust function. And it's very general. Your color is going to become your rusty color. If we go in the pound coin, there's no such thing inside the pound coin as rust, but it inherited the method, and we gave the rusty color and the clean color to the constructor, which then did all the setting up that was required for us. So how cool is that, right? So for a new coin, we only need this much code. And that's exactly what we're going to do in the next video. We're going to set up all of the other coins using exactly this thing here. And well, then by the end of it, we should have our own set of coins, all with their own different variables and their own different bits of data. So for that, I'll see you in the next video. Hello there, you beautiful people, and welcome to this lecture where we're going to be finishing up this All the Coins project. So in this video, we're going to make the rest of our coins and learn about polymorphism, which after inheritance, abstraction, and encapsulation is the final principle of object-oriented programming. So we're going to be using polymorphism to change little pieces of a coin's behavior and allow some coins to rust and others not. And finally, we're going to make a demonstration of all that we have and take one of each of the coins and print out data for them in a nice table that you can show your friends or anyone that's interested in looking. So by the end of this lecture, you're going to know about the final principle of object-oriented programming, polymorphism, and you also have a nice shiny set of coins to buy some chocolate with. So let's go to it. Alright, so we've pretty much done all the work really. All we need to do is copy and paste this code for the pound coin and change some data to make each coin specific. So let's start at the bottom with the 1p coin and just copy and paste our pound coin class. So I'm just going to make some space up in here, paste in there, and I'm going to call this 1 pence. And I have to spell it like that because I can't type the number 1 because you're not allowed to start classes with a number. So I actually have the data already pre-written. So if I can just find where that is, here we go. So I've got this data dictionary here. I'm just going to take that and I'm going to remove this from here, paste that in there, and there we go. So if that is done correctly and indented properly, that should be fine. So this is for a 1 pence coin. And you can see that the value is 0.01. The color is bronze. When it goes rusty, it goes brownish. Okay. And all other data has been changed as well. So I got this data from the Royal Mint website, so it's pretty accurate. Like that matters. But anyway, next comes, that's it, right? That's all we need for another coin. And now let's do it for the 2 pence coin. So let's just paste this information again for the 1p coin. It's another class. We're going to call this the 2 pence coin. And we're going to go back to my stuff here. We're going to take the data from in there and go back to our Python script. Delete the data. Just paste that in. Okay, and make sure the indentation is correct. Okay, so that's that. I mean, that's another coin. Can you see how quickly we're making coins now that we've set up the structure correctly? Okay, let's go with the 5 pence coin. So I'm going to copy and paste this. And I'm going to change some of the data in the 5 pence coin to the 5 pence coin values. Here we go. Get that there. Okay, now there's something interesting about the 5 pence coin. Okay, and well, any silver coin really. You can see that the clean color is silver. We need to override the standard behavior for the rust and clean methods because 5 pence coins and silver coins don't rust. Okay, so we just need to override the standard behavior that we're getting from our parent class. And this, when you override some behavior, when you have a function with the same name, and we're still going to have rust, right? It's just going to do something different. And when you do that, when you have a function, the same function name, but it has different forms, it has different shapes, it has different versions of itself, That's called polymorphism in object-oriented programming, because poly means multiple, morph means form. So when a method has multiple forms inside a class, that's polymorphism. Okay, so the way that we're going to do it, we're going to override the Rust class in the parent, which is up here. We're going to override it so that it says self.color equals self.cleanColor. Okay, so it's not going to happen. We're not going to have, even if it rusts, you're still just going to set it back to the clean color. Okay, and I'm going to do exactly the same for clean. So self.color is going to be self.cleanColor. I'm not sure if I even need to do that because it's actually already inherited that. Okay, so I'm just going to leave it there anyway, but it's not necessary. And that's what polymorphism is, you guys. So that's it for the 5 pence. We've got, all these coins have rusting and cleaning methods, right? But we've just defined a new version for the 5 pence coin. And I actually need to call it 5 pence. Okay, 5 pence coin. That's better. Now we're going to move on to the 10 pence coin, which is another silver coin. So we're just going to keep this the same value. So where's that gone? There's 5 pence. Okay, this is going to be the 10 pence coin. And I'm going to copy and paste the data for the 10 pence coin, which is over here. Okay, where's our thing? There it is. Okay, and I'm keeping the rust and the clean with the overridden versions. Now I'm going to get the 20 pence coin. 20. Where's it gone? 20 pence. 20 pence coin. Take the data for that, and you can see this is it's just repetitive, right? I mean, but we're making completely different objects, but because we've set them all up in a nice and easy to use way, now it's just copy and paste, isn't it? So let's just get rid of the data. There you have it. Okay, so we've now got the 20 pence coin. Now for the 50 pence coin, let's just copy and paste this. And here, this is it. 50 pence coin, right? Yep. So let's just go and copy and paste the data for that. We're nearly there. Nearly there now. So there we go. There's that. Okay, we've now set up our 50 pence coin. The final one is our £2 coin. So because that can rust, in my version of it anyway, we're going to just copy and paste the pound coin again. Call that £2 coin. And actually, our class names should start with capital letters. So I'm just going to edit that. 1 pence in capital. 2 pence in capital. 5 pence in capitals. 10 pence in capital. 20 pence, 50 pence, pound, and I'm going to call that the £1 coin, and then we're just going to have the £2 coin, and I'm just going to copy and paste the data for the £2 coin, which is in here. Copy and paste, and make sure the indentation is right. And there we are. There we have it. So now we have 1, 2, 3, 4, 5, 6, 7, 8 objects, as well as a parent class here. Well, 9 classes in total. And just by setting up an abstract class, one that's really general, all we've got to do now is just give a different dictionary, and we actually have completely different behavior for all of these things. So let's watch this working, shall we? So let's right down the bottom here, let's make a list of coins, and in our list of coins we're going to have one of each type. So we're going to have 1 pence, we're going to have 2 pence, we're going to have 5 pence, we're going to have 10 pence, we're going to have 20 pence, we're going to have, and actually what I can do is I can break the line there, we're going to have 50 pence, can have £1, and we're going to have the £2 coin. Okay, so now what we're going to do, we're just going to loop through each of those coins. So for coin in coins, what we're just going to show some information about it. So the arguments that we want, or the stuff that with the information that we want the coin itself, we want the coin color, we want the coin value, we want the coin diameter, and we want the coin thickness, and the coin dot number of edges, and the coin mass. Okay, now we've got our own list of that stuff. Our string is going to look like this, the string that we're going to print out. Value is going to be this, and diameter in millimeters is going to be something else, and the thickness in millimeters is going to be something else, and the number of edges is going to be something else, and the mass in grams is going to be something else. And that's that, okay? But now to set this text up, what we're going to do is we're going to format. Now, are we going to put in like a load of parameters? Are we going to put in coin.color, coin.value, coin.diameter, coin.thickness, coin.edges, coin.mass? No, we're not. What we're going to do is we're just going to unpack the arguments, and that's going to put them as parameters in there. Okay, so that's where we'd use unpacking in a in format. Okay, so that's going to make that nice string for us. Quite a long line, but we'll deal with it. Okay, and then we just want to print out. So what we want to do is just now print out this string for each of the coins. Okay, now it's going to be ugly, but watch this. Wow. Okay, so we're pretty much there, right? I mean, that's very nice in the sense that we're getting the color, the value, the diameter, and all this stuff for each of them. But what the heck is this, right? That's just ugly. Well, that's what happens when you just, and I wanted to show you this. You can see here the first value that we are printing the coin. Okay, if you print a coin object, this is what you get. Well, that's what's coming out here. How can we tidy this up a bit? Well, there is a way, and it's using another special method. So let's go all the way up to the top here at the coin level, in the coin class, and there's a special class called str. Okay, now what this does is $_str$. This defines what comes out when you print that object. Okay, now we want it to basically say, if it's a 1p coin, it needs to say 1p. If it's, it needs to say 1p coin or something like that. And if it's 10p coin, it say 10p coin. If it's a £1 coin, it needs to say a £1 coin. So how do we do that? Well, first of all, it's going to look like this, isn't it? It's going to return a string. It's going to say like 1p or £1. Okay, so the way that we're going to do it is we're going to take a value, and if the value of the string of the coin self dot original value, right? If the original value of that coin is over £1, then what we're going to do is we're going to return a string that says that value coin. Okay, and we're going to format that with the integer version of the value, because we don't want it to say £1.00 coin, we just want it to say £1 or £2, and that needs to be greater than or equal to 1. Okay, but if it's less, that needs to say if, doesn't it? But if it's less, then what we're going to do is we're going to return, say if it's 1 pence, right? The value is 0.00 like this. We don't want that. We want to times the thing by 100 and put a pence there. So like that. Make it all capital as well. So it says coin. We're going to format in there the the integer version of self dot original value times 100. Okay, now that's going to define how it's printed. Now if I run this, we're going to see it says 1p coin, 2p coin, 5 pence coin, 10 pence coin, 20 pence coin, 50 pence coin. Then when we get to a value over or equal to 1, it's going to say £1 coin, £2 coin. Now I'm just going to zoom out just a little bit, configure idle, change the text to say, I don't know, like about 12. Hopefully you guys, oh, it's a bit small. What about 16 or something? Maybe we can do a bit better than that. Let's just say 20 then. Is that good enough? No, that's too big. Goodness gracious. 18. Go for the middle. There we go. Okay, so now you can see that we've got all of these coins. We've looped through them. We've printed out the type of coin, the color, the value, the diameter, the thickness, the number of edges, and the mass. And you can see that there's different values for all of these different coins. Each one of them is its own class. Each one of them is its own object as well, because these are actually the object values that we're printing out here. And, you know, we've really done a lot in this project, that's for damn sure. The main thing we got from this lecture, however, was polymorphism, right? You saw how you could have one object, one parent class at here, the class of coin, with its own functions and stuff inside, and then you could override the functions for some of the children classes. That's called polymorphism. And is that all the OOP is for? Is that all we can do with it, making coins? Well, of course not, right? You can make loads of really complicated things, and most of modern programming is based on this, to be honest with you. So in the next project, we're going to apply what we've learned in this project, because some of it might still be a bit vague. You're not really sure where it fits, right? It's all come kind of as a blur. So in the next project, we're going to make a bank. And it's actually less complicated than this example here with all these coins. It's quite a lot less complicated, but it's going to serve as a good recap of everything we've learned in the course so far. So for that, I'll see you in the next video. But you've got a lovely set of coins you've got here, so make sure you buy yourself some chocolate. Hello there, you beautiful people, and in this video we're going to make a bank. We won't introduce anything new here, really, but it's nice to have a fresh example, you know, away from all those coins, to help all those complicated concepts from object-oriented programming to stick in your mind, so you can see it afresh. Now, the way that we're going to do this is to create two types of account, a current account and a savings account, and both of these are going to inherit from the account parent class, because most accounts pretty much work the same way, right? So each account can deposit and withdraw money, and it can also print you a statement. However, each account will have different minimum limits. The current account will have an overdraft of 1,000, and the savings account won't have an overdraft at all, just like real life. So that's pretty cool, right? And by the end of this video, hopefully those OOP concepts, or those object-oriented programming concepts that you've come across, will sink in a bit deeper, and you'll have a really cool program to show off as well. So let's get into it. Hello there, you beautiful people. So the first thing I'm going to do, I'm going to create a new script called bank.py. So save that, desktop, Python Bible, bank.py. Save it, maximize it, and we're good to go. So first of all, let's create our abstract parent class. The first thing we're going to need is a simple constructor, and this is going to take a name, you know, the name of the account holder, a balance, and the minimum balance for the account. So we're going to make a class of account. I'm going to define the constructor right here. We're going to take the name, balance, and minimum balance. Now bear in mind, this is for any account, right? This is just a general account class. What behavior do all accounts have? Okay, so the name of the account is going to become that name. The balance is going to become that balance. And the minimum balance is going to become that minimum balance, whatever goes in there. All right. Now, each account can deposit money. So let's make a method for that. Define deposit, self, and you just deposit an amount, right? Okay. So what's going to happen is self.balance is going to become self.balance plus that amount. Now, a shortcut for writing this, you can see the way that self.balance appears twice. It's a bit of a mess, okay? So what we can do is we can just write self.balance plus equals amount. And that is exactly the same. It's going to say self.balance is itself plus amount. It's a nice shortcut. You might want to keep on. You might want to keep hold of that. So that's that. Now each account can also withdraw money, but only if you have enough, right? So let's make that method. Define withdraw. You need to put self as the first parameter, and again you're going to withdraw an amount. Now if self.balance minus the amount that you're going to withdraw is greater than or equal to your minimum balance, then you can subtract it. And I'm going to use that shortcut again. Self.balance minus equals amount. Okay, if you're not comfortable with this, just go back to using it the old way, but it's basically the same thing. And if it can, then it's going to do it. Otherwise, it's going to say, it's going to print to you, sorry, not enough funds. Okay, so that's that. That's the withdraw method. Nice and straightforward. And the final thing that all accounts can do is give you a statement. So let's create that. Define statement. We're going to put self. And all this is going to do, it's going to print account balance, put the pound sign. Goodness me. There you go, pound sign. And format in there self.balance. Okay, so there's that. Now, that's our general behavior sorted. Now, that was pretty easy, right? I mean, we've now got a deposit where I give it an amount and it's going to add that amount to the balance. You can withdraw a certain amount, but only if you've got enough. Otherwise, it's going to tell you can't. And if you ask for a statement, it's going to say the account balance and then give you the balance. So now we need to just make our current account. So we're going to go down here, make class current, and get that to inherit from account. All right. Now let's create our constructor in there. We're going to define init self name balance. Okay, so these are the options that someone is going to be given. These are the parameters they have to enter to create a current account. Okay, not these ones, not these ones, these ones. Okay, now what we need to do now is to pass that data up to this account. So what we're going to do, we're going to call the super method, the init function init, and pass that the name we just got, the balance we just got. And because this is a current account, we know the minimum balance is going to be minus 1,000. We're going to give them an overdraft of minus 1,000. An overdraft of 1,000. Okay, so what happens here? Basically, whenever you create a current account, say I have a current account and I'm going to call it X. I'd write current. My name would be Ziad, and my balance would be, I don't know, let's say 500, right? Name is going to become Ziad, and balance is going to become 500. We then pass Ziad in here, is what's going to happen. Balance is going to become 500. And minimum balance is minus 1,000. And that's going to go up into here. So this is going to become Ziad. This is going to become 500. And this is going to become minus 1,000. Okay. And then the name for this instance called X is going to become that. The balance for X is going to become this. And the minimum balance is going to become that. Okay. And it's going to get all these methods as well. Okay. So that's how that works. So let me just put it back to how it was working before. I'm just going to undo everything pretty much. Okay. Put that there. Undo. All right. So now I'm going to give myself £500. Okay. So we've managed to create that. So let's just show you this working. Okay, I'm going to run this. Hopefully it's working fine. And it got an unexpected argument, minimum balance, probably just a misspell. So let's go back in there. See, it says here min balance. I passed it minimum balance. It should just be min balance. That's going to fix itself. Okay, so if let's make a... actually, let's just get rid of this in here. Let's just make an account. Run this again. Make an account Z equals current. I'm going to call it Ziad and put in 500. Okay, now let's deposit £300. I do Z.deposit £300. Now that should put me at £800, right? So let's look at our statement. Z.statement. It tells us the account balance is indeed £800. So what if I withdraw 1,000? Z.withdraw 1,000, and I need to make sure that this is uppercase. Then I look at the balance or statement. It's going to tell me I'm minus 200. Okay, what if I withdraw another 800? It's fine so far. Cool. Now if I withdraw another one. Sorry, not enough funds. And the reason is because we're at the minimum balance of minus 1,000, which is exactly what we expected to happen. Now, one more thing I want to show you is if I print Z, we get this ugly text again, right? Current object, it's just horrible, right? This is the hexadecimal memory address. It's just not the one. We want a bit more of nice text than that. So the way that we can do this is we can, in here, define a string function. And we're going to say, in here, we're going to say return someone's current account. Balance, and I actually put a colon there, balance is something else. And we're going to format in there the name, self.name, and self.balance. Now if I show you this again, let's run that. Let's create my current account again, and then print my account. Ziad's current account, balance 500. Much nicer than this rubbish, okay? So that's why you use the str method. Now, what we've got next, we've got the savings account. Okay, so for a savings account, we just need to create another class. So class savings, and that's going to inherit from account. We're going to define our constructor. Self name balance. Fabulous. And we're going to call the parent constructor to do all the setup that we don't want to have in each class. We're going to give it that name. We're going to give it that balance. But this time, the min balance is going to be 0. Okay? Because you can't go less than 0. And we are going to, that should be that. And then for this print function here, this str, it's going to take that, paste that in, make sure it's got the right indentation. And instead of just saying so-and-so's current account, I'm just going to say so-and-so savings account. Beautiful. So now let's make another account. We can make a current account for me, and we're going to make a current account for someone called Tom. Savings account, sorry, for someone called Tom. And Tom is going to be on 300. Okay. So now if we print T, then Tom's savings account balance 300. Fabulous. So if we withdraw 300 from Tom's account, okay, now if we look at his balance, T.statement, we see he's on 0. If I try to withdraw just one more, it's going to say, sorry, not enough funds. Whereas if we look at my account's on 500, I can go all the way to negative 1,000 because it's a current account. So I can do withdraw of 1,500. And now I'm on minus 1,000. And if I just withdraw one more, it's going to tell me that I don't have enough funds. So there you are. It's actually simpler to make a bank with bank accounts and stuff like that than it is to make a bunch of coins. Believe it or not, what a mad world we live in. Anyway, while I didn't show you anything new here, I hope that was useful for making you feel more comfortable with how classes and objects work. as I know for me it's useful when I see and follow through another example. In the next video, we're going to have a review of this section of the Python Bible and go over what we've learned about OOP in Python. So I'll see you in the next video. Hello there, you beautiful people, and welcome to this review lecture for this section on object-oriented programming. So we're just going to go over a few things just to make sure that you've got everything, and hopefully you'll feel a lot more comfortable with classes by the time that we finish. So the first thing that we learned was that classes are templates for objects. When you create a class, you're basically creating a template for all the objects you're going to make later on, just like when I mentioned the analogy of a factory of coins. Each coin is an object, but there is a mold somewhere in the factory that helps you create these objects. Now, objects, just like in the real world, have two things. They have states and they have methods. In your class, you use variables to create the states, and you use functions or methods to create the behaviors for your objects. We jump right in and we created our very first object and a class, which was a model for a pound coin. We learned about how you can access the states of this object by using the full stop syntax. So for example, if we had an object called coin1 or an instance called coin1, coin1.value would get the value of the coin, and you could change these states as well. You could say coin1.color equals green, for example, if you wanted the coin to rust. But then by doing it in that way, we found it was good for one-off things, but it was a bit tedious if we wanted to change a lot of our states, or we wanted to change our states in a very repeatable fashion. A better way to do it is to create class methods, and we created class methods that could rust, clean, and flip our coin. But in order to have class methods, you need the Python constructor, which is the _init function, and we use this self syntax to refer to the current instance. Once we set up all of our methods, we wanted one more that could model the coin being spent, and that would remove the object from our code. For this, we needed to use a Python destructor, which is what gets rid of a class. And the destructor in Python is the _del_self, this kind of thing going on here. And if you want to use the destructor, you just type the del keyword and then the name of your instance to get rid of the coin, and it would run the destructor function. But now that we'd made one coin, we wanted to see how we could make all the other coins. Okay, there's quite a few coins, isn't there, that we went through. But we wanted to do it without having to copy and without having to basically just retype all of the code again. So this is where we learned about the object-oriented programming principle of inheritance, where you can have one big, powerful parent class that is going to have a lot of stuff already defined in it, and you've just got to put the stuff from your mini child class into the big parent class, just where it might be different, and let the parent class take care of the rest. So we made an abstract coin class that would do most of the work for any coin, and that worked great, except for when we had some of the coins, like the silver coins, like the 5p and the 20p, which actually wouldn't rust. And what we did was we used polymorphism to override the rusting behavior for those coins, so we could stop those specific coins from rusting. Now, polymorphism is where your methods have a different form, but they have the same name. And inheritance is where you get access to the functions and the variables that are in your parent class. After that, we made our very own bank. And what we did was we made a bank account. So you had your current account and your savings account, and these inherited from the superclass, which was just a general account, just a very average account. And we gave in again the specific data that made the difference between a current account and a savings account, which in this case was the overdraft. And when we printed out these, when we put one of these instances or one of these account objects in the print function, we saw that it came out quite ugly. So I taught you about the str method that allows you to control how the output looks like when you print an object. And that was it, to be honest, you guys. How awesome do you feel now, right? I mean, a few sections ago, you started off by typing out numbers, and now you've made a bank. So I bet you feel absolutely amazing, right? If you followed through and grasped all this, and well done. So, in fact, for now, until I put some updates up, this is the final chapter of the Python Bible. Now, don't cry. Don't cry. In closing, I just want to say that it's been an absolute pleasure to teach you. And if you followed through the course, you understand it, and you've been practicing as you've been going along, your level of progression has been absolutely phenomenal. And you should be unbelievably proud of yourself. I know I am. I know I'm so proud of you if you followed through with me through this roller coaster of a journey we've been through. Now, I've loved every single minute of making this course, and it's my honor to have you as my student. And I just hope you've enjoyed it, even a half of what I have making it. So I just, once again, like to say thank you for choosing to learn with the Python Bible. Thank you for learning with me, and I wish you all the best in programming with Python in the future.